any question, please raise your hand and wait to be recognized by me. I will make all rulings on the admissibility of exhibits, appropriateness of questions, and pertinence of proffered testimony. Mr. Ben Allen, who's seated behind me, will provide legal assistance. All such rulings will be final. I'm now going to turn it over to Ms. Shaw, but I do want to just remind witnesses from yesterday's proceedings that you are not yet excused from this proceeding, and you could be recalled at any time during today's proceedings. Thank you very much. Ms. Shaw.
Thank you, Chair Homendy. If you've not already done so, please silence your electronic devices. Please plan for a 15-minute morning break at 11 a.m. and a lunch break from 1 to 2. The 15-minute afternoon break will occur at about 3:30. Please be advised that these proceedings are being streamed live and video recorded. The video will be posted publicly to the NTSB YouTube channel following the hearing. The exhibits for this hearing are in 9 separate groups. The exhibits are identified by group and number. Group A are administrative exhibits and witness biographies used to pre-qualify witnesses who will testify in this hearing. Group B are the NTSB Group Chairman's factual reports. Group C are exhibits related to the first panel, which was on hazard communications and emergency responder preparedness for the initial emergency response. Group D are the exhibits that were related to Panel 2, circumstances that led to the decision to vent and burn 5 vinyl chloride tank cars. Group E are the exhibits related to today's Panel 3, wheel bearings and wayside defect detectors. And Group F are exhibits that were related to this afternoon's Panel 4, rail tank car safety. Group G are NTSB introduced interview transcripts. Group H are party introduced exhibits, and where you can also find the opening statements provided today. And finally, Group M is reserved for other miscellaneous exhibits. The NTSB is authorized by statute to disclose information to carry out its mission, but we protect confidentiality and proprietary information to the greatest extent possible. As such, the exhibits contain redactions. These are the result of negotiations between the parties and the NTSB regarding the disclosure of information claimed to be personally identifiable, security sensitive, or proprietary in nature. Though redacted, the exhibits contain sufficient information so that members of the public can refer to them during the hearing and throughout the NTSB's investigation. The exhibits entered into the record and any presentations along with other records of the investigation become a part of the NTSB's public docket and are available on our website, ntsb.gov. The public docket did open yesterday. Party spokespersons and witnesses have been provided electronic copies of the public docket containing the exhibits that we've described. The docket is located on the East Palestine investigation page, which you can access in one of 2 ways: by visiting ntsb.gov/East Palestine, or if you have joined us in person, you can scan the QR code on the back of the hearing agenda. On the investigation page, you will find a link to the public docket just above the map. A transcript of the testimony taken during the hearing will be prepared and entered into the docket as soon as possible. In addition, Mr. Allen will keep a list of any documents that are discussed during the hearing that are not currently exhibits in the NTSB public docket, and these documents will be submitted after the hearing and again entered into the docket. Additionally, the parties will have the opportunity to submit proposed findings of fact, conclusions, and recommendations to the Board of Inquiry after the close of the hearing. Their submissions will also be made a part of the public docket and will receive careful consideration during the board's analysis of the evidence and preparation of the final report. We encourage the parties to make use of this opportunity. Please note that the submissions must be sent to the NTSB within 30 calendar days of the closing of the hearing by July 24th, 2023, and the parties must also provide copies to each of the other parties as well. We're now ready to begin Panel 3. Chair Homendy, this panel will address wheel bearings and wayside defect detectors. Specific topics to be addressed include freight car wheel bearings, Wayside Defect Detector Systems, and the ATC. Witnesses for Panel 3 are composed of the following individuals: Michael Rush, Association of American Railroads; Jared Hopewell, Norfolk Southern; Hans Ewand, Engineering Systems, Inc.; Christopher Hand, Brotherhood of Railroad Signalmen; Jason Cox, Transportation Communications Union, IAM; and Dr. Constantine Tarane, University Transportation Center for Railway Safety at the University of Texas, Rio Grande Valley. The NTSB technical panel is composed of Joey Ryan, the panel chair; Ruben Payan, investigator in charge for the East Palestine investigation; Dr. Ann Garcia, Gregory Scott, Adrian Lamb, and Abe Aronian with TSB Canada. I would now ask that the witnesses please stand to be sworn in. Please raise your right hand. Please answer by saying, "I do." Do you swear or affirm that the testimony you will give in this hearing will be the truth, the whole truth, and nothing but the truth? You may be seated. Thank you. As a reminder, all witnesses will remain under oath until the conclusion of the hearing this afternoon. Chair Hamady, these witnesses have been pre-qualified, and their respective experience and qualifications appear in the docket as exhibits in Group A. As a reminder to the witnesses, please push the microphone button to talk and then push it again when you are finished. Please answer the questions factually and avoid analysis. I'll now turn the questioning over to Mr. Ryan.
Thank you, Ms. Shaw. We have opening statements from 4 of our witnesses. We will start with Mr. Rush with the AAR.
Chair Hamady and members of the board, thank you for the opportunity to appear here today on behalf of the Association of American Railroads. For those of you in the audience who might be unfamiliar with AAR, it is a trade association representing large and small freight railroads, as well as passenger railroads. The February 3rd derailment is a stark reminder of the railroad industry's responsibility to the communities in which railroads operate. The railroads are taking what happened here with the utmost seriousness. Each of AAR's member railroads share the same mission to safely serve communities and customers across the nation. Each train trip is an opportunity for railroads to apply lessons learned to further enhance safety. AAR helps its members collectively do just that. As an organization, AAR sets standards for rolling stock. The rail cars and locomotives that travel from one railroad to another. These standards address the safety and interoperability of railroad equipment, exceeding what is required by regulation. The railroads also spend millions of dollars annually on research to make the industry safer at AAR's research subsidiary, MXV Rail in Colorado. Indeed, it was AAR's subsidiary that developed the first acoustic bearing detector. The railroad industry's recent safety record is excellent. This record was built through years of work and investment in employee training, infrastructure, and technologies such as wayside detectors. The railroads have driven risk down across every facet of railroad operation. In 2022, the Class 1 mainline accident rate was the second best in history, according to Federal Railroad Administration statistics. In addition, the rate of mainline accidents on Class 1s attributable to equipment failure was also the second lowest in history in 2022. With respect to the transportation of hazardous materials, the railroad accident rate is far lower than the rate for trucks. Over 99.9% of hazardous materials shipments by rail arrive at destination without a release. The February accident focused attention on overheated bearing detection, which has come a long way since railroads voluntarily tested, developed, and deployed hot bearing detectors nationwide. In 2022, there were 13 accidents on Class 1 railroads attributable to overheated bearings. Bearings were responsible for less than 1% of all accidents. One only has to go back to 2000 to find accident rates for overheated bearings over 4 times greater. Now, to be clear, Those 13 accidents, none of them were of the magnitude of the East Palestine accident. Nevertheless, as the East Palestine derailment demonstrates, overheated bearings are still a cause for concern. Railroads have voluntarily deployed hot bearing detectors for many decades, with over 6,000 currently deployed across the country. When certain temperature thresholds are reached, these detectors notify the train crew of a potential overheated bearing. The Class 1s also have committed to installing 1,000 additional hot bearing detectors and are lowering temperature thresholds that trigger the alarm for train crews. Using hot bearing detectors and advanced data analytics software, railroads are now able to detect potentially problematic bearings before they reach the overheating thresholds. Acoustic bearing detectors that measure noise to identify defects also detect potentially problematic bearings. When it comes to enhancing safety, the railroads have long focused on preventing an accident before it occurs. Wayside detectors and inspections are foundational to helping railroads meet that goal. The railroads must continue to improve their safety record. While rail remains a safe, responsible transportation solution, the industry is committed to becoming even safer in the years to come. Thank you.
Thank you, Mr. Rush. The next opening statement is from Mr. Hopewell from Norfolk Southern.
Thank you and good morning. My name is Jared Hopewell. I'm the Assistant Vice President, Communications and Signals at Norfolk Southern and have been with the company since 2005. At Norfolk Southern, safety is our top priority. For decades, we've deployed safety systems to monitor equipment performance and identify potential defects and irregularities as trains move across the system using a variety of wayside detectors, including hot bearing detectors or HBDs. We use HBDs to assess the temperature conditions of wheel bearings. In 2022 alone, HBDs scanned the temperatures of more than 2.2 billion bearings. As we saw in East Palestine, when a hot bearing detector detects that a bearing is more than 170 degrees above ambient temperature, it emits a radio transmission that provides an audible, real-time alarm to the train crew, who are trained to respond to the alarm immediately. Hot bearing detectors announced 618 bearing-related alarms directly to the train crew in 2022. Approximately 43% of those resulted in the identification of an issue requiring attention, with 14% of the alarms requiring in a car being set out from the train. The detectors also relay temperature measurements on a near real-time basis to the wayside desk, where we monitor for potential developing issues. Those issues include heat trends across multiple locations during the course of travel of a rail car that have not risen to a level that would trigger an audible alarm to the crew. In 2022, based on this, the wayside desk performed 876 bearing-related interventions by instructing rail crews to stop trains for inspection. Nearly 65% of those resulted in train crews identifying potential problems with the train that could be addressed before they became more severe. In the last 30 miles before train 32N derailed in East Palestine, it passed 3 HBD systems. The first 2 detectors did not trigger any alarms or alerts that would have required action by the on-shift wayside desk operator or by the train crew. As the train passed through the East Palestine HBD, however, the detector identified an elevated temperature from a wheel bearing on car 23 and announced a critical alarm to the crew to stop the train and inspect the axle. As the NTSB noted in its preliminary report, our train crew responded to the alarm in accordance with applicable policies and procedures and acted appropriately to bring the train to a safe stop. Unfortunately, the train derailed before it was able to come to a complete stop. While safety mechanisms were not able to prevent this accident in this instance, we are committed to learning from it, and we have worked every day since the derailment with industry partners, regulators, and the NTSB to continue to improve railroad safety. Norfolk Southern has already taken steps to enhance our wayside detector system and has been participating in an industry-wide initiative to reevaluate alarm thresholds. In addition to expanding our use of existing technologies, we are making plans to install new kinds of detectors that will provide us with additional data points that we can use to identify potential issues before they result in an accident. And we are working to deploy inspection portals that use machine vision and ultra-high resolution cameras to provide a 360-degree health check on rail cars. We are committed to improving the safety of our railway operations at Norfolk Southern and intend to lead efforts to make industry-wide safety improvements. I'd be happy at this time to answer any questions the board has about our wayside detector systems.
Thank you, Mr. Hopewell. Our next opening statement is from Mr. Hand with the BRS.
Madam Chair, members of the board, good morning. My name is Chris Hand. I'm the Director of Research for the Brotherhood of Railroad Signalmen. Wayside defect detectors, particularly hot bearing detectors, have recently gained significant attention. However, BRS and its members have long recognized the importance of wayside detectors, including hot bearing detectors, in the rail industry. Hot bearing detectors have been in service since the 1940s, and advancements in technology have continuously improved their field detection capabilities and communication with back offices. Presently, these detectors can be integrated into positive train control systems, enabling real-time data transmission to train crews. It is concerning that railroads are reluctant to provide train crews with real-time alerts such as trend analysis. In contrast, airline pilots are well informed about any issues in flight and do not rely solely on alerts from a central office. Train crews should be afforded the same level of awareness. Regarding testing and maintenance of hot bearing detectors, Norfolk Southern is responsible for determining the testing protocols, the schedules. Similarly, railroads have the authority to decide the level of detail and effort put into maintaining these detectors, as well as conducting trending analysis. To prevent accidents like what occurred on February 3rd, 2023, it is crucial to create regulations that establish standardized practices instead of relying solely on railroads to create their own standards. Thank you.
Thank you, Mr. Hand. We'd like to call up Exhibit H54 for the presentation from Professor Tarwani with the University of Texas.
Good morning, Chair Hamindi, members of the board, and the audience. My name is Constantine Tarwani, and I am the director of the University Transportation Center for Railway Safety at the University of Texas Rio Grande Valley. My biography is provided, and people can have access to it. I would like to talk about just a little bit of background for the audience. Please move next. So just these are the main components of a taper roller bearing, which basically has a cup or an outside cone, outer cone, inner cone, cages, and rollers. Some of the defects that bearings might see are pitting, spalling, local defects, distributed defects that could be from water etch, basically water seeping into the bearing, and of course we have burn-offs that can be caused by high heat generation. Some of the wayside detections that are relevant to bearings and wheels are the hot box detectors, the acoustic bearing detectors, and the wheel impact load detectors. So hot box detectors, for the audience, there are about 6,000 in North America. They could be spaced anywhere from 15 miles to 25 miles or 40 miles, depending on the location. They scan their infrared thermometer or infrared radiation sensors that scan the bearings and wheels. The acoustic bearing detectors, they basically listen to the bearings as they pass, and they can identify growlers or bearings that produce loud noise. The wheel impact detectors are devices that can detect the load of basically wheels on tracks. Our facility has unique bearing test rigs that can mimic the operating conditions of bearings seen in revenue service. We can mimic basically any ambient conditions and any operating load and speed conditions. So we have two types. Some are four bearing, some are single bearing, depending on what the need of testing is for the industry. So I just want to focus on this one so that for the audience, because it's going to be coming up in questions. So there are two types of, or there are three things that we measure in a bearing: temperature profile, vibration profile, and load profile. In 20 years of experience, we were basically finding out that bearings, identifying bearing defects through vibration is effective. The top graph has red lines. The red lines are the threshold of healthy. Anything above that red line is defective. Anything below the red line is healthy. Bearing temperatures can go through cycles of heating and cooling depending on how components may get stuck or misalign rollers, but that's not an indication of a bearing defect. Vibration can identify those defects at an early stage. At the top profile, at about 100 hours, or a little bit after 100 hours, the bearing was healthy. It started developing a defect, and the vibration signature of that bearing started increasing, and it went above the threshold, and it continued to be above the threshold for 50,000 miles, indicating that a defect has developed, whereas the temperature profiles were not able to indicate that there was a defect in that bearing. Next. The two pictures shows the bearing before the defect developed and after. The important thing here to point out is that there were 50,000 miles between when it was healthy and after the defect developed, which means that, and there were no temperature issues, which means these bearings, when they develop a defect, they can go on for sometimes 100 or over 100,000 miles before they become critical. And so this shows that vibration detection is proactive and can give hundreds of thousands of miles of advanced notice, whereas temperature is very reactive in nature. And that's the kind of research that we have been doing over the past 2 decades. Thank you.
Thank you, Professor. We'll start with our questions, starting with Dr. Garcia.
Thank you, Mr. Ryan. Mr. Cox, the FRA's requirements for railcar inspections are specified in FRA CFR Part 49, CFR 49, Part 215, and Appendix D. Briefly describe the differences between the Part 215 and the Appendix D railcar inspections in terms of what gets inspected and who is authorized to perform the inspections. Mr. Cox?
Yes. Thank you. Under 215, the group of people called Carmen are authorized to do the safety inspections. They are a group of safety inspectors, and under Appendix D, the train crews can do the inspection. I actually have a printout of 215 here. I believe it's Exhibit E22 in your record. But this here represents 215, which the Carmen are extensively trained in. And out of that entire example, only this small section and the small section at the bottom of this page is what the train crews inspect. All in all, on a freight car, you're looking at anywhere from 90 to 105 points of inspection per side of a freight car, depending on what type of freight car we're talking about, whereas the Appendix D only hits on 12 points. It is meant to be a very limited type of inspection to get the car to a safety inspection point. In addition to that, to outline the type of training that these safety inspectors have, these highly qualified inspectors, under 215, they are issued these wheel gauges. And they use these wheel gauges in order to assess the total health of the freight car, something that is never issued to a freight train crewman.
Is there a difference in the purpose of the two types of inspections?
Yes, the 215 that the Carmen does is supposed to assess the total health of the freight car, whereas the Appendix D is just supposed to be a stopgap to get the freight car to an inspection point. Unfortunately, in today's rail structure, the railroads have gotten larger, there are less railroads, and there are less interchange points. Therefore, the Appendix D has become more and more the primary inspection on these cars instead of the detailed inspection under the 215 by the qualified mechanical inspector.
And what are the differences in the qualifications and what type of training is required to perform each type of inspection?
There is testing yearly on air brakes and mechanical defects, and the carmen are required by the federal regulation to go through this type of training very regularly. The train crews, not nearly as much.
If you could bring up the map, please. What type of inspections were performed on the first car to derail from when Norfolk Southern first received the car in Madison, Illinois, up to the train derailment in East Palestine?
My understanding of the record, when Norfolk and Southern first received the car, there was no inspection done. So the car came from another railroad, and traditionally there would be an interchange inspection and the cars would be looked at, but as I've said, there's less and less Class 1 carriers, and therefore they are relying more on the Appendix D. This car came into Decatur, Illinois, passed through Toledo, Ohio, where it stopped, Cleveland, Ohio, where it stopped, and passed through Bellevue, Ohio on their system. There are qualified mechanical inspectors at all these points, and they were not allowed to inspect this car at any of those locations.
Thank you. Regarding the types of rail car inspections in yards, what does the term ghost tracks refer to, and does it apply to Norfolk Southern trains and yards?
The term ghost track means a train that has been set outside of the terminal. It was never yarded. And with the train never being yarded, where they change out the crews, there is no qualified mechanical inspection that has to be performed in an instance, and therefore that can be used to skate the regulation and only do the Appendix D inspection and not the full inspection of a qualified inspector.
In September of 2022, the FRA administrator sent a letter to Class 1 railroads with specific concerns about the level and type of railcar inspections, including ghost tracks. The letter sent to the Norfolk Southern CEO is Exhibit E21. Mr. Cox, do you know if Norfolk Southern has addressed the FRA administrator's concerns regarding these railcar inspections?
To my knowledge, they have not responded to that letter, and to expand upon my knowledge of that letter, when the local representatives at various points across the NS system asked their transportation management about this letter and letting the carmen do the detailed inspections, their response was, this letter says I do not have to do this. Therefore, Norfolk and Southern is not going to do this.
Mr. Hopewell, has Norfolk Southern responded to the September 22 letter from the FRA administrator?
I'm not aware. I'm not aware of this letter or our status on a response to it. I'm sorry.
Can you find out for us, please?
I can.
Can I ask who here would be able to ask that question, answer that question?
I would have to consult with the rest of my colleagues who are here if someone's read in on that topic.
Thank you.
Mr. Cox, did a Norfolk Southern employee inspect the rail car from the time when Norfolk Southern received it up to the derailment in East Palestine, whether it be a Carmen inspection or a train crew inspection?
For clarity, you're talking about the car that burned off the journal?
Yes.
The answer is no.
Thank you. And this lack of the inspections, was this within the FRA regulations for car inspections?
To the best of my knowledge, as I've already outlined, due to the fact that there are less Class 1 carriers, they have used the regulation to skirt the inspection process. With there being less Class 1 carriers, the regulation is out of date and not in touch with today's railroad structure. And to further outline, I am also aware that there is a Railway Safety Act bill out there for vote, and in its current shape out of committee would fix a lot of these oversights. Thank you.
Thank you. And you alluded to this previously when the map was up, but just specifically, was there an opportunity for Norfolk Southern Carmen to conduct a full mechanical inspection of the rail car prior to the derailment?
There are areas where I discussed that Carmen were present, but no, they would not have been allowed to look at that car per the Norfolk and Southern's policies.
Thank you. And my final question for this round, Mr. Cox, do you believe that a full mechanical safety inspection or an alternate maintenance schedule would have detected a failed bearing in the first car that derailed in East Palestine?
That is a potential. I would reference the exhibit in your docket, E1, where it shows pictures of multiple bearings, among them where the wheel seal is cocked and out of place. There's an inner and outer. And when that gets greasy, a carman will take this gauge and give a little pry to see if that seal will turn. If it does, that's loose and it will leak lubricants. It can fling lubricants across the side of the freight car, indicating that there is a problem. And of course, a wheel seal will also allow the intrusion of particulates and water, which will lead to eventual failure.
Thank you. And if I could have just a few more seconds, you held up the gauge. Could you hold that up again, please? The tool that you use?
Yes, there's two. There's a flange gauge, which is this one, and there is a high flange gauge in rim thickness, which is this one. These are highly important because if the flange is too thin, it could break off the wheel. It could potentially go down the wrong side of a switch that it's not intended for. Or if the flange is too high, it could ride up on the frog of a switch and go on the ground that way. Or if the rim is too thin, the wheel could actually shatter.
And the train crew, when they perform an Appendix D inspection, do they use those tools, and are they trained on how to use them?
The answer to that question is no.
Thank you, Mr. Cox. I turn the questioning over to Ms. Lamb.
Excuse me, I was just wondering, Chair Hamilton, can the other panelists follow up on a question or?
That's up to Dr. Garcia.
Thank you. Did you have a response, or why don't we go ahead with Ms. Lamb? And then you'll have the opportunity, if you take a note, to go ahead and address that.
Thank you.
Thank you.
Thank you, Dr. Garcia. Please display page 1 of Exhibit E1. My questions are for Mr. Ewand. Mr. Ewand, the East Palestine derailment occurred after the train experienced what the rail industry terms a bearing burn-off. Can you please describe what happens during a bearing burn-off and over what distance and in what time period one can occur?
Thank you for the opportunity to address the committee and your questions. Somewhat of a broad and not an easy question to answer. A bearing that reaches the overheating mode or in peril mode where overheating is going to occur, once that condition has been reached in the bearing, it's a number of seconds typically for the bearing to go from a elevated temperature to an extreme overheat condition. However, as you can see in these images, the thickness of the axle journal, nominally in the 6.8 inches, has considerable strength associated with the size of that axle. Consequently, the amount of time to reduce the strength of the steel, and as can be seen in the upper right-hand image of the exhibit L1, the steel actually begins to extrude itself. Not all burn-offs are like this one, but I'm speaking specifically to this, the subject bearing in the East Palestine derailment. So a considerable period of time will transpire as the steel heats up, begins to plastically deform, and ultimately its ability to withstand the vertical load of the side frame is exceeded and the journal breaks off from the rest of the axle. So it depends on, from a bearing manufacturer's position, the bearing has failed at the moment that it no longer can roll appropriately. From a burn-off mechanism, there's considerable time from the bearing failure to the actual separation of the journal from the axle. I hope I answered your question in there.
You answered. Please display page 2 of the same exhibit. Other than burn-off, what are the typical failure modes? Or can you speak to the initiation modes of burn-off? On what components of the bearing would this occur?
Sure. To be specific, I'm not speculating about what occurred on this specific bearing at this point. However, in general, there are a limited number of conditions that will lead to what we would loosely refer to as bearing failure. There can be, because it's a mechanical assembly, and as you see in the lower right-hand corner of the exhibit, the two bearings seen in cross-section are physically pressed onto the axle journal, which is the large cylindrical gray shape. The roller bearings themselves are located left and right and may be identified by the yellow component, which is the actual cage. The cage is used to separate the rollers, and this entire assembly is static on the axle journal. And by static, what I mean is that the bearings themselves, the inside diameter is pressed to the journal. The rollers roll on those races, And then the opposite side of the rollers would be what's called the bearing cup, which comprises the two races of the bearing. So there can be failures of the cage, where the wear between the rollers and the cage occurs, allowing the rollers to come out of their appropriate position, leading to elevated temperature and premature spalling and failure of the bearing itself. In addition, because this is a mechanical assembly of bearing cones bearings pressed onto the journal, the vertical load applied by the weight of the railroad and the interaction with the wheel and the rail will cause a bending force in the bearing assembly itself. And that cyclic bearing force will lead to what's referred to as fretting wear, or wear between the bearing cones, the faces of the bearing cones, the wear rings, and then the seal wear rings themselves. As that wear occurs, the interface or the stack load between the bearings geometrically changes. It's called, what we refer to in the field, losing the stack load. Losing that compressive force allows the bearings to move out of geometric position with respect to the cup races, as well as the rollers with respect to the cones themselves. That change in geometry causes the bearing now to be compromised, again, leading to premature wear, spalling. Those spalls can lead to debris within the bearing, and all of these conditions will contribute to elevated temperature or failure of the bearing. Lastly, the interference fit between the cones and the journal, because of this flexing, will also reduce itself, and that also leads to the geometric loss or change in load path, leading to bearing failure.
So the inspections that Mr. Cox talked about, you can only see them once you have this geometric loss. The initiations where you're talking about spalls or wear or debris in the grease, would that be visible to an inspector when the bearing is installed on the axle under the train car?
Again, to be specific and not to speculate, I'm not speaking to the incident, but rather to bearings in general. The looseness of components that I referred to can be detected through hand testing. However, the axle, the wheel set, would have to be out of the truck in order to do that. In a normal, let me be more specific, my knowledge, while not as developed perhaps as Mr. Cox's as far as rail car inspections, it would not be typical in a wayside inspection or it would only be at a one spot where maintenance would be performed on a rail car, where the wheel set would be out from underneath the car. Did I answer your question?
It did.
Thank you.
You've mentioned maintenance. At what point is maintenance performed on a bearing? Does it get preventative maintenance, routine maintenance?
Again, a very broad question. Typically, maintenance is performed on wheel sets via a series of Y-made codes. The Y-made code is a description outlined in the field manual, the AAR field manual, that a carman would have, wherein there are a limited number of Y-made codes that would remove a bearing or be a cause for a bearing to be removed from service. There are acoustic conditions. If a carman hears that a bearing is growling or making noise on a roll-by inspection, I think already testified to that if free grease or free drip oil is leaking from the bearing or loose seals are visible, that would be another reason for a bearing to be removed from service. Then there are the wayside detection, the acoustic hot box detectors, of course. I think those are the ones that come to mind at this point. There may be others that I'm not thinking of.
Thank you. What rehabilitation activities can a bearing get when it gets pulled off for maintenance? What happens to it?
So perhaps if I could build on the question that you previously asked, in addition to answering what you've asked in this question, in those YMAID codes, there are substantially more wheel condition or reasons for the wheel set to come out of service due to wheel condition by number than there are for bearings to cause the wheel set to be removed from service. Examples of that would be thin flange, spalled wheels, thin rim. The list is substantial. I'm not sure I can hit them all from memory. When that occurs and the wheel set is removed from service, it then goes to a wheel shop. The wheel shop would then remove the bearing from the wheel set. So largely bearing maintenance or bearing reconditioning is driven by the wheel set condition and the wheel condition more so than individual bearing condition. At the wheel shops, the bearings will be disassembled and inspected. There is as outlined in the association recommended practices and rules and recommended practices, MSRP. There are specific rules that are applied to a bearing to be reconditioned. Largely the condition of the cup, spalls, etc., can be repaired. There are some conditions that I don't have committed to memory where the bearing would no longer be returned to service, but other components can be brought on to the bearing, such as a new cone can be installed onto a reconditioned cup. This information is noted within the componentry of the bearing itself, and the bearing is then reapplied to a wheel set while being called reconditioned. It essentially is being treated as new or expected to perform as new.
Thank you. That concludes my questions for this round. I'm turning it over to Mr. Ryan.
This is for Mr. Rush. I would like to allow you the opportunity to address the physical car inspections by Carmen, bearing inspections. I believe that's what you wanted to address.
Thank you, and I think actually you covered it quite well. Bearings are sealed components. I'm not saying a Carmen can never detect an issue with a bearing, but that's not typically going to be the case. That's why you need bearing detectors, because a visual inspection cannot be relied on, or typically will not reveal a problem with the bearing. But the point was well made in the previous dialogue.
Okay, thank you, Mr. Rush. Questions going over to Mr. Scott, please.
Thank you, Mr. Ryan. This question is for Jared Hopewell of Norfolk Southern. Can you please explain the criteria used to establish the standards used by Norfolk Southern for their hot bearing detectors, such as spacings, alert, or alarm parameters?
Yes, thank you. Criteria in those different categories that you mentioned are laid out in several different areas. There are best practices or recommended practices in industry literature from sources like ARIMA pertaining to installation, site selection, things of that nature, as well as AAR documentation that's managed a lot by the Equipment Health Committee that pertains to other settings, thresholds, and that nature that's set up in the equipment.
Okay, in reference to your Advanced Train Control, or ATC desk and its analyst, what criteria do you base your standards on for them?
Okay, I'll start a little bit, maybe explain the differences between some of the things in the first question and the second question, if that's okay. The detector system as a whole works, as has already been mentioned, really a combination of ways. The detectors themselves that are in the field and, like as I mentioned for the 32N, announce the alarm directly to the train. They serve as a reactive device, as Dr. here mentioned next to me. So that is one element of the system, and that's the alarm. That's the immediate take action part of it. Your second question is more so about the wayside desk and the trending analysis, and that is a more proactive and predictive element using the same data that those same detectors generate. We collect that and do a trending analysis on that data as trains travel across the system, and we track those cars. So the development of that system started off as a multi-railroad effort in the late 2000s and has been taken from there. We have instituted those rules and those settings kind of baseline at some of what is set up in the AAR standards around those Y-made codes. And we have additional ones that go above and beyond that a bit that we've developed over time as that system has matured.
Okay, so you mentioned you referenced like ARIMA, AAR standards. Has Norfolk Southern or any other Class I railroads that you know of done any independent studies or any testing on their own?
I'm not aware of independent studies done by any of the individual railroads. It's typically a pretty collaborative effort in my experience. The railroads certainly do take data points from events when they do happen, and the system has been, I would say, refined over our years of experience of deploying these things.
And in your opinion, do you feel these standards are adequate, or do they need to be revisited?
I feel that using the measuring stick of how the systems have performed in terms of just a results-based analysis on how the bearing-related events have declined over the past couple of decades of their implementation, I think that speaks most to us right now. Those numbers have come down, with the deployment of detectors as that has become more prevalent, through the 80s, especially 70s, 80s. And then we took it another step further with the wayside desk. So at this point, we feel that, we have an effective system, but obviously we're going to continue our efforts to further that development and improvement.
Okay, I think Dr. Garcia has a couple of follow-up questions for you as well.
Thank you, Mr. Scott. Mr. Hopewell, we learned from interviewing the Norfolk Southern ATC analyst on duty that he did not see the non-critical alert transmitted from the Salem hotbox detector until after the derailment because the analyst was working to resolve other train alerts. Is this correct? And what actions would the ATC analyst have taken if he had immediately seen the Salem alert?
Thank you. Yes, the analyst working on the desk that evening was working through the alerts that were in his queue and did not get to that alert immediately. So that's correct. The nature of the alert that did arrive based on our SOPs would have been a monitor until next detector type event. It would not have been an event that we would have expected immediate action to be taken at that point in time.
Thank you. And that procedure to just monitor and wait, is that strictly a Norfolk Southern procedure, or is that one that's used throughout the industry?
That is our procedure that we've developed, and we use data based on the occurrences that we see. Often we see when alerts come up, they may not always present themselves as future issues. And as I stated, the system is intended that functions that way is an over time. It's not necessarily a react right now situation with the alerts. In fact, most times it's not. So I believe does that answer your question?
Yes, thank you. The Norfolk Southern ATC desk supervisor stated during his interview that he had repeatedly requested additional staffing. What was Norfolk Southern's decision-making in denying or providing the requested additional staffing positions?
I was not in my position at that time when those discussions were had and questions were asked. I was aware of it in the time I've taken my current role, and we have actually taken steps to add resources to that desk. First off, to make sure that their capacity, their bandwidth is not going to be anything that would present an issue in the current environment, and also due to the fact that our deployment of additional detectors and technologies we anticipate is going to present further importance and workload on that desk. So we're taking steps proactively to add those resources and have them trained up and ready for it.
During our interviews, we heard from ATC analysts that increasing the number of hotbox detectors will increase their workload. Is this true, and has Norfolk Southern addressed this issue?
So if I understand the question right, is anticipating that more detectors equals more, is that, okay. I can't say for certain if that's true. That's an event in the future. We've, like I said, we've taken the steps to put those resources in place. That's nearly complete now in terms of having those folks ready. So I don't anticipate issues for where we are going forward.
Thank you. I turn the questioning over now to Mr. Aronian.
Thank you, Dr. Garcia. These next set of questions will be addressed to Mr. Rush of the AR. In the AR field manual of interchange rules, Rule 36, an overheated bearing is defined as measured by a wayside detector at least 170 degrees above ambient temperature, or a temperature measured by the same wayside detector of at least 95 degrees above the temperature of the mate bearing. Mr. Rush, please describe the background on how these temperatures were determined, and when was the last time they were updated?
Mr. Ryan, can I just follow up on the previous dialogue, just one data point that might be of interest to the board? The previous question talked about a workload at the back office as they get the information from the bearing detectors. I checked not with Norfolk Southern, with another large Class 1 railroad, and the frequency, the average frequency in terms of how many times a day they have to analyze, or during a shift, they have to analyze these reports from the wayside detectors is 2 to 3 times per shift. just some context in terms of workload. Now, going to the issue of how we arrived at those thresholds. So let's talk, first of all, what those thresholds represent. Those are thresholds in AAR's car repair billing rules, which authorize the ability of a railroad to take a car out of service, make the repairs that are necessary. Those thresholds, the way in which the thresholds are developed really is a function of experience, and you're balancing a couple of considerations. One of those considerations is, of course, the detection of issues with the bearings. The other issue, as was talked about earlier, is, you know, if you put the thresholds too low, you're going to have a lot of false stops, and you're really going to bollocks up the railroad system. You're going to cause issues with respect to customer service, and you're eventually going to lead to shippers choosing other modes of transportation, which really is not in the interest. It's really an experience issue in terms of where to establish those thresholds. Having said that, as I think some people in the room are aware, we have been taking a look at those thresholds, and we'll continue to look at those thresholds. It's an ongoing exercise in terms of taking experience into account. But really, that's what it comes down to, is taking your experience in terms of what threshold's appropriate in terms of getting those defective bearings off the system, but at the same time, not constantly stopping trains.
Thank you. So these overheated bearing temperature thresholds established in the rule then are not absolute limits for safe operating temperatures of bearings. If I understand properly what you just described, they are a standard at which bearings can be removed from service and billing, and the car owners could be billed for.
Correct. Now, keep in mind, it's in the interest of the operating railroad not to have derailments attributable to hot bearings. But the structure, the way in which AAR standards work is our ability to impose standards is through what we call our interchange agreement, and has to do with what we can do with respect to the interchange of equipment. We can't require a railroad to do action on its system which is not affecting interchange. We can't require a railroad to do something with its track. So technically, narrowly, you're correct. It's not a mandatory rule. As a practical matter, a railroad's, you know, is going to take action with respect to a defective bearing. It wouldn't be in its interest to do so, to not do so. And the car repair billing system authorizes them to do the necessary repair and bill the car owner.
Thank you. In your opening statement, you made some comments about that the AAR is actually considering lowering some of those alarm thresholds. Can you please comment further about that? And is the AAR actually considering at this point limiting the service life of bearings based on mileage or years of service?
Let me take the first question with respect to some of the activities that the industry is engaging in with respect to thresholds and alarms. So the industry will be taking a look at the thresholds. You actually saw a commitment from the Class 1 railroads. I think many people in the room are aware of the announcement the Class 1 railroads made earlier this year, that each individual Class 1 railroad was going to take action at the 170-degree threshold, 170 degrees above ambient temperature threshold. We are going to continue to take a look at the thresholds, at the other thresholds in the AAR rules. Another thing we're taking a look at, we've talked a little bit about trending analysis, where a railroad gets the temperature readings from a variety of detectors and determines if there's a pattern that's cause for concern with respect to a bearing before a bearing has ever reached any of the car repair billing thresholds. Each of the Class 1 railroads has, let me take a step back. If you take a look at the now 6 Class 1 railroads, used to be 7, together, the Class 1 railroads had approximately 150 150 trending rules that they used to analyze the data coming from the hot bearing detectors. Each one was doing its own thing with respect to those 150 rules. One of the things the Class 1 railroads have embarked upon is they're sharing those rules and taking a look and seeing if there's a best rule or best set of rules that maybe should be a floor for how the industry analyzes the information from those hot bearing detectors. That analysis has been taking place. It's a current activity taking place. And so, we may come up with a rule or a set of rules that would be a floor. And of course, the railroads would be continued to adding on and using any other rule they wanted to use to ascertain the health of bearings. So both with respect to the absolute thresholds and with respect to the trending rules, the industry is taking a look and seeing what more should be done.
Thank you, Mr. Rush. I will pass the questioning now on to Mr. Scott.
Thank you, Mr. Aronian. This next question is for Mr. Tarane. As shown in the IC's opening presentation, there's a video footage of the 32N traversing the areas near the Salem and East Palestine hot bearing detectors with an obvious glow or fire coming from the bearing of the 101st axle. The temperatures that would likely cause the bearing to glow like it did in the video would likely exceed over the AAR standard of 170 degrees Fahrenheit over ambient temperature. Briefly, can you explain why this bearing that was on fire and read 103 degrees over the Salem hot bearing detector and 253 over the East Palestine hot bearing detector, when actually the temperatures would have been much more higher?
Well, I'm going to base my testimony based on 2 decades of us running bearings 24/7, 365, all kinds of manufacturers, all kind of class railroads. Bearings basically, when they start heating up, when they develop defects that are large enough and now they're causing friction, you're measuring the temperature at the cup. It usually takes anywhere from 30 minutes to an hour for the cup to feel the temperatures that are inside. Like, let's say, so the roller might be at, let's say, 300 degrees F, but the cup is not feeling that. So it takes what we call the thermal constant, could be anywhere from 30 minutes to an hour, depending on the severity of the friction. So once that starts, once it starts trending because of that friction, it's not going to go back and stopping or slowing down. It's not going. It's going to slow the rate, but it's not going to make things better or start rolling better. But it takes about 30 minutes to an hour. So yes, it's not going to instantaneously reach those temperatures. So it's going to take and that's I think the footage, there was a footage at about 8:12 that was on fire, but then the derailment happened about 45 minutes, which is typical of these thermal constants.
Okay, thank you, Mr. Tarani. This next question is for Chris Hand of the Brotherhood of Railroad Signalmen. In your opening statement, you mentioned the testing and maintenance of hot bearing detectors, and railroads are responsible for determining this testing protocols and schedules. Also, you mentioned that the railroads have the authority to decide the level of detail and effort put into maintaining these detectors, as well as conducting trending analysis. Can you please elaborate on why you mentioned this in your opening statement?
Well, I mentioned it because these defect detectors provide a level of safety and ultimately can stop a train. So I think, you know, railroads utilize AAR, ARIMA, and their own thoughts on how to come up with standards. And quite honestly, there just needs to be a standard across the board. And that's, you know, getting defect detectors regulated.
So do you feel that there's a difference in the emphasis put on wayside detectors and their inspection process versus FRA required testing and regulated equipment?
Yes, absolutely. You know, when you go through signal training, you are trained on switches, crossings, things of that nature. So when you eventually take a signal maintainer or signal tech position, you are familiar with those systems. The thing you're not familiar with is the hotbox detector or any detector, because they don't have those in the schoolings. Most of those are, you know, you have to go to a specialized journeyman class, something of that nature, to be familiar with those. So the first time you walk into one of those signal huts, it's quite frightening because you've never seen it before.
So do you feel the wayside detector should be regulated by the FRA as well?
Absolutely.
Okay. I'll now turn my questioning over to Mr. Roney.
Thank you, Mr. Scott. These next questions are for Mr. Hopwell of Norfolk Southern. Mr. Hopwell, can you briefly describe the different hotbox detectors, makes and models that are presently on the NS network, as far as the scanning angle and the scanning location distance from the rail gauge of each one of them?
Yes, thank you. We currently employ two different models of hot bearing detectors provided by two different vendors, Southern Technologies and Progress Rail. They both operate in a similar fashion in that the scanner head looks up at a 45-degree angle. It has two gating transducers that tell the system when the bearing is passing over the envelope of the scanner head to see the bearing. And the alignment point is at the 7¼ inch based on seeing a consistent part on the inner race of the bearing.
Thank you. So we would assume then the three hotbox detectors prior to the derailment site were all of the same make and model?
Yes, they were.
Okay, thank you. So then, can you tell me what is the average time delay in minutes for reporting the bearing temperatures of when a train passes over a hotbox detector to the ATC desk?
I don't have specific data points on that, but my experience in looking at particular events, it's in low single digits of minutes for the total transmission time for it to arrive at the office and be processed.
Thank you. In your opening statement, you made a comment about the number of overheated bearings on the NS network in 2022 to be something around 618. Can you elaborate on if there's any upward or downward trends of that number if we look at the last 5 years, let's say?
So to clarify the number first, that number would represent the number of times that a bearing-related alarm was generated by the detector. The inspection findings of those results may or may not have resulted in an actual bearing failure. There are other potential issues with braking that creates heat that sometimes generate bearing alarms. So that number shouldn't be taken as a direct correlation to bearing failures per se. I don't have good data points on where that trend has been in recent years. I feel like it's fairly consistent in that range, though.
One last question. Can you explain why some of the Norfolk Southern hotbox detector alarm thresholds are different and than the AAR field manual rules? For example, the documents you had provided the NTSB show that the differential alarm on the NS network is set at 115 degrees instead of 95 in Rule 36. Can you comment on that?
I can comment generally that those settings that we employ are based on experience over long periods of time. As Mr. Rush mentioned, that those often you often have to balance against false stops and things of that nature. We've found that, especially in the case of the differential setting, that we have found that the trending in the office analysis part has kind of supplanted some of the functionality of that. And my understanding in benchmarking with some of my Class 1 counterparts is that they're in the same boat with that based on their experience as well. So we've got both our own and some industry reinforcement on experience there that has led us to where those numbers might not be exactly one-to-one match.
Thank you, Mr. Hopewell. I'll pass the questioning on to Mr. Ryan now.
Thank you, Mr. Aronian. Next question is for Professor Tarane. This is a general question in regards to the study that was conducted in your laboratory that was recently with AAR and MXV rail regarding reconditioned bearings and flaws in the components, if you can speak on that.
Yes. So we have been working with MXV Rail over the past, since 2017, over the past 5 years, on looking into the efficiency and efficacy of bearing reconditioning. So the study basically takes bearings that are removed from service. And for the record, bearings usually tend to be removed from service more so for wheel removals more often than bearing issues. But when the wheel axle is removed, the bearings are sent to reconditioning facilities. The reconditioning facilities look at the bearing, and based on AAR rules or guidelines, they'll say, okay, this bearing can be repaired, this not. So the idea was that there hasn't been a study done to see, well, how do they perform after they are repaired and put back? And so we've done the initial phase was phase 1, where we looked at 12 bearings, and we did an analysis before reconditioning and after reconditioning. And those data showed that it's a 50% chance of improvement. So the likelihood of a reconditioned bearing being better by reconditioning is about 50%. The second phase of the study we did, did it specifically for bearings that were removed for issues that are not related to the bearings, meaning wheel axle removals, nothing, the bearing was healthy. And when we did that study, we also found out that after reconditioning, about 50% of those bearings failed, and 50 survived. So the study is ongoing. There is a third phase, but those data have not been released, and we work with MXV through them. But the experience with these bearings has been right now almost about 50% chance that reconditioned bearings, when they put back in service, they will have a 250,000 mile. That's basically the threshold we use. Will they run 250,000 miles without failure? If they fail before then we consider that, a failed bearing.
And when you say failed, can you describe some of the defects, why they failed?
Yes, so usually the bearings are, so when you look at the raceway, there are certain defects of certain size that you can repair. And so the repairs are different. It could be just buffing the surface, it could be removing stress, the stress from certain points that have defects. What we found in our experience is that the process varies, and there is no there's no one way of doing it. So for example, one of the things we found is that when there are two repairs or two stress relief holes right next to each other, very close, they tend to actually cause the bearing to fail. So just because the proximity of the two stress relief holes causes a stress and causes the bearing. So based on that input, that was relayed back to the reconditioning facilities, and some of the rules and guidelines were changed. It says, look, if there are two repair areas that are very close, you might consider not doing that. Mostly it also depends. If you do not remove all of the crack or the crack propagation properly that's still under the surface, it might, under stress, when you do that, it might propagate and cause. So when we say failed, we usually do not run them to failure, meaning to burn off. What we do is we have our vibration sensors, and the vibration sensors will tell us when a defect develops instantly. And so when we remove them, if the defect is large enough, meaning over 2 inches squared, we consider that a failed bearing, because if that will continue to fail and degrade into basically burn off.
All right, thank you. Chair Hamidou, we're close to our time. We do have a few more follow-up questions if time allows.
Yes, please, go ahead. We're ahead of schedule, so ask your questions.
Thank you.
I have a follow-up question for Mr. Ewand. Both you and Professor Tarwane have talked about how bearings are examined when wheel sets are pulled. So that means that an inspection interval would be essentially when a wheel is going to have damage. And over the years, wheels have improved in both design and materials. Do you know of any instances where the industry has thought about how that would have an effect on whether flaws in bearings would be able to be detected? Because the intervals for inspection of the bearings has now increased as well.
Ms. Lamb, you ask very complicated and broad questions. I'll do my best. Good questions, by the way. So there have been improvements across the industry, both in wheel steel as well as in bearing steel. So improvements are constantly occurring. I think it's important to recognize that in the bearing world, a spall on the cup is considered a failure, whereas in some conditions, the bearing can operate, and those are largely fatigue-related conditions, but that does not mean that the bearing is in peril to overheat and burning off. The challenge that the industry has is that in this industry, because of the considerable variation between the bearing, the expectation of what the bearing is to provide. In some cases, bearings that operate in a unit train operation, which is a little bit dated now, I understand, giving PCR, but or PSR, that those bearings will operate with a different life, and those wheels will have a different expected life due to wear than, for instance, the same size bearing and wheel that's operating under a tank car or a hopper car that is used for storage of media or used as a temporary storage device. So consequently, it's quite difficult to be able to pinpoint precisely when maintenance could or should be performed from a forecasting perspective, because of this broad variation in utilization of the bearing itself. Specifically, if you consider a unit train, 50% of the time, that bearing is not going to be loaded by payload because the car is empty half of the time. However, in refrigerated cars, those units or those cars tend to be loaded in both directions. So the application of load to the bearing is substantially different because the car utilization plays a role. So unfortunately, there is no simple answer to that question. I hope I've addressed it at least to some degree to your satisfaction.
Do you think that there are additional steps that can be taken to maybe time track bearings or have bearings stay on a specific type of car and then develop standards that way? Or are there additional ways you think that the industry can respond to the ability to detect these flaws and do it before you end up with something like a bearing burn-off?
Again, limiting my response to you not to be specifically addressed to this derailment, but rather in a general sense. I personally think that given the constraints on the industry because of all the variability I spoke to you about, the improvement in prediction and or monitoring of condition might be a more effective way of addressing bearing reliability than establishing a specific, if you will, mileage, because of the specific reason that not all bearings, even though the bearing size is the same, its life expectation is greatly different because of the variability of car type in the industry.
Thank you. I will now pass it over to Mr. Payan.
Mr. Rush, I just wanted to clarify, make sure I understood a comment you made earlier about the number of alerts that a wayside analyst usually handles on average. If I understood right, you said 2 or 3?
Per shift, that's what I said.
Is that per shift? That differs significantly. When we talked to INIS analysts in Atlanta, they mentioned that they were getting about 300 alerts per shift. Not all of them needed to be addressed, but they did need to be looked at and either dismissed or followed up. So I wanted to clarify what the 2 to 3 versus 300.
So I'm not, obviously we would have to talk to NS and find out specifically what they're talking about. Are they talking about they're actually having to analyze the results for a specific bearing 300 times during a shift? I'd find that surprising if that's the case, and we'd have to explore that some more. I think we'd have to have a dialogue in terms of whether we're talking about apples and apples or apples and oranges.
Right, yeah. When we, in our interviews, which are exhibits to the docket, they were talking about during their 12-hour shift, they would get about, on average, 300 alerts. Some of them they all had to be looked at, but some of them could be dismissed and some of them had to be followed up. And at times, there would be like 5 or 6 trains that needed follow-up. And this was for one person during the 12-hour shift. That it could get up to 5 or 6 alerts that needed to be looked into further.
Yeah, so with respect to actually, in terms of looking into further, if we're talking about the number of times a train has to be stopped a day on a particular railroad to look and, for the crew to get out and look, leaving apart the absolute threshold alerts, the talking alerts to the engineer and conductor. But if we're talking about additional times the train has to be stopped based on analysis back at the back office, so to speak, yeah, that's consistent with what my understanding is in terms of the frequency with which that would occur. The number of times an analyst in the back office has to be during a shift looking and seeing on the basis of the trending analysis whether a train has to be stopped. That hundreds is a lot more than my understanding, so we'd have to pursue that further.
Okay, thank you. I'll turn it over to Mr. Aronia now.
Thank you, Mr. Payam. These next few questions are addressed to Professor Tarane. Professor, when a roller bearing starts heating, would the train speed have any impact on either masking or enhancing the bearing temperature readings, depending on how low or how fast the train is moving?
Yeah, yes, of course. Basically bearing temperature in general has several factors. It depends on speed and load. So the bearing operating temperatures based on, so a bearing that is loaded versus unloaded, loaded bearings will run hotter than unloaded bearings. Of course, bearings running at 20 miles per hour are not going to run as hot as bearings running at 60 miles per hour. Or so on average, for example, a loaded bearing that is running at about 60 miles an hour will have normal or typical temperatures between 120 to 140 degrees F. If it's unloaded, it's going to be lower than that. The ambient also plays a factor. So, for example, if the ambient conditions are 115, right out there, you're running in the bearing temperature will run hotter, right? So usually we like to look at the temperature difference above ambient, which is the thresholds are. Some of the issues is that there is other factors. For example, a freshly packed bearing, brand new, with new grease. If let's say you put it on an axle and suddenly the train is loaded and you're moving at, let's say, 55 miles an hour, that temperature can reach 200 degrees F easily because as it's going through what we call the break-in phase. So if an alarm is issued at that point, right, it's going to be a false positive because it's just typical of bearings to run through this. And in my experience of running that data, it could take up to 25,000 miles before a brand new bearing breaks in. So you combine, basically, there is also like different manufacturers have different types of grease. Some are thicker, more viscous grease that will run hotter. Some use grease that is the bearing runs cooler, but it doesn't last as long. So there are different factors on there. And of course, now when we have a typical defect, when the defect develops, now keep in mind that when these bearings are very resilient and very robust, they're meant to really take on a lot of load. When a defect develops, and as you saw in some of my presentation, it could take up to 100,000 miles between a spool that, let's say, starts at half an inch to reach a critical area where it's causing now so much friction. When that friction happens, it's a factor of speed. So if you're going at 20 miles an hour, it's going to take longer for that defect or that heat to reach higher temperatures. If, let's say, you're going at 60 miles and that friction, it can happen much faster. So the speed and the load play a major factor on how fast the rate of degradation and how fast that heat can go up to the cup. Some of the other issues that can come up is if there are impacts, if let's say the wheel has impacts, that can also aggravate things. So there is several factors, and that's why the bearing is a mechanical component. Trying to diagnose its health with temperature is subject to a lot of inefficiencies. Listening to the vibration, you can have a much better picture of when the defects develop basically 100,000 miles in advance, where that gives you it's kind of like predictive maintenance. So yeah, the temperature is one of those that has many several factors. And
Thank you. So the follow-up question is, we have the hot box detectors now that look at temperatures. So if a train speed is influencing the temperature of the bearing, would you think, in your opinion, that the red temperature at lower speeds should be actually extrapolated to a higher speed, something like the wheel impact load detector does? When you go slow on a wild detector, the reading is extrapolated to 50 miles an hour, which is the optimum speed to read the proper impact level. Should something like that be done to the hotbox detectors?
in my opinion, yes. So, for example, if let's say a car, there are some cars that run their entire life at between 20 and 30 miles, right? They're not going to exceed 30 miles. Now, let's say if a car running at 20 miles is reading 130 degrees F, that's more than average. So at 20 miles, your temperature should be in the neighborhood of 90 degrees F. So if it's reading 130, that's elevated. So the way we do at least our thresholds in my testing, we don't do them as a flat and say, okay, this is the threshold. We do by speed and by load. And so that's how we connect, because as I said, having a bearing that's going 20 miles an hour, reading 140, that's a concern. Having a bearing that's going, let's say, 70 miles an hour, read 140, that's not a concern.
Thank you for those clarifications. I'll pass the questioning now to Mr. Scott.
All right, it's kind of a follow-up to Mr. Ronian's questions. We're talking about heat. In an article of American Society of Mechanical Engineers, I believe it was dated April 2016, it's Exhibit E4, you mentioned that temperature alone does not seem to be the good indicator for the presence of a bearing defect and how severe it is. What other detections methods, such as acoustical, could you speak on it, and your vibration detection, what do you feel is a better option versus the heat?
Yes, so again, in my experience, acoustic bearing detectors are a better predictor of bearing failures than hotbox detectors. The issues, as I said, it's a complex problem, meaning when acoustic bearing detectors were first introduced, the issue was that if you set your thresholds too low, you can have many bearing stoppages and delays. And as my colleague Yuan pointed out, a bearing can run on a spool for 50 or 100,000 miles with no issues. And in my experience, there are probably a lot of bearings out there with spools that are running, and the temperature is not going to tell you. So what acoustic bearing detectors will catch, what we call growlers. Growler is 90%, almost 90% of the raceways are defective. If you set it too low, then you might have too often of stoppages. In our experience is that having, let's say, onboard sensors that measure vibration and continuously monitor a bearing can give you a much better predictive an early warning. So in some of the cases I showed, we basically can detect the onset of bearing defect within less than half an inch square area with a vibration sensor, and of course tracking it with time until you reach a certain threshold. Of course, the worse the defect, the louder and the higher the vibration, so you can track. We got it down to a science where we say, for example, if let's say the vibration level is at this threshold, you have about 50,000 miles before you want to react. If it is at this threshold, you might have 25,000. And so that at least gives the railroads a little bit ahead advanced notice that they can schedule maintenance. Temperature will always be a reactive. And because of the factors I said, so many factors, ambient, is it a new bearing? So for example, let's say you have 100 cars. 7 of them have brand new bearings, just fresh axles, and the rest are old. That's gonna skew the basically the average, because those are gonna run hot compared to the others, so it's gonna skew the average, some of the predictive analysis that you're doing. The vibration is blind to that. It's just gonna listen to that bearing and it will tell you if there is a defect and how severe the defect is. And so it's a mechanical component, and at some point it's being used in so many machinery. I think it's time for us to start looking at these other options that are that will give us more predictive analysis.
Okay, thank you. Turn it over to Ms. Garcia.
Thank you. I have one follow-up question for Mr. Hopewell on dispatch center communications. Mr. Payen presented a timeline yesterday morning showing that at 9:27, the train conductor referred to his Norfolk Southern Hazmat guidebook and requested permission from the Norfolk Southern dispatcher to move the locomotive a full 1 mile away. What did the dispatcher or her supervisor do with this information? Did they communicate this to the first responders or the town of East Palestine that at 9:27, Norfolk Southern was moving its employees a mile away from the site of the derailment and fire?
I'm generally aware, based on my review of the exhibits, of that there was multiple avenues of communication between the train crew and the dispatcher's office, and the events that led them to take that move in terms of referring to their consist and their guidebook. The details of communications that occurred between Norfolk Southern and authorities and our dispatcher and police centers, I'm not read in on the specifics of those details.
Thank you. Can you find out for us and let us know?
Yes, I can.
Thank you.
Chair Hamady, that concludes the questions for panel 3.
Thank you very much, and great job with those questions. We are going to take a break. We'll actually go to 11:15 if folks are okay. All right? All right? Okay. We'll return to the room at 11:15. I asked that the witnesses come back a few minutes earlier to be seated. Mr. Hopewell, if you wouldn't mind checking on the status of that September 2022 letter from the FRA administrator, because my guess is Mr. Alexi may have a question on that. So thank you so much.
DOG or which are the what I would do, but I would wait to you also wireless. We say no, I go around. No, I can and more zones. The, yeah. I have left and right is helping already. But this is all Postec zone, and then I have a galaxy zone. The galaxies are everywhere. But then you could put for a table, you could split Postec's galaxy, and then you play with gains of a single amp, you know.
Right. Welcome back. We are now ready to, nope, we're not. I am going to give a little bit of time to Mr. Rush, who wanted to clarify an answer to one of the questions that Mr. Payan asked about the number of, yeah, can we get the fans turned off? I don't think people can hear. Sorry. Mr. Rush is going to provide some additional details in response to Mr. Payan's question regarding alerts.
Thank you, Chair Hamandi. The question had to do, or the issue we were discussing had to do with how many hot bearing analyses the back office has to do in a day or a shift. And actually, I think I kind of use both shift and a day. So let me be a little bit more precise. So the railroad I was quoting, and this is also true for NS, on an average day, you're going to be dealing with 2 to 3 analyses, trending analyses that the back office has to analyze to see if further action is warranted. The 300 number that was referred to, whether it's accurate or not, was done in the context of all sorts of activities that were being dealt with at the back office. It was not a bearing analysis specific number. But I think both, again, the railroad I quoted and for NS, I think the numbers are very consistent. In any particular day, you would be analyzing 2 to 3 bearings under the trending analysis rules. Thank you for the opportunity to clarify.
I was going to turn to Mr. Hopewell for one thing too, but did you want to ask a question on that?
Oh, that clarified it. Thank you.
Great. And I believe that NS responded to the September 22nd letter from the administrator, and will provide that in as an exhibit. But if you want to just, you can read it into the record or whatever you want to do.
I don't have it here to read, but I did confirm that the response was provided on 11/11 of 2022.
Thank you very much. My understanding is that the technical panel has additional questions right now.
Yeah, thanks, Chair Hamandi. One follow-up question for Professor Tarani. In this car, for this derailment, had approximately 54,000 miles on it. The axle was installed in 2012. It seems like a low mileage, which has to do with the type of service that this car was in. It was a reconditioned bearing with only 53 to 54,000 miles on it in the last almost 11 years. Just to also mention that a recent derailment in Newcastle was also a hopper car on the Norfolk Southern with reconditioned bearings. I don't know if the type of service has to do with how long the car sits, but could you talk about what happens to a bearing when it sits for long periods of time and how that affects the longevity of the bearing?
So the 53,000 mile is typical. Basically, a reconditioned bearing, what we're finding out with our testing, once it is reconditioned and put back in service, depending on how effective the reconditioning, it can last anywhere between 50 to 100,000 miles, or it can spoil out between 50 to 100,000 miles. That's typical. Some can last longer, 250,000 miles. Now, there are other factors, which is how long the bearing sits out of service. So typically bearings, like they should be, the manufacturer state that the bearing should not sit on the shelf for long periods of time, and it needs to be rotated. So our common practice in my lab is that every week when we have new bearings, my students go and rotate the bearings a few times just to make sure that the grease is mixing, because if the grease sits stagnant, it separates. Basically, the grease has additives and liquid, and so if it sits static for a long time, basically the additives will separate from the liquid, making the grease ineffective. And so it kind of deteriorates the grease, and that liquidy foam can seep out of the bearing and cause issues. So grease is very important. Lubrication is an extremely important thing for bearings. Without that lubrication, there is so much friction. One example in my lab, we had a bearing that was sitting there for about 3 years, and my students did not know. They said, okay, it's a new bearing, let's put it on our axle and run it. And it had heating issues within about 3 days of operation, and when we started seeing that the liquid was coming out of the seal, and when we opened it up, we noticed that the grease had separated. Now, we have not done a study to know how long does it take for the grease to separate, and it probably is a function of what type of grease and what combination, but common practice is for the bearings to they shouldn't be sitting long, because yes, they will be susceptible to grease separation, and that renders the grease ineffective.
Thank you. I'm going to turn it over to Mr. Aronian.
Follow-up question, Professor Tarane, if I may. In your opinion, and in order to eliminate bearing burn-offs, is it more beneficial to actually reduce the average distance between the detectors by adding more detectors to the network? Or is it more beneficial to establish universal and common rules about warm bearing trending over multiple detectors, or a combination of the two?
And again, I'm going to base all of my questions based on 2 decades worth of running bearings of different manufacturers. There has been studies done on distance, right? And some of the studies that PTCI, MXV now, has done showing that there is no advantage to having, for example, hot box detectors spaced every 9 miles versus 15 miles. The issue is that I do not believe, in my expert opinion, is that the distance is the issue. Once a bearing starts to catastrophically fail, all the hot box detector can do is you will get more frequent data, but it's not going to delay what's going to happen. Meaning, so for example, let's say there was an additional hot box detector in between the 103 reading and the 170, or the 253. Okay, so let's say you got another reading of 169. So what then? And so the thing is here, like having more. We reach a point where you optimize a system and it cannot be optimized. This is the best you can get. In my opinion, temperature is not the right tool. So trying to optimize something that is not the right tool, it's going to take a lot of time, a lot of effort. I always use the analogy of you can dig a 10-foot hole using a shovel or a bobcat. They both will get you there, but a bobcat can get the job done in 10, 15 minutes. A shovel you need a day. So that's kind of like trying to do analysis on something that is not going to give you predictive maintenance. It's not efficient. So at some point, like the temperature there has been now 2 decades of optimization on warm trending, and we're still having some of these accidents happen. I think it's time for us to start thinking of different ways to be able to track and detect onset of bearing failures, and be able to, right now we have access to machine learning, artificial intelligence, modeling. So many people are doing that you can actually predict failure using the data that is on board the car. So that's kind of like my experience of doing this research for two decades, what is leading to.
Thank you very much for that. I'll pass it over to Ms. Lam.
Thank you. I have a follow-up question from Mr. Ewand. You talked about in one of your earlier answers the effects of wear having on the assembly of the bearing becoming loose, components that are supposed to be press fit are becoming loose. And we've just heard from Professor Terwane about what happens when rail cars sit. And I'm wondering what happens when you have loose components in a rail car that sits in a flooded area, or loose components and a rail car is moving through hard driving rain for an extended period of time. Is there effect of water getting in the bearing? Because that kind of thing isn't something that will be readily obvious once conditions are dry.
So again, with the, the caveat that I am not speaking specifically to this incident, because obviously in the condition we were able to inspect what was left, it would be unknowable whether water ingress had been an issue. And when I was trying to remember and list out to you all the different ways that a bearing can fail, I did leave out water ingress. And water ingress is very much an issue that needs to be considered in the as a cause for premature bearing failure or and in the AAR field manual, there's a specific call out that if a bearing is submerged or flooded, that it needs to be replaced immediately. What can occur under driving rain or other conditions, and I think it's worth investigating in this matter, is that water can ingress into the bearing. That water then migrates and dilutes the lubrication, and I think it's probably everyone is aware that water and lubrication are mutually separate items, and so it decreases the ability for the grease to perform its work and leads to premature failure of the bearing. So I think it is worthwhile considering at least the surrounding factors associated with the amount of time that the car sat, where it sat. I'm unaware of those items at this time. Did I answer your question?
Yes, you did. But you did mention that the AAR has something about if a bearing experiences flooding, it's supposed to be replaced. Do you know in the industry, is flood conditions of train yards tracked? Or do they, it's possible that you don't know and I'm asking the wrong person, but I thought I would at least ask.
I don't know in this specific condition. I do know during my tenure working for a railroad that when we learned the cars had been submerged on our line of road, it was immediately recognized that bearings needed to be replaced immediately on those cars. But how that gets handled if, say, for instance, the car is at industry or something like that, that's beyond my knowledge at this point.
Okay, thank you. I will now pass questioning to Mr. Scott.
Thank you, Ms. Lamb. This question is for Mr. Rush. In a recent AAR news release, I believe it was dated March 8th, 2023, it stated that all Class 1 railroads have now agreed to go further and are immediately beginning to install additional HBDs across key routes with the goal of achieving a 15-mile spacing unless acoustic bearing detectors are within that route. What is the current AAR standard for spacing?
So AAR doesn't have standards on spacing. Again, the AAR rule, AAR's authority, if that's the right word, is to issue standards pursuant to interchange, equipment that's interchanged from one railroad to another. What a railroad does with respect to its infrastructure, its fixed infrastructure, its track, its wayside equipment, that AAR does not have standards for. We can and do have recommended practices, right? But what that press release indicated was a commitment to go beyond what the previous commitment had been through an AAR recommended practice, which the Class 1s all followed with respect to detector spacing for key routes, which was 40 miles, hot bearing detectors every 40 miles. So that press release reflected a commitment by the Class 1s to have more frequent spacing, the 15, 20-mile spacing thresholds that you
So your recommended practice was 40 miles before this?
Correct, on key routes.
Okay. Do you know what decisions or technology they use to determine or move it up to 15 miles?
Well, the 15 miles, I think it was you who referred, or maybe it was a professor who referred to MXV research. There was a research paper done in 2017, if I recall, which looked at what the optimal spacing would be, comparing 15 miles spacing to, I think it was 7.5 or something like that as an interval, and determined there was no advantage in going to the 7.5 mile interval versus the 15 mile interval. It was based on modeling that was done by our research subsidiary.
Since the railroads are exceeding your recommended practices currently, do you feel like your recommended practices are dated and need to be investigated again?
So the recommended practice, again, you're referring to, again, our recommended practice for key routes. We will be amending that. Yes. But the simple answer is yes, we should be revising and will revise our recommended practice.
Are you currently looking at other technologies? I know you mentioned acoustics earlier. Are you examining other technologies such as that for a better accuracy? Or as Mr. Tarane mentioned, vibration, are you looking at other technologies like that as well?
Okay, so there's a number of things that we have underway in terms of initiatives. So one thing that the Class 1 railroads are looking at, we had an explanation before of how a hot bearing detector works and the angle at which the detector looks for the bearing is a 45-degree angle at which the hot bearing detector looks for the temperature reading. There's individual Class 1 railroads are now piloting, experimenting with multi-beam detectors, which will capture the whole width of the bearing in terms of temperature readings. So that's one innovation we're looking at. Another thing that, another technology perhaps that's worth mentioning is the railroad industry spends millions of dollars a year conducting safety research at our research subsidiary in Colorado. And we investigate all sorts of issues with respect to track and rolling stock and operating practices. One of the things that there was a recent research paper that came out that I know caught the attention of the board concerned non-destructive testing of reconditioned bearings. When you take a bearing off, would you engage in non-destructive testing? Would that yield any benefits? The technology that that MXV has first looked at was looking at using electrical current to determine whether there was a defect or not. That actually, that initial look at that technology was not promising. But we're going to continue to look at that as well as other methods of non-destructive testing to see if that would enhance our ability to detect potential problems with reconditioned bearings. So that's another initiative we have underway. Talked about the Class 1 railroads taking a look at trending rules and trending analyses. So we have a number of initiatives underway with respect to improving our ability to detect potential problems with hot bearings.
Are you all currently examining vibration detection?
And I'm going to have to defer to the professor. I think if you have a vibration issue, I suspect that's going to create noise and show up on an acoustic bearing detector. I'm not an expert here, so I'd actually, would almost like to defer to him. But, acoustic bearing detectors, which were developed by our research subsidiary about 15, 20 years ago. That was an interesting exercise, by the way. We developed that technology and couldn't find a vendor who was interested in making it. So it took a while to get the acoustic bearing detectors out in the field. But I suspect that the acoustic bearing detectors would detect a vibration issue, but I'm going to have to defer to the professor because that's outside my area of expertise, to be honest.
So if I'll finish with you, follow up with you some more. But if acoustic, we've heard that it may be better than the hot bearing detectors. Why is there such a small footprint within the U.S.? My understanding, and you correct me if I'm wrong, because these are just numbers that I'm hearing, that there's only like 15 or 16 across the whole U.S. So why is that footprint so small when it could possibly be a better detection system.
So the number, first of all, I think is a little bit bigger, but I don't have the precise number in front of me, but not by orders of magnitude. So I will agree with that. So the way the railroads position their acoustic bearing detectors, and remember, this is an innovative technology, and there are more that are being put in service. The way the railroads position their acoustic bearing detectors is putting them on routes where they'll get a large volume of their shipments of those rail cars moving over those detectors. So they analyze their networks and put them at those key locations. Remember, an acoustic bearing detector, the way in which it operates is going to discover an incipient condition very early. So you don't need thousands of acoustic bearing detectors out there. If you get that car going over that acoustic bearing detector, if there's a problem developing, it will be revealed at a very early stage by the acoustic bearing detector. So it's a very different paradigm than you're dealing with respect to the temperature detectors. But I will say, keep in mind, it's also, there are more being rolled out. It's a very recent innovation. And I would agree with the professor that it's a very valuable tool in terms of discovering incipient conditions. It can do so at a much earlier stage than you can with temperature detectors.
Okay, just from my understanding, just as a reference point, the derailment happened in February. My understanding was the last time this car had been through an acoustic detector was October of the previous year. So if you increased the locations of the acoustic detectors, would that have helped in this situation?
So, but without, again, going to the specifics of the accident, because I'm not familiar with that, in fact, with the statistic or the fact that you just mentioned. The railroads, I do know the railroads are looking at their acoustic bearing detectors. I do know more are being installed. So not really disagreeing with your premise, but I think it's a constant review by the railroads. Again, this is a very recent technology that we developed. So you will see more acoustic bearing detectors. I can't get into the specifics of the route that was used for, or what the placement is on NS, but the railroads do look at placing their detectors to capture the greatest amount of traffic over those detectors and discover any incipient conditions as soon as possible.
Are you aware of any tracking the Class 1s or other railroads are doing as far as the distance and time since a car has last passed over acoustic detector?
I do know the railroads engage in analysis in terms of the placement of the detectors to capture traffic to the greatest extent possible and expose as many cars as possible to the acoustic bearing detectors readings. I am not aware of other analyses that are taking place, but that's not to say that they don't engage in further analyses. I'm just not personally aware of those analyses.
Okay. Do you have everything you need as far as technologies? Is there anything you need that would help you to look forward in the future for new technologies?
Well, as I said, for example, the Class 1s are piloting the multi-beam hot bearing detectors. We have, again, the acoustic bearing detector was something we just developed not too long ago in the context of railroad history. Who's to say, what potential technologies there are going forward? We did hear references before to machine visioning. As I know the board's aware, we've done a lot of work and continue to do a lot of work in our Colorado facility with machine visioning equipment, which can reveal all sorts of problems with respect to rail cars. I don't think you can say you ever have enough when you have instances of accidents being caused by a particular condition. As long as we have accidents which are being caused by hot bearing detectors, as much as we've driven down the frequency with which those accidents have occurred, again, 4 times going back to the year 2000, 95% reduction from when I first joined the industry, which was too long ago to mention. As long as we have those accidents occurring, we can't say we're satisfied we have enough technology. We'll continue to look at what's out there. We're not satisfied.
No problem.
Thanks very much. I think we're going to turn to the party panels now. I just we can come back after the Board of Inquiry to see if you have additional questions. But I do want to turn to the party panels. So Mark has reminded me kindly that when you ask questions, could you please state your name and affiliation so that he can jot that down. We're going to start in the middle with the parties from the labor table and proceed to the industry. Oh, industry table will go last. We'll go with labor table, government table, industry table. So labor first.
Okay, thank you. Jared Cassidy with Smart Transportation Division. Mr. Cox, Mr. Hand, there's been a lot of comments about experience and how experience should be relied on in this hearing. And, you know, I'm concerned because that experience was present on February the 2nd, and yet we still had a derailment on February the 3rd. So I would like to open with an open question or a general question and saying, what could be done today to improve safety on the railroad in your respectful crafts? Because a lot of this conversation is about future development and what tomorrow may hold. But what can be done today to start making meaningful changes in safety on the railroad for your crafts? Chris, we'll start with you, or Jason, we'll start with you.
Oh, that's a good question. You know, in recent years, the industry's push on efficiency has evacuated a lot of outlying points and a lot of inspection points of the safety car inspection from the qualified mechanical inspector. With that said, relying on this Appendix D where the train crews are only doing a 12-point inspection is not sufficient, where the Carmen is performing those points of 90 plus inspection points per side of the freight car. The other thing that can be done is giving them the time to do the work. In this industry, and I would point to exhibits I've entered into the record, I'll reference H38, a deposition by NS manager Ryan Stagey, who under oath testified that he was authorized to speak on behalf of Norfolk and Southern, said that they're only giving the car inspectors 30 seconds a side to inspect the freight cars. I would also point to Exhibit H41 in the docket that outlines the historical time studies done prior to the new efficiency standards, where inspectors were given 3 minutes per car on the outbound inspection and 3.6 minutes per car on the inbound inspection. The inbound inspection being where the primary 215 mechanical in-depth inspection is done, where the total health of the freight car is assessed, down to today, where the standard and the efficiency reports put out by Norfolk and Southern show that those times are down to 30 seconds aside, the 1 minute per car. Exhibit H40 outlines a supervisor scorning the mechanical employees when they spent 45 seconds aside. And then following that, in 2021, where NS Supervision praises the inspectors for their inspections when they got to 1 minute per car, which is the goal outlined by Mr. Stagey in his deposition. Does that answer your question?
It does. Chris?
Yeah, I'll be quick. I think it's just the atmosphere that we've been dealing with you know, prior to COVID, and that's employment levels. The reduction in employment levels has, you know, you're putting more work on individuals than is needed. So from a safety standpoint, we need to get the employment levels. And I don't know if it's PTC numbers or if it's, prior to COVID. I think it's probably in between there. To go ahead and run. See.
Mr. Hopewell, Mr. Rush had made a statement about a false reading earlier in regards to trending temperatures. I'd never heard that term before. Had this been caught by the ATC desk, would it have been considered to be a false reading potentially?
So in other words, just to get it so I'm clear, had the ATC desk stopped the train previously, would it have been?
Had the ATC desk seen the Salem reading of the elevated temperature prior to the East Palestine, would they have considered that a false reading? Do you think they would have instructed the train to stop?
By our SOPs and guidelines we've laid out for the wayside desk, this was the first occurrence of an elevated temperature for this particular alert that came into them. Based on the level of those readings that came in, the desk analyst would not have been required by those SOPs to make a call to stop that train. However, they are empowered to do so based on their experience if they choose to do so.
May I ask one more very quick, Madam Chair?
Yes.
Okay. Mr. Cox, if that was considered a false reading, let me rephrase that. Had the crew actually stopped, is there the potential for the identification of a defect from your knowledge that the conductor could have seen had that ATC desk acted on the alert and the crew actually stopped? Was there the potential to identify that defect and prevent this derailment from occurring?
I do apologize. You're real echoey. Could you repeat the question? I had a hard time hearing.
Well, first of all, I'm from Nashville, so I have a bit of country twang, so I apologize for that. Had the ATC desk acted on the elevated reading and instructed the crew to stop, could that defect have been discovered by that crew, in your opinion, that could have possibly prevented this derailment had the crew actually been told to stop and identified the fact that there was potential for danger?
Yeah, I mean, the whole reason from what I've learned is the journal burned off because they didn't stop. And there's a history of the mechanical desk telling train crews, to my knowledge, not to stop.
Okay, Randy Fannin, BLET. Mr. Cox, I have a couple questions for you. Are there schedules in place for rail cars to be inspected that would include the journals after a car is turned out into the rail system?
So if a car is derailed, it's required to receive an in-depth inspection on the bearing by a qualified mechanical employee at the repair shop when the wheels are rolled out. Also, doing roll-by inspections, I think, is highly critical because a failing bearing will have telltales. It'll make noises that could be detected by a human inspector. And I think the big picture here is that with a lot of these locations being vacated of human inspectors who should be working with the technology, that this firewall of safety has been severely compromised. Had the inspectors been given a chance in interchange, there's definitely that chance to find additional issues that can prevent problems. And if that tool is there, why wouldn't you utilize it? It baffles my mind.
Okay, follow up to your answer just now. With the extension from a 1,000-mile inspection to FRA regulation extension to 3,000-mile inspection, would that increase the availability to have these cars and journals inspected?
Increasing the mileage?
No, with the increase of mileage, did it decrease the amount of inspections by your craft?
That is correct. Under the 215 regulation, which I had referenced before, which I believe is dated, there used to be more inspection points. There used to be more railroads because when those cars are placed into a train, they're supposed to receive a mechanical inspection by a qualified mechanical inspector to assess the total health of that freight car. And under today's railroad structure, that is done less and less.
Thank you. Next question, Mr. Hand. With the addition of longer and longer trains currently run across the rail system networks, at what point is the current equipment invalidated due to the length of these trains, whereas the radio is unable to reach the head end of and communicate the defects?
I think that's a valid concern. I guess it would depend on the area. If a train hit a detector and it alerted it for a critical stop, I mean, that's a valid concern. I don't have that answer for you. That's why there's avenues we can take that would give the train crew real-time data.
Okay, thank you. Mr. Hopewell with NS. With these longer trains, as just previously discussed, does the PTC system currently in place allow for the ability to inform the train crews through the PTC system as it does the ATC desk?
Currently, the PTC system is not set up to relay those messages. We're looking at means to enhance the means to spread those further, but currently they are not.
But it has the ability, correct?
I'm not aware of that ability.
Okay, the last question, does the NS have the ability to install, remove, turn on, or turn off any of the detectors along their system?
We do occasionally make changes to detectors, and we analyze the line segment and the trains and the commodities that run over that route, as well as other considerations when we do so. Our average spacing on our key routes is currently 13.9 miles across our system, and the addition of our additional detectors in our action plan is going to tighten that up even more.
Okay, Mr. Rush, I have a couple questions for you. Are there any standards that's been referred to the AAR, to the networks, that from the car manufacturer or journal manufacturer that would recommend a heat threshold prior to the installation of this into the networks?
A heat, I am not aware of any.
NS has different thresholds from what you've answered the question earlier. They've come back with a higher number than what the AAR recommendations. That is, your department is just making recommendations, not regulations that the Class 1s or any other railroad has to follow.
So I think you're referring to the mate bearing temperature, I suspect specifically. I will tell you, first of all, that those are car repair billing rules. They're not mandatory, but I will tell you that's one of the specific thresholds that we will be re-examining as to whether the current threshold in the AR car repair billing rules is appropriate or not.
Thank you. Madam Chair, I have one more question. Mr. Cox, last question. With the longer trains that we've just discussed with the others, is your department and your craft seeing any additional issues due to these long trains traveling across the networks?
Yes, I have had conversations with qualified mechanical inspectors where the cars have come into a shop and they're seeing components that are not traditionally worn out, such as Fowler blocks and more technical components, and the pockets, the draft pockets that hold the cars together at the couplings. Normally, you would see some other type of failure, such as breakage or collapse of a cushioning device long before you'd see any type of wear out.
Thank you. Thank you, Madam Chair.
Quinn Norman with the BRS. Mr. Hopewell, was there additional hot box detector installed between milepost 49.2 to 69.01?
Is there a specific time reference to that installation?
No, it's within the last month or two since the derailment.
Yes. So as a start to our action plan that we announced just prior to that, we did take the initiative to install additional detectors. Our plan's targeting any of those spacings that are greater than 15 miles, and that was an opportunity to get started with that one.
Also, can you tell me about Norfolk Southern's training methods as far as training signal employees, craft employees on wayside detectors, hot boxes, that type of thing?
Echoey, but training generally?
Yes, training.
So our employees have, there's a couple different methods of training. We have prescribed training that's delivered by our system that delivers all of our other training, a lot of our other training electronically. That's to all of our employees. We then have more targeted efforts that we can deploy in addition to on the job. Our onboarding program, as you know, for BRS employees is a year that's heavily on the job based. We also bring our equipment suppliers out, and they do very, very focused hands-on training with our folks as well as needed.
So is this training done by person, virtually? Is it both, a combination, like you were talking?
I'd say with a combination of those methods, it's both.
How often are the craft signal employees trained on wayside detector maintenance and testing practices?
I'd have to check the interval that repeats at. I believe it's annually.
How does Norfolk Southern record and track wayside detector testing maintenance practices that are performed?
Our maintenance practices and expectations are documented in a test and maintenance procedure, similar to many of our other procedures for other signal and crossing type equipment. They define the intervals, they define the procedures to be done at those steps.
In January 1st, there was some electronic leader positions that were abolished. Are they looking at bringing those positions back? They're the people kind of responsible for helping test with the maintainers and help teach and train. Are there any considerations that way?
Would that have been January 1st of
21, sorry.
2021? So I was, that situation, I wasn't involved in that move at that time. I talked to some of the folks who were. So I did my understanding is that there were 5 total positions. I looked into this after, this was made more public, that there were 5 total positions that spanned what used to be called the Pittsburgh Division for us, which runs 2/3 of the way across the state of Pennsylvania. So I did an analysis of just the trouble tickets that came in on detectors for the year prior and the year after that change was made. And we observed that the number of trouble tickets were about the same, if not a little bit less, after we made that change. We'll always consider, what's the best way to apply our workforce to get, the results and the level of proficiency that we need.
That's all I have for the moment.
Hey, I'm Dennis Wilson with TCU. Questions for Jason Cox. Mr. Cox, in earlier answers provided by you, I believe you said that there were fewer Class 1s.
I'm sorry, would you mind speaking up a little?
Speaking up?
Yep, there you go.
Right.
Holding it closer. Yeah.
Did you mean fewer Class 1s or inspectors and points?
Yes, thank you for that. It's kind of one and the same. So yes, the overall result is fewer inspection points. And as I've testified to previously, there are a lot of points that have been evacuated of car safety inspectors altogether and relying on the train crews to only do the 12-point Appendix D inspection. You know, I think it's important to outline that the rail system is an interchange system, and its safety is only integral to its poorest actor. Thank you.
All right, so Mr. Cox, Norfolk Southern furloughed many of its employees, which included a large number of safety inspectors, and closed outlying points where some of the safety inspectors worked. Norfolk Southern then increased train lengths and shortened inspection times. What has been the result or consequence you have seen as a result of this efficiency endeavor?
Yeah, I believe the term I'm looking for here is time stress. When you decrease from 3 minutes per car to a third of that, you see issues creep into the system. Defects that should be detected can't be detected under that type of time stress. It's a real problem, and it needs to be corrected. It should be pointed out, and it should be corrected.
All right, the last one, Mr. Cox. You stated that field feedback by NS Supervision in reference to the FRA Administrator Bose's letter was that the letter reads as a suggestion versus a directive. So given the choice of a more thorough or a safer inspection or an abbreviated inspection, NS Supervision chose the latter?
Yes, in that letter, when, and I testified to this earlier too, when the letter was presented by the safety inspectors for freight cars to local management at various spots across the NS system, the general response was, this doesn't say we have to do anything, and if we don't have to do anything, we aren't going to do anything, and they're going to pursue the minimum standard, which I believe I've accurately outlined here is unsafe.
All right, thank you, Madam Chair. I have no further questions.
Any questions from the International Association of Firefighters?
I need to cede my time to the representative from SMART.
Okay, thank you. Jared Cassidy with Smart TD again. Mr. Rush, earlier you were talking about the studies being done with MXV and the different research and development. I'm curious, are any of the applicable labor organizations a part of that R&D effort from the AAR or any other Class I railroad?
The AAR research program is developed by its members, which represents, again, large and small railroads. We have a research committee which makes recommendations for our research program. It contains representatives not only from the railroads, but we have, for example, Federal Railroad Administration attends our research committee meetings. We have academics attend our research committee meetings, but we do not have labor representation on our research committee.
Okay, thank you. Mr. Hand, I'm going to kind of get into your career here. And it's hard for me because I am a conductor and engineer to not make statements. I just want that to be known. So in your career, have you seen changes in the defect detectors and how they applied to the information given to train crews? And what I mean by that is, are there less audible alerts than there used to be? Are there more silent detectors than there used to be? In your opinion, overall, has there been a reduction in the quality of the way the defect detector is being used in the industry?
Yeah, that's a good question. And I've kind of dove into this and, back in my time at UP, which we're not going back too far, but 2018, they utilized an entrance and an exit message for hot bearing detectors. From my knowledge, that you're either getting an entrance message or an exit message now. Now, when you couple that with longer trains and there's no entrance message, is that hotbox even working? Is the radio working? So yeah, there's been cuts, which I don't really understand. Like the radio traffic has gotten less due to remote authorities and things of that nature. So I'm not real sure why they're cutting out entrance or exit messages. But yeah, that's a significant change.
Okay. Mr. Cox, I'm gonna need you to put your tapping shoes on. We're gonna go quick here. So that's a reference to say, pick it up. On quality and quantity of the inspections, have you seen any deterioration in the frequency or the number of inspections that are occurring? And do you feel that the quality of the inspections that are being done now is at the level that it used to be prior to, say, the last 7, 8 years?
Yeah, when you look at the data that I submitted, where the inspectors were spending at least 3.5 minutes plus per car on this 215, the full mechanical inspection. The inspections back in those years, dating back to 2014, I provided this data, was very thorough, and there were a lot more exceptions to the freight cars taken during that time. When you look at it now, that same 215 inspection, according to the last page of that data, shows that the inspectors were taking 30 seconds for that 215 mechanical inspection.
Can you talk to me about that 30 seconds and what does that look like? Is there pressure? Is there outside pressure? I mean, is someone standing there with a stopwatch? What does that pressure actually look like visually for the carman?
Well, I would reference the docket exhibit group G25, where we were interviewed, and there was a recording that was discussed on the record. Now, due to protecting the anonymity from that individual from retaliation, that recording outlines the fact of a NS supervisor threatening them, the safety car inspectors, with discipline if they did not get the number down.
And then you were talking earlier about the removal of carmen from a number of locations, some of which in their entirety. As a conductor and an engineer, I know the importance of a roll-by inspection. Can you briefly explain what harm has been done by fewer QMIs performing those roll-bys, and what kind of stuff it is actually that the QMI gets to look for as kind of that last opportunity to inspect a train before it departs the yard?
Yeah, so an instance at Decatur, Illinois, one of the places that this particular train went through, if memory serves, there were 2 inspectors on duty, but due to the time restraints, the fact that they've reduced the number of inspectors, there was no opportunity to do a roll-by inspection on that train. And it has been proven as an efficient tool that roll-by inspections can be a last-ditch effort to catch more serious issues before they even have a chance to get to a detector. Like I said, the human inspection and the detector should be a combined firewall of safety to protect the workers and the public.
Have you ever heard a bad bearing rolling out of the yard?
Yes.
Okay. During the roll-by, correct?
Yes.
Okay, thank you. Sorry, Chair.
All right. Thank you very much. We will now move over to Bill Schoonover with PHMSA. Or Carl can go first, whichever one wants to go first.
Let Carl go first.
Carl will go first.
All right. Carl Alexi, FRA. Question for Mr. Hopewell. This is regarding the advanced train control desk and the workload on the person on that desk. How many detectors, all types, were in service on the Norfolk Southern system on February 3rd of this year?
To provide a rough number, the hot bearing detectors, which are the predominant number in that equation by far, just under 1,000.
And roughly how many other, because there's a whole slew of different types of detectors, order of magnitude, how many other detectors are
Yeah,
there?
the other miscellaneous types would add no more than 10% to that, I would say.
Okay. In 2022, how many hotbox critical alarms did NS experience?
Reference my opening statement to be certain. That would be 618 alarms announced for for bearing-related alarms.
And then I think you said, so now I'm tracking you here. So then you said 14% of those were set out.
That's correct.
That's correct. And so that's about 84 cars. How many of those, were they all inspected and the bearings disassembled and evaluated?
I don't have the details of the mechanical follow-up that was done on those to further dive into the bearing issue.
Yeah, I'll have more questions on that in a minute. But regarding the detectors, do they have a health status, a way to check the health on those and report back to the back office so that when one of the detectors isn't functioning, you know about it?
Yes, the detectors have, in their logic in the electronics in the field, multiple ways by which they will detect if something is not functioning properly with them, an issue with a wheel detector or a scanner. And that's, in that scenario, it would announce itself not working, and we would dispatch someone to respond and fix the issue. We also have a system in the office that is a maintenance-based system that our employees use down to the maintainer level that provides them some insight and predictive ability to get ahead of maintenance issues.
Do you dispatch someone to look at that, the detector that's malfunctioning? Do you dispatch a signal maintainer?
Yes, if our wayside desk sees something, they'll pass it over to the folks on an adjacent desk that dispatches our maintenance personnel.
Is there a time frame in which you dispatch a signal maintainer to go check that out?
Those issues I would say are usually immediate because they're going to be stopping trains until we fix it. So yeah, we don't delay those.
Okay. Okay, thank you for that. Let's see. We know that we talked about trending analysis, and we know that analysis is only as good as the data. But that data is only as good as the quality or the effectiveness of the equipment, the detectors, and the maintenance standards of those. So how do you take that into account? Do you look at that and say, well, if we looked at these detectors more often, we'd have more confidence in the data that would allow us to do these, and we'd have more confidence in the results of the results or the data that's coming in?
We have taken a look at our procedures recently and made some modifications to provide clarity, mainly for our people executing the task that they're expected to do. I would say we haven't seen issues that are pointing us toward the need to make radical changes with where we're at, benchmarked with some of our counterpart railroads, and I feel like we're all in the same general ballpark of frequency of those tasks.
Okay, and who makes the final decision of what action to take for a trending bearing? And what document guides that decision?
So we have an SOP that we've generated and upkept for the wayside desk analysts, and we make adjustments to that as needed based on we look at actual events. we've actually created our own alerts based on experiences that, and modified the SOPs accordingly.
But is there one person, is there one belly button that gets pushed to make that decision?
In terms of modifying that document?
No, making that decision on, you know, when you get a trend, you know, the trend analysis, somebody does it, somebody says, hey, there's an issue here. Who makes a decision on what to do?
I mean, it's the person on the desk at that time.
Okay, they're empowered to make that decision. And
Yeah,
affect
absolutely.
that.
Even if it goes above what the SOP calls for in terms of stringency.
Okay, all right, thank you.
Chair Hamidi, can we ask that the party members remember to hold the microphones closer to their mouths, please? We cannot hear them over here on the tech panel.
I think you just did that, so there you go.
William Schoonover. Madam Chair, I'd like to cede my time back to FRA. I think their line of questioning is important.
Thank you. Again, this is Carl Alexi, FRA. And staying with you, Mr. Hopewell, what is the average distance for a burn-off?
Please hold the mic closer. Thank you.
Okay, how's that? What is the average distance for a burn-off journal derailment past the last hot bearing detector or acoustic bearing detector?
Sound better? All right. I don't have data points in front of me right here for that. The place I would reference would be that 2017 TTCI study that several of the others have already mentioned. I think that has some good data relative to that question.
Okay. And Mr. Hopewell, this may be for you, it may be for Mr. Ewand or Mr. Rush. When a hot bearing or a wheel set is set out or a car is set out for a hot bearing, and do the railroads do they disassemble those or do they just replace them? I don't know the cost for doing the disassembly and the analysis versus what it costs just to replace them and send it on. Because well, I'll let you answer the question. I'll follow up. And it's Mike or Mr. Rush, if you know.
Sure. You know, so bearings typically are not discarded. They're reconditioned. So if you have a problematic bearing and it's removed, it's going to be broken down and analyzed. It may be appropriate for reconditioning. It may not be. Perhaps components can be used. Perhaps not. But there will be, you know, it will be broke. You know, the bearing's not going to just be taken and thrown in the trash. It will be taken apart and analyzed.
And that data is captured somewhere of what the findings are of that inspection?
So when the data is captured, certainly not by there's no industry-wide repository in terms of, if that's what you're talking about, that I'm aware of.
Yeah, Ms. Lamb was starting to talk about this as understanding, you know, what the life cycle of these are so we can begin to be more predictive rather than reactive. And that type of data that you would get from a teardown of a bearing would be useful in establishing that. So I'm just wondering if there is that repository, that sounds like there isn't, where that data could be overlaid with the mileage of that wheel set.
No, but I would like to point out that we do have a committee, the Wheels, Axles, Bearings, and Lubrications Committee, which does spend a lot of time on bearings and spends a lot of time analyzing these questions. There's a lot of expertise at the table there, not just the railroad expertise, but the supplier's expertise as well. And so the wealth of data and knowledge that the individual companies has is brought to bear in that committee's deliberations and discussions.
Okay, all right, thank you. Let's see. Back to Mr. Hopewell. So we had one person at the advanced train control desk. What happens, and I understand this person was working from their house. What happens if they had an accident, they fell down a set of steps and, you know, they were unconscious? What is the resiliency, the redundancy in your system that would not create some gap in information flow along those lines?
So to address that a bit, the analyst was performing work remotely at that time. We have procedures specific around that, and then the same expectations regarding performing their duties apply. Now, going to where we've added some resources to that desk, we won't have that situation anymore. At least one person will be in person in the control center at all times. Prior to that, we had mechanisms in place where a lot of our people on adjoining control center desks that work in conjunction with the wayside desk are cross-trained and have rotated through and are familiar with the work and how to do it. So we have those folks aware and ready to step in if needed.
Okay, thank you.
Thank you.
Let's see, let me go to Dr. Tarawana. Oops, I'm up against my time. What KIP reading or wild reading would potentially cause a bearing damage?
So basically, like bearings, as I said, they're very resilient. Okay, so usually bearings, new wheels might have a kip anywhere from 15 to 25. That's or below 20. That's normal. Once we get above 20, it becomes like elevated, right? But there is a range between 20 and 60 that you'll see a lot of the bearings are operating in that range. The bearing will see those vibrations, will feel them, but they're not gonna, they might accelerate, but it's not significant. Now, once we go above 70 kips, so anywhere between 70 to 95, what we're causing is those kips, higher kips, are causing the bearings to vibrate and be caught misaligned. So there is excessive vibration. The rollers, even though they're in a cage, they still have some movement. Once a roller enters the load zone, because they rotate in and out of the load zone, once it enters as misaligned, it's gonna get stuck as misaligned and it's gonna generate higher temperatures. If this continues, so basically like higher kips make the bearing more susceptible to this type of, so it will aggravate. Once we reach 95 kips, it has these severe temperature trends, and it will accelerate the failure of that bearing.
Okay, thank you. And Madam Chair, if time allows, I have additional questions.
Village of East Palestine.
We'll give our time to the FRA.
You guys caught on fast.
Appreciate it. Okay. Okay, how often, this is for Mr. Hopewell again, how often do you inspect, does NS inspect the hot bearing detectors, the lenses for dirt and whatnot to make sure they're functioning right?
The basic inspection that involves a physical walk around and check of the trackside components is done every 30 days.
And how did you arrive at that frequency?
We've been at that frequency for some time, in my experience. You know, despite the fact that these are not regulated devices now, we're in a department where we're used to functioning that way and performing all of our other tests and inspections. So this work kind of just falls in line with how we've set up other tasks that we have our folks doing.
Okay, thank you. And back to Professor Tarawana. In one of your papers, you talk about onboard sensors or detectors on a car. How is that data from those sensors transmitted to? Where would it be transmitted to?
Okay, so what you're referring to, they're basically, we did some pilot testing. It's not, it's basically been deployed with several customers on a pilot version. So the way these work, they are mounted onto the adapter, which does not move, and it stays with the car. So even if the wheel axle is removed, the adapter will stay. So these monitor the temperature and vibration of each individual bearing, and they wirelessly report that data to a gateway or monitoring system that's on each car. And then that data gets sent via phone SIM cards to the cloud, where we basically can analyze. But a lot of the process is automated. So basically it will continuously monitor, and if it sees certain thresholds, it will start aligning bearings and wheels based on let's say top 10 worst bearings, and then this way we just look at the specific bearings that have maybe concerns versus looking at everything. So if everything is healthy, there's no need for me to be looking at all of that data.
Okay, all right, thank you for that. And one more question for you. So if there's a hot bearing, a trending alarm, and the railroad sends someone out there to inspect it, whoever it is, how long does it take for that bearing to return to ambient? If it's glowing red, how long does it take to return to ambient temperature?
You're not going to see it glowing red. So the bearings, like we have bearings in our lab that sometimes operate at 240 degrees F. Okay, you're not going to see it red, right? It takes, as I said, to cool down from 240. Let's say you're reaching 240 or 200, to cool down from 200 to ambient, it will take anywhere, again, from 30 to 45 minutes. That is the thermal constant, what we call it. This is the time it needs for a bearing to reach a certain, like 63.2% of the steady state. So it will take it about 30 to 45 minutes, depending on how hot it is. If it's lower, then it's going to take it less time.
So it's conceivable that there could be a hot bearing on a train, and when the crew goes back to inspect it, and some of these trains are pretty long, crew goes back to inspect it, they would come upon a wheel set that looks perfectly normal when it was overheated, but by the time they were able to walk back to the back of that train, it had cooled down to be normal, basically.
Yes, I mean, the minute, if the bearing is not critical, I mean, it's not starting to burn off, if the bearing is just simply hot and you just stop the train, the temperature, immediately starts going down. So the slope is steep at the beginning, but then of course it tapers down. So if you check on it after 15 minutes, it will significantly have cooled by maybe 50 or 80 degrees.
Okay. All right, thank you very much. Mr. Ewand, I have a couple seconds left. I know you did the evaluation of the axle for this, for this incident, the East Palestine incident. Has a causation for that failure been determined?
So the purpose of our analysis was factual only, so we provided a service of tearing down the axle for the NTSB. We were not asked to provide any analysis.
Okay, thank you.
All right, thank you. We will now move to the industry table. We'll start with Norfolk Southern.
Thank you, Dave Gooden for Norfolk Southern. My questions are for Mr. Hopewell. Norfolk Southern created the 953 alert of its own initiative. Is that correct?
Yes, that's correct.
And why was that created?
So, as I mentioned earlier, we have a series of alerts. The baselines of those are based on the AAR specs and the YMAID codes. The 953 alert goes above and beyond those in terms of sensitivity, and it was actually originated in-house, put into effect in late 2021, and it came about through our wayside desk analysts taking notice and speaking up based on events they had seen, and getting with our engineers who developed that trending algorithm for that alert.
Okay, and speaking of which, how many alerts do you understand are routed to the ACT on a typical 8-hour shift?
Yeah, I think this is going on top of what Mike started off with here. understanding that the 300 number was quoted in testimony, we looked at some data, and we saw a number typically running, as you average out days, to 180 per day. That's amongst many types of alerts beyond bearings that might come into a desk. That kind of rounds down to 3 to 4 actionable alerts per shift in terms of that frequency, and then going by the 876 number I quoted in my opening statement, that comes to about 2 or 3 per day, bearing-related desk interventions on average.
All right. So what kind of action would the ATC have to take with those 3 or 4 actionable type alerts and alarms?
So the alerts may come in as an indicator of a bearing issue. The alert might be intended for bearings. Oftentimes, the alert itself might result in another issue being found, perhaps with braking. The analyst has the ability to see the details that come in and that data to look at all the wheel sets on the car to determine if there might be a braking issue. So they might ask the crew to take action with regards to what has the signature of a braking issue, or go back and inspect the bearing for heat.
All right. Thank you, Mr. Hopewell. No further questions. I yield my time back.
Trinity Rail has no questions at this time.
Oxyvinyl.
Paul Thomas, Oxyvinyls. We appreciate all the witness testimony. It's been very informative, and we have no questions at this time.
Are there any other questions for that table? Nope. All right. Hearing none. We will, you guys are okay to keep going? All right. We're going to move on to the Board of Inquiry, and we will start with Vice Chair Landsberg.
Thank you, Chair. You know, we've been spending a lot of time talking about standards and what's appropriate here. And AAR is a trade association that also sets standards. Am I correct, Mr. Rush?
That is correct.
Okay. That's unique in the transportation world. I'm not aware of any other mode of transportation that has the same setup. My background is in aviation, and we have seen what happens when a regulatory agency such as the FAA abdicates its responsibility to a manufacturer or to an air carrier. Are your standards recommended or mandatory for your members?
Okay, and first of all, I'm going to just take a point of 15 seconds and correct a response I gave to Mr. Alexi. The Wobble Committee does have a database of what's found during teardowns, so I did misspeak on that one. Okay, with respect to the AAR standards, it's a little complicated. So the AAR standards are a function of the interchange agreement, which is a contract in essence that the participants...
Are they recommended or are they mandatory?
So
yes or no?
I can't give a yes or no answer. Neither one would be accurate.
So some are recommended and some are mandatory. Is that what you're saying?
No. If you would give me the privilege of giving me 1 minute, I will answer it.
You get 1 minute.
Okay. So the signatories to the interchange rules, which include carriers, equipment suppliers, et cetera, agree to be bound by the interchange rules. And what the interchange rule, what they say is by contract, you will accept a car that meets the interchange standards, for example, and you will agree to abide by the interchange standards in terms of the equipment you provide. But because it's a matter of contract, any two parties or multiple parties can agree to amend their contract, if you will.
So it is basically recommended and you leave it to the parties to make the decision. Does one have to pay to be a member of the AAR?
AAR's full members pay dues. One does not have to be paid to be a signatory to the interchange rules.
Do they have to pay to get the standards?
The signatories to the interchange rules generally, everybody pays for the standards. If you want a copy of the standards, whether you're an AR member or
How
not,
much is a copy of the standards?
if you want a copy of the standards, generally you're going to have to pay for them.
How much?
Actually, it depends on the standard, but a couple $100. I mean, particularly.
Want a full set? How much?
I don't even have that number in front of me.
Could we get that?
Sure.
You also mentioned that you have a number of safety committees, and that's commendable. How many members on these safety committees, and how many committees are there?
Yeah, I just want to clarify your previous question. I do want to clarify one thing. So not all the standards are accessible to everybody, and I want to make a specific reference to our PTC standards, which involve some security concerns. So some standards you have to have a need to know in order to have access to the standards because of security concerns. So I just want to clarify that. Okay, with respect to the AR committees, the size of the committees vary tremendously in terms of the different areas.
How many committees do you have?
How many committees do I have?
Yeah.
Oh, I'd say with respect to the committees under my jurisdiction, probably about 35 or so. I actually don't have a specific
You
number.
mentioned that you've done a lot of research in your wheel and bearing committee, which is, of course, directly germane to what we're doing here. Could you provide that research to this investigation?
You say research on the bearings or?
Yeah, your wheel and bearing research. I think that it would be very helpful to our investigative team to have.
Research goes back many, many years.
That's fine.
So I'm not, we will try to be a fulsome response as we can to that. Okay.
That would be most appreciated. A question for Mr. Hopewell. Our investigation revealed that 20 out of 77 cars in this consist had defects. That's 25%. How do you plan to improve that record going forward?
I'm not aware of the circumstances by which those defects were identified, so I can't speak to those specifically. Our car inspection and quality control processes are not something that's in my line of reporting either. But our mechanical department has standards around quality that they maintain.
I think it would be appreciated for the investigation if we could get a little more detail in that regard. As I say, the investigation uncovered a significant number, and that sort of goes to what Mr. Cox is saying. Mr. Cox?
Yeah, if I could add to that. It's my understanding that those defects were found visually by the Federal Railroad Administration after the disaster. And I would like to reiterate that had inspectors been given the time and the manpower resources to do what they need to do without the time stress, that would reduce what you are talking about.
Okay, thank you. Chair, my time is up. I have one more question. This is for Mr. Rush. High hazard flammability trains, HHFTs, they're currently defined as 35 cars in total on the train, or 20 if they're bunched together. And yet we've seen here that as little as 5 cars can create a major disaster. Should that definition be changed?
The HHFT, of course, regulations, and those are federal requirements, were developed in response to specific concerns over flammable liquids. Of course, here we're not dealing with a flammable liquid. I think it begs the question of what requirements are appropriate for flammable gases or any other particular hazardous material, and you need to drill down on the specific requirements and see what's appropriate for that particular commodity. I don't think you should automatically, again, the HHFT rules were developed specifically for those liquids.
Well, it seems to me that that's something that both the FRA and the industry ought to be looking at as a result and an outcome of this particular incident, because it's very clear 5 cars basically cleaned out a significant portion of East Palestine, and I think the regulations are not covering this in an adequate sense.
If I may, The Rail Safety Advisory Committee has as one of its tasks that we will participate in taking a look at that issue.
We'll look forward to it. Thank you, Chair.
Thank you. Member Graham.
Thank you, Chair. This is for Mr. Hopewell with Norfolk Southern. You said just a minute ago that an analyst normally has 180 alerts, or the desk has 180 alerts per day, or is that per shift?
Don't have that in front of me. I believe that was per shift.
Per shift, okay. And how long is a shift?
The analysts work 12-hour shifts.
12-hour shifts, okay. And you said 3 to 4 actionable items per shift?
So that's per hour.
Per hour.
Per hour, and then of those that are bearing related, that calculated out to 2 to 3 per day.
2 to 3 per day. Okay, and then how long does it take to determine what's an actionable alert for the analyst?
So the alert and basic details, including a level of criticality, are populated for the analyst in their screen. So that in combination with them being populated in order of time that they came in, gives them high-level information to start their analysis. In terms of how long it takes for any individual one, based on my experience with them, some of them can be rather quick. If they need to monitor them for potential future action, they can move them to a specific queue, knowing that they're kind of a watch item, not an immediate action, but a watch. So there's a couple mechanisms they have to help facilitate that.
Okay, great, thank you. Also, as it relates to the hot bearing detectors, how is the K value calculated?
So the K value is a statistical way of leveling the heat in one particular bearing to compare it against the levels that are read within the equipment and within the train. So there's a KT for the whole train and a KE for the piece of equipment. And that helps just kind of level and do the statistical analysis in a more even way because of kind of leveling it against the conditions of the rest of the whole train as it exists at that time.
Thank you for that. Per Norfolk Southern's data, it said that 67%, and it relates to the 953 alert. It says here, 67% of the 953 alerts in 2022 were limited to a single occurrence. Do you know how many of those 953 alerts had a second alert, but not a third alert?
I don't have that readily at hand to answer your question.
Okay. Do you have an estimate or were there ones that were you aware that ones had a second alert but not a third?
There is some fallout in that statistic. I think you can kind of follow that all the way to the end and see the confirmed bearing catches that were made, and it kind of tapers down to that point.
Okay, thank you. And with that 953 alert I noticed the data said 55% of those were braking related in the data that was provided to us. Can that alert differentiate a braking issue between a bearing issue?
So what happened, this can occasionally happen both for alarms and for alerts. When there's a braking issue, the heat can propagate its way toward the bearing, and therefore the bearing scanner will pick up that heat, even though the bearing itself is not the root cause of the heat. What the analysts can do, and they may or may not be able to discern this, but if an alert is generated for a bearing, they're going to stop the train and tell them to inspect based on that basis. What the train crew may find may be a braking issue as they discover it. Sometimes a a signature of a braking issue will be evident in what the analyst can see, and they'll tell the train crew that at that time. It's just based on what information they have, they'll relay it based on how they see it, and then the train crew will verify it.
Thank you. And one more question for you. In the past 20 years, do you know how the criteria has changed for hot bearing detectors for the alerts, or has it? Are you aware of any changes?
The alerts themselves were not put into use until the late 2000s. That experience was started as an effort among multiple railroads, and I would say that over time, we learned based on events, just in the same way that we've learned in developing the 953 alert ourselves, and based on the baseline guidance and the AAR values that can generate the YMA codes, we've adjusted and adjusted as necessary based on our experience with confirmed failures, following that data back. So that's been our approach. And like I said, in the case of the 953, we generated an entirely new alert based on our findings.
Thank you for that. Thank you, Chair.
Member Chapman. And we don't have to do the timer. Each of us are going to finish our line of questioning and then go through another round. So we're just not going to time everybody.
Thank you, Chair. Mr. Rush, forgive my unfamiliarity with the regulatory and standard setting paradigm in the rail industry. I come from aviation, like Vice Chair Landsberg, and frankly, Member Graham as well, which of course is very highly regulated. And so I'm some questions for you just to kind of help me understand how this works. You indicated in answer to an earlier question that setting the AAR temperature thresholds was done as a matter of experience. Is that correct?
That's correct.
And you also indicated that AAR and the industry are now considering lowering those thresholds, at least taking a look at that. If the current standards are based on experience, what would be the basis for lowering those thresholds?
I'm not sure I said lowering the thresholds, and I'd like to distinguish between the trending analysis rules and the absolute temperature thresholds, such as temperature above ambient, bearing mate thresholds. So the car repair billing rules are an authorization to perform repairs. The railroads have done further analysis to determine what is appropriate in terms of actually stopping trains and taking a look into whether there's a bearing temperature or not. And actually, let me just focus for a minute on the trending analysis, because I think that's a very good example of what I'm talking about. The AAR trending rules, which were adopted 15 years ago, as Jared pointed out, they're a very recent innovation, should be viewed as a kind of a general authorization to perform repairs within the parameters of those rules, but they really need refinement to be practical. I mentioned that each class, if you total the Class 1 railroads together, they have 150 trending rules which refine that AAR general car repair billing rule. If you didn't use those 150 rules, the AR rule would really be impractical. It really needs further refinement. So each of the Class 1s, again, did their trending analyses. Jared talked a little bit about what they've done.
I feel like we're drifting away from the core question, which is the setting of the temperature thresholds. Again, that was based on experience. I thought I heard you say earlier that the industry is considering lowering those thresholds. Is that correct?
Okay, I'll be more precise. So, for example, the 170 degrees above ambient temperature, which was a car repair billing rule, not all the railroads, if you go back in history, used 170 degrees. They used some of them used higher temperatures. They are now all committed to using 170 degrees on their railroad to take a look at bearings. The bearing mate temperature threshold. I think there's a belief in the industry that it should be higher. That that in fact Class 1 railroads are not using the threshold that's in the car repair billing rule because it's an impractical rule. And so there's going to be an examination in terms of what the appropriate bearing made temperature threshold should be. It's really what we're going to do is taking a look at the temperature thresholds as well as training analysis and see what's appropriate. Not necessarily lowering them, just finding the best way of trying to remove problematic bearings.
Okay. When were the current standards set, approximately? What's the time frame in terms of when they were set?
Trying to remember exactly when the current thresholds, the temperature thresholds were adopted, not more recently than, let's say, 15 years ago.
Okay. And are those thresholds, whether they're the current ones or whether they're changed, are those established as safe operating temperatures? In other words, 168 degrees is safe, but 170 degrees is not. I mean, are they safe operating standards, and if not, what are they?
The thresholds are meant to stand for a point at which there's cause for concern and you need to take action. So let's take the 170 degrees above ambient temperature, which I think is a threshold most people have been focusing on here today. If you get an alarm, the crew will stop, it will go take a look and use a temperature stick, although there's some, which has a temperature threshold actually of 169 degrees just because of what's available out there in the supply industry. If that temperature still applies, so essentially it's a wax kind of a stick, they'll apply it to the bearing. If that stick melts, indicating a 169, 170 degree temperature, they will remove that from service. So yeah, it's an indication of that's a point at which, yes, you need to be very concerned about the bearing.
Okay, thank you. Chair, just one more quick question. Actually, Mr. Rush, let me come back to you on this one. I have to say, almost certainly in an industry such as aviation, this is the sort of thing that would be subject to a federal regulation across the board. Would AAR be open to regulatory standards set by FRA in this area, or frankly in the area of placement and threshold standards for hot bearing detectors?
If I may take a moment. So the way the railroad industry is a very heavily regulated industry. I'm sure as heavily regulated as the aviation industry. And we are the original heavily regulated industry. The AAR standards are requirements that are within the parameters of the Federal Railroad Administration standards. Some of our standards are incorporated by reference. In fact, a number of our standards are incorporated by reference in the FRA regulations. FRA participates in the AAR standard setting process. All the key committees we're talking about, FRA is present and participates in those activities. We work very closely together. At the end of the day, one of the advantages when you have AAR rules is the ability to quickly make changes to those rules and update them. That's an advantage we have over the federal regulatory process. But I don't think anyone should be under the illusion that we develop our regulations in isolation without regulatory scrutiny. That's not what takes place. Where FRA believes they need to step in, they certainly do so. But I think the system actually works very well today. There's lots of federal regulations. People shouldn't be under the impression that there's just industry standards. That's not true. Where you draw the line depends on the facts and circumstances, again, of what you're talking about in terms of a specific regulatory item or a specific item subject to AAR standards.
Okay, that's fair enough. I mean, I think the thinking that it's always easier to change an industry standard or faster, easier to change an industry standard than a regulation, that applies to any industry, I think. I mean, it's fair. Your answer is fair, and I understand it. I do think that FRA should give some thought to looking into this. I'm going to ask a question that maybe you can help us with. Does AAR car billing allow for repairs to trending bearings, not bearings necessarily that have breached the thresholds?
Yes, they do.
Okay, thank you. Thank you, Chair.
And on that note, I'm going to allow our technical panel to ask additional questions on that one to follow up on that answer, okay? So for my questions, Mr. Hopewell, does Norfolk Southern have a written or unwritten time limit for inspections of rail cars?
In my limited experience around our mechanical department, no, I have not seen one.
No policy no written policy on time limits for rail car inspections?
For limitations on time, no.
And no just general rule by middle management or anybody to push through on inspections to get rail cars inspected?
In my experience, the thing we have tried to understand with regarding time is to understand how long it takes in order to do the inspection thoroughly, safely, completely. We want the inspections to serve their purpose. If I was a mechanical manager, I wouldn't want to explain a train on the line of road breaking down, causing delays. So in my experience, we wanted to understand the time so it could be properly allocated, and that the planning of the operation of a yard could be built around allocating that time.
Okay. Are you aware of any discipline for carmen or any other personnel within Norfolk Southern for them not meeting certain time thresholds or limits?
Not in my experience. I was in our mechanical department for about 1.5 years, and I was in a position where I would have been aware of discipline for really any reason, and I'm not aware of any of that.
Okay, thank you very much. Julie, can you pull up Exhibit 38 of Group H? Mr. Cox, in some of the, and I've read so many of the interviews now, I can't even remember whose interview. And it might have been yours or it was one of the Carmen. 20 years ago, several minutes were provided for car inspections, and then it was stated that since precision scheduled railroading, that on average that was at some point reduced to 3 minutes and 45 seconds per car, and then reduced to 1 minute a few years ago. At this time, I want to refer to the deposition of Ryan Steege. Can you flip through that for a second? And I probably should have figured out which page it was. Go again. Okay, well, at what point, page 19, actually. Do you have page 19 of that? Back? Yeah, okay. So here on page 19, the question is, what is Norfolk Southern's goal for the proper time per car to inspect a train? Mr. Steege says, an individual car can be walked in about 30 seconds, so the goal, I'll just quote this, so the goal that we set is a man-minute per car, meaning 1 man, 1 minute per car. That includes the brake test. Asked whether that applies to a 40-foot car or a 90-foot car, the answer was yes. And then there's a reference to, in time studies we've done, a car can be walked in 30 seconds. Mr. Hopewell, what's a time study? Are you aware of what a time study is?
I'm aware of that term. It would be a means to understand how long it takes to do a task.
Okay, great. Julie, can you pull up Exhibit 41, Group H? Can you flip to the time study? All right, Mr. Cox, what am I looking at here?
What you're looking at here is a
Can
historic...
you speak a little closer to your microphone?
I apologize.
Oh.
What you're looking at here is historic time study data that was performed by a third-party contractor, Engage, for Norfolk and Southern. What you'll look at is it starts in 2014, and as you scroll through the exhibit, the inspection times go from, as I had previously testified to, 3 minutes per car on the outbound and 3.4 minutes on the cars on the outbound for inspections. And then it finally ends with the inbound inspection only being 0.5 minutes per car.
Mm-hmm. Yeah, so in fact, 2014, 2017, 2018, it said 3 minutes per car outbound and 3.6 minutes inbound. For 2019 and 2020, it was 2.5 minutes outbound and 30 seconds inbound.
And if I may, I'd like to point out that as you look at those time studies, the numbers stay consistent until you get to a particular era in railroad history where they initiated particular efficiency standards.
What do you mean by that?
I believe the layman's term for it is precision scheduled railroading.
We'll come back to that. Julie, can you pull up Exhibit 40, Group H? I only have 2 more exhibits. Okay, here. Wonderful, thank you. So here we have an email from Mr. Joe Wick, Senior General Foreman, Dearborn Division, Detroit Mechanical for Norfolk Southern Corporation. And it's, oh boy, I need to read it. Okay, our number, thank you. Thank you. Our numbers need to improve Our numbers need to improve right now. Instructions have been issued on how we are to accomplish this, and it doesn't seem like we are all acting on it. These numbers show that we are slacking off in the train yard and have no need for more help. Though we are struggling to keep up, not good at all. The latest plan calls for 90 seconds on both the IB, which is inbound, and the OB outbound. I know we can do better than that. Let's make this happen. The taskmaster entries are very important and detrimental to the operation as it pertains to this report. Let's get the numbers and reporting where it needs to be. What does that mean, Mr. Cox?
Well, what that means is these safety inspectors for freight cars are getting tore over spending 45 seconds aside for inspecting freight cars, and they want it lower to the minute per car that I have previously testified to.
All right, and while Julie pulls up the last exhibit for this portion, which is Exhibit 39 of Group H. How many, we have a lot of folks from the community and who are not part of the rail industry. When you're talking about a train in a yard and you're talking 30 seconds per side or 45 seconds per side, how many cars are you talking?
Are you talking about how many cars in a train that an inspector will look at?
Yeah.
I mean, under today's standards, you're looking anywhere from 140, maybe in excess of 200.
30 seconds per side on in excess of 200.
That's correct.
Okay, great. And can you flip? Okay. Next one. Maybe a little. Field scorecard. What is a field scorecard, Mr. Hopewell?
In my familiarity with the document, it's just a collection of averaged measures regarding the different inspections done at a particular location.
Thank you. Mr. Cox, you want to add anything to that?
Yeah, when you look at this exhibit, you'll see a column labeled man minutes per car inbound, MMPC.
Can you speak into the mic? Sorry.
I'm sorry. It's called man minutes per car inbound, or MMPC, as an abbreviated column almost in the center of that document. And this is attached to the email where the supervisor is saying, "Good job, inspectors." And as you can see, the system overall average is 1 minute per car.
So it's good job for 1 minute per car.
Correct. Not for finding the defects, for 1 minute per car.
So I'm going to ask Mr. Hopewell, I'm going to ask you again, does NS have a time limit for inspections of rail cars?
In my experience, no. I would point to the scorecard. It shows some locations over 2 minutes. I would point out that also in this time frame, we've also been employing technology that assists, especially with the air brake portion of these tests. And a lot of our efforts were also around best practices, consistent forms of measurement. For example, this task may, in various places, have been measured from the time you left the office to the time you came back, instead of measuring the time you actually took to inspect the cars. So we pushed for consistency. We employed technology and refined our processes. That's my explanation for this subject.
Thank you. Mr. Cox, are you aware of anyone who's been disciplined for this, for not meeting lower times for inspections?
So historically, the reports that come to my office is they have not disciplined for being less than the goal in time, but the reports that come to my office is, hey, I'm being told I'm being watched. I'm not going along with the program. And there's some other means that they look for. They'll tell you they're watching you. They'll let you see them watching you. They're waiting for you to make that mistake. And I would like to point out that the public file for OSHA is rife with these types of complaints.
Thank you very much. I apologize for taking so long on that line of questioning, but thank you for that. You're good? Member Graham.
Thank you, Chair. This is for Mr. Hopewell. I was looking at the interview transcript for the analyst on duty the night of the derailment. You talked about a priority hierarchy for addressing multiple alerts at the same time. Can you expand on that a little bit?
Yeah, I think that was in what I explained earlier about how the alerts and how they're populated at their high-level screen give them a basic understanding of what the alert is. The system can assign level of criticality, and then they can also tag particular first-time alerts for repeat follow-ups for trends. So I think those are the means by which an analyst would be able to prioritize their alerts.
Okay, thank you for that. And let's talk about the analyst and how the analyst communicates with dispatch. How does the analyst normally communicate with them?
So if the analyst reaches a decision that a train needs to be stopped or advised on any other action that they need to take, the analyst has access to the radios themselves, and they can reach out directly to the train and give them that information directly. If the analyst is unable to reach the train, they will then contact the dispatcher and seek their assistance in contacting the train.
And how do they reach the dispatcher? What communication device?
A phone call, my understanding, is usually the first attempt at that. And if that doesn't work out, there's a hierarchy in the dispatching office, assistant chief dispatcher that they can escalate to if needed.
They also do email?
An email is sent. It's more of a record of here's what I asked this train to do. A lot of times that email will indicate I've already contacted this train. It's for awareness. It provides a graphical representation of what they saw. It's more for awareness. It's not for the first making the contact.
Okay, and then on the night of the derailment, how the analyst was working at home, if I'm correct. How did that communication change, or was it similar?
Those methods would remain the same unless some kind of in-person interaction would be necessary. In that case, the analyst might contact a partner analyst in the office and say, hey, go walk over there and find this person for me. But in terms of the night of, there really wouldn't have been a meaningful change due to the fact of being remote.
Okay, thank you. And this will be for you also, and maybe AAR also. We talked a lot about bearings. The professor also talked about the bearings, the life of a bearing. Does the railroad track mileage or that life of the bearing on each rail car? And let me preface it by, I come from aviation also, and just about every single thing, every part on an airplane is tracked. It has an inspection time. It has a life limit. It's got to be tracked. It's got to be replaced. Does that happen with a rail car with bearings? Either or.
Mike's probably a little more aware of it.
Yeah, so let me give you, I should be able to give you a more precise answer than I'm about to give you. So if you remember, when I take that wheel off, I'm taking the bearing. So the bearing is tied to the wheel, right? And so that is tracked. So in essence, you could look at a particular wheel set and figure out how long that bearing has been on that wheel set.
Okay. Is that life tracked? So let's say we have a reconditioned bearing, and it's got say it's a 50,000 mile life. Is that tracked on that car? Does a railroad track that for that particular car?
So any bearing that is put on a wheel set will be expected to have a life longer than the wheel. No, you're not going to put the AR rules are such that the expected life of the bearing is going to exceed the expected life of the wheel. You don't put bearings on. We don't have a system where you can put a bearing on an axle that only has a 50,000 mile life. That's wouldn't be allowed under AR rules.
Okay. How about, go ahead, Professor, please.
Okay, so I've been tracking this, and I can provide some answers to this. So a typical bearing is expected to have about 2 million miles. So when it's manufactured, the expectation is it can run for 2 million miles. Now, what happens, it's not going to run 2 million miles for some reasons. As we pointed out, what happened is the bearing is linked to the axle, which means that once the axle is removed, and it's more likely that the axles are removed for high kip or other issues than the bearing. Now, the mileage is usually tracked, and I've done this research where I've asked several. It's kind of it's not a precise thing. So what happened is they will look at the bearing when it was manufactured and when it went into service, and they'll start saying, okay, this typical car sees 10,000 miles per month or and so they can have an estimate but not exact. So the bearings the bearing will get reconditioned. So for example, I have bearings in my lab that were manufactured in 1980 and they're still running. Okay, so they are resilient unless, as I said, they're going through reconditioning. And so a bearing can have as up to 2 million miles, depending on the reconditioning and how well the reconditioning is. But it will be removed for axle reasons more often than a bearing issue.
So do they track the axle then? The wheel, the mileage?
When I try to get that information, it's not readily available. All they can do is estimates. They'll say this wheel axle went into service, let's say, of September of 2021, and the car typically runs this many miles. And so they can give us estimates, but not exact, no.
Mr. Rush, do you have anything to add? Okay, thank you. Thank you, Chair.
Nothing else? Okay.
Chair, I do have just a couple of other questions, if I could.
Yeah. Oh, yes. Sorry.
And I'll be quick. Mr. Hopewell, it's going to seem like I'm picking on you in Norfolk Southern with this question. I'm not. I want to underscore the concern I have about the potential incongruity of having the industry essentially governed by industry set standards. Back to the issue of temperature thresholds, there was an earlier exchange that you had with, I think, with one of the folks on the technical panel about Norfolk Southern's differential standard of 115 degrees, which compares, I think, to the AAR standard of 95 degrees. And you indicated that differing standard for Norfolk Southern was set based on experience. And again, the discussion with Mr. Rush indicated that the AAR standards are set based on experience. I mean, that suggests that somehow Norfolk Southern's experience might be different than the broader industry experience. Is that the case, or is there some other explanation for why Norfolk Southern has a different standard than the industry standard?
I'll go back to the way I believe I answered that question before, is in the particular example of the differential alarm. We've looked at our experience again and data that we've collected based on stops that we were making for that alarm, and found that the analysis we were able to perform from a alert and a trending basis provided us a more accurate take action point than that differential alarm. The differential alarm being at a different threshold than the absolute alarm, and it creates the situation where a crew member could be put on the ground to go inspect an axle. They take their temperature indicator, and the differential threshold being lower, they're going to come back and say, I didn't find anything, and the train's going to continue on. We found that our analysis was that using trending and the other data available was a more effective way to effect a proper stop of that condition.
Member Chapman, if I may?
Sure.
I think I can help you. I think I can very directly answer your question.
Sure,
So
absolutely.
having personally surveyed the railroads on the very question you're asking, the majority view is the Norfolk Southern view, that bearing mate threshold is too low. You end up having too many false positives, and that's why we're going to take another look at the bearing mate temperature threshold.
So is it likely what we might end up seeing is that the AAR numbers will be increased rather than decreased?
Most of the AAR members, the majority of the AAR Class 1 railroads do not follow the car repair billing bearing mate temperature threshold because they believe it results in too many false positives, and they don't find it useful.
Okay, thank you. Professor, do you have an opinion regarding appropriate temperature thresholds for hot bearing detection?
I'm glad you asked that. And yes, so the reason you see these thresholds are recommendation and not standards is because a lot of it is kind of, you have to look at data because, and this is what happens. So the history of these, we have now 3 decades of hot box. At the beginning, they were looking at temperatures. Then they started looking at temperature differentials and averaging. So the first study that was published was 2001, where UP was looking at the average of all bearings on one side and comparing and doing standard deviations. And the reason they do that is because we did a 2008, we did a test on the field where we actually had thermocouples on the bearing cup, which are the actual accurate readings, and we compared those to hot box. And we found in that study, and it's a published study, that some of the hot box detectors can overestimate by almost 100 degrees F and underestimate by almost 80 degrees F. And also they were biased towards a class K versus class F because there was a change in those. So basically the scanner does not scan the bearing. A class F bearing is a little bit longer. So it's not an exact science. And so one experience might be different because these thresholds are just based on experience, and it's not and there's so many other factors that factor in there. As I said, like what type of bearings? Is there a mix between class F and class K? Is it loaded and unloaded? So all of those can skew. So when you see those differentials, it's just kind of trying to find something that works, but it's not exact. And I think that's one of the reasons why you can't really put it as a standard, because they vary. And that's why I continue to iterate, it's that it's not the right tool. So we're trying to make something fit when it's not the right tool. And that's why these standards cannot really be pinpointed.
Thank you. And thanks to all of you. I mean, we're all learning from this process, and this is a useful exchange. So I appreciate it very much. Professor, one last couple of questions for you. Actually, really just one question, but a little bit of prelude. One of the factual reports indicates that the car with the bad bearing in this accident twice over the last 10 years sat stationary for a period in excess of 6 months. Ending in 2018, the car shows no movement for 565 days, which is about 18 months. And then ending in May of 2019, it shows no movement for 216 days, which is about 7 months. Now, I recognize it may have been moved short distances within a yard someplace, but at least in terms of any substantial movement, the car sat twice for extended periods. Is it possible that what impact would that have on the bearings potentially?
So there are two main factors, and one of them Dr. Yuan alluded to. There are two factors. One is when a bearing sits, as I said, long periods of time, especially in cycles of heat, cold, or extreme heat, the grease will tend to, as I said, separate. Okay, there hasn't been a study of how long does it take to separate? I'm sure the bearing manufacturers that produce those, they do these tests. They don't publish them, but they do them. But we've noticed that they do separate. So that's one factor. The second factor is if, let's say, the car is sitting and there is heavy rain, there is a tendency that rain might seep into the bearing. And so the water, the addition of water plus not sitting wrong, it will degrade the grease. Basically water, grease's worst enemy is water. And what happens is when you degrade the grease, or we call it water etch because water gets in, it degrades the grease, and now you're getting a lot of friction, and it will cause water etch damage. Water etch damage is one of the harshest damages that a bearing will see because it creates spoil all over the raceway, and it will degrade fast. So those two factors are always a concern when a bearing is sitting outside for long periods of time and it's not in constant motion. It's better for a bearing to be continuously moved than just sit.
Thank you. Thanks for your answer. Thanks to all the witnesses. Chair, those are my final questions.
Thank you. I'm debating who to ask this question. Mr. Hopewell, sorry, he's like, darn it. What's precision scheduled railroading? Mr. Rush is dying to answer this question if you don't. So either one of you may answer, but
I'll try to do it quickly then. In my, if you're asking for my personal view, it was a means to just take a look at our operation and how we move trains more optimally across our system.
Mr. Rush?
Yeah, so the phrase precision scheduled railroading, obviously it's been bandied about lots of places and it without a very specific meaning. I actually think Jared captured it very well. The essence of precision scheduled railroading really is operating a railroad efficiently, which any business wants to do. Precisely getting more precise than that, there is no more of a precise definition than that. There are different ways in which railroads, if you look at the last few years, have attempted to operate more efficiently. There's various aspects of their operations, but it really is nothing more than trying to operate your railroad efficiently.
Okay, so in questioning, during interviews, the following statement was made of what is PSR: keeping equipment moving, reducing terminal dwell time, keeping the equipment and crews turning, reducing waste, including closure of yards. Would you agree with that?
I think of, just quickly listening to everything you just said, yeah, that's part of it. That's what it is.
Okay.
Yeah.
Also, for folks here, what's a hump yard?
So one of the aspects of precision scheduled railroading that people think about with scheduled railroading has to do, how the railroads use their yards. A hump yard is when you're trying to classify a train. I move a train literally up a hump, okay, and then at the top of the hump, you release a car, and it goes down to whatever track would be appropriate in terms of the next destination for the cars. So I may have, a train which may be divided up into 6 different trains. So as it goes over the hump, the switches will align as the car goes down the hump. It will direct the car to the right track for the next destination. The flip side to a hump yard is a flat classification yard. There's no hump. It's a locomotive, taking a train, breaking it apart, putting the cars in the appropriate track. Hump yards tend to be very expensive to operate, but there are efficiencies. As part of what people think about as PSR, certainly a couple of the several of the AR members over the last few years have been analyzing where they should be using hump yards and where they should be using flat switching yards. I think that's where you're getting at with Chair Hamady.
Thank you very much. Mr. Hopewell, Cookie, how many hump yards have you closed since you began with precision scheduled railroading? Do you know?
I could start using my fingers to count them, but there have been several. We've brought several of them back into operation with the system. The number of hump yards on I believe not just our railroad but the others has actually been in a slow decline over my entire 18-year career. I can name as many hump yards have been put out of that use during pre-PSR times of my career than I can during the
Would you
PSR
say
time.
6, 7 maybe?
That
Or
were
more closed?
during that entire 18 years of my career?
Not the 18 years.
Oh,
Allentown.
I can think of 3 off the top of my head that are
Allentown, Pennsylvania, Enola, Pennsylvania, Sheffield, Alabama, Linwood, North Carolina, Bellevue, Ohio, which was the largest classification yard in the East, and Macon, Georgia. Does that sound right? I think Chattanooga was closed a little while.
Yeah, two of those are back in service now, but those are correct locations.
Elkhart, Indiana, and Conway, Pennsylvania, Birmingham and Chattanooga, and then you reopened in 2022, Macon and Bellevue, right?
That's correct.
Okay, thank you. All right, Julie, can you pull up Exhibit M3? I had some fun with the computer this weekend. Sarah and I did. Thank you, Sarah. Okay, so this information comes from the Surface Transportation Board, which is information submitted by Norfolk Southern. So total employees, it shows from 2012 to 2023, down from, we'll estimate 31,000 down to about 20,000. Can you flip to the next page? Maintenance of equipment in stores, down from a little over 6,200 in 2012 down to little over 2,400 in 2023. And this is where your group comes in, right, Mr. Cox? Okay. Next one. This is all Class 1 railroads for maintenance and equipment. It was a little over 30,000. Now we're down to a little over 18,000. Next one. Maintenance of way and structures, about 6,200. Now we're down to about 2,400 at Norfolk Southern. Next one. Train and engine, up and down, but now down from a little over 11,000. Now we're a little over 8,600. Next one. And then other than train and engine and transportation service, from about 1,400 down to 790, about cut in half. Next. And then professional and administrative, also down from about 2,600 down to a little over 1,800. Next. Executives, we're almost back up to 2012, and that was 1,900, a little over 1,900. Went down a little bit, down to 2021, and now we're going back up, and we're at about 1,715 today. Can we go back to the Norfolk Southern maintenance in stores, of equipment in stores? Yep, that's Class 1, back to Norfolk Southern. I think you had it a second ago. There we go. What impact has this had on the workforce, Mr. Cox, and operations at Norfolk Southern?
Yes, that's a good question. I believe that you see an increase in more serious defects. You see situations like that was talked about earlier, about 25% additional defects in the train that was involved in this incident here. You're seeing routine maintenance that would normally be caught that goes uninspected. And because of the reduction of Carmen and safety inspectors at points, the railroads are using the Appendix D in the regulation to bypass the more thorough mechanical inspection that's required under 215 that a qualified mechanic is highly trained for, that uses the gauges that I showed you earlier that no other craft that's inspecting these rail cars is using.
And because of the closure of facilities, less employees, and I'll just add to that, if you have 30 seconds per side per car, I mean, that's a lot right there. How about the length of time or distance that a train would travel to its next inspection by a qualified carman?
Well, that's a good point. The length of time between inspections increases a lot. And if you continue using the Appendix D rather than the full detailed inspection, you could run an Appendix D, pick up cars like this train did at a terminal, and then run itself to destination, and part of the train never receive, in theory, a full mechanical inspection. And I also like to add that due to these numbers here, the reductions, they basically would, to put it in a layman's terminology, lay off the third guy, have the other two employees pick up the time to do the inspections while decreasing the amount of time required to do the inspections. So not only do you have this time stress, but now you've introduced tiredness, fatigue into the scenario when they do happen to get an inspection.
Great, thank you. And I'm going to pick up on exactly what happened with this one in the next round. Oh, sorry. I've been waiting all day. Sorry, guys. If somebody needs to leave to go to the restroom or take a break, it's cool in the middle room, Jim. I understand. All right, Mr. Cox. So with that, Dr. Garcia, you had the map up from Decatur to East Palestine. Julie, can you pull that one up? I want you to, Mr. Cox, can you walk us through one more time, because you have a lot of folks here, a lot of folks from the community, so they're not part of the railroad industry. I want them to understand what was inspected when and by who, and the difference in that. And try, if we could not use D, or you could use Carmen inspection versus locomotive crew.
So it's my understanding that when the train came into the Norfolk and Southern line in the territory at Decatur, Illinois, that it picked up a cut of cars, 40 cars, and added it to the train, but the rest of the train could not be looked at by the inspectors, and through the practices I've just told you about, they wouldn't be looked at by the inspectors. And the car involved in the disaster was not looked at by the inspectors on the NS line. And as the train continued, you get to Toledo, there are inspectors currently stationed there that, same scenario, they didn't look at the train, they didn't look at the cars. Same thing with Cleveland. And what's not on this map, I know the train didn't stop there, but what's not on this map is between Toledo and Cleveland is Bellevue, Ohio, where there are carmen stationed. They wouldn't have looked at the train either. So, like I've tried to say before, the regulation is being used in such a way that trains are going further. They're going without going into points to be inspected, and they should be inspected. The regulation is being used under the current rail structure in a way that I believe it was never intended to be used.
Mr. Hopewell, did you want to respond at all or disagree with anything there that you want to clarify?
Yeah, I would share my understanding, which is somewhat limited and worth verification, but my understanding is that on origination of this train in St. Louis, at the yard of the Terminal Railroad, the train was also, the particular car in question was also handled by another railroad called the A&S after the car came off the Union Pacific. I would want to confirm, I believe those are major yards that they have there that have mechanical staff in place. So again, I can't dispute, I'm just saying it's worth confirming. The Terminal Railroad, when they built that train, my understanding is they performed a Class 1 brake test, and if there's mechanical staff on hand to do that, then there's no reason I think they're actually required by FRA regulations to also perform the mechanical inspection because they're there. At Decatur, the train did set off cars and picked up cars. The picked up cars were inspected by our mechanical personnel, by my understanding. And the remaining interactions between there and its ultimate destination in Conway were just crew change points. So the train wasn't stopping to perform any other tasks, is my understanding of the traverse of the train.
Thank you. And Mr. Cox, do federal regulations need to change about the allowance between inspections, or the differences between inspections for that locomotive crews would do versus Carmen? Or, you know what, let's back up for a second. Can you one more time talk about the difference between the two? I know you talked about 90 to 120 points on a rail car that you all, or 105, 90 to 105 points on a rail car that you would see doing an inspection versus 12 for the other inspection. Can you talk about the differences there for a second?
Yeah. When the qualified mechanical inspector looks at a freight car, like I stated earlier, he is assessing the total overall health of the car. He's looking at how the components are interacting with each other and looking for telltale signs that there is a problem with the car. And this equates to looking at anywhere from 90 to 105 points per side. And they include very serious criteria down to the criteria that protects the employees, the train crews, like the safety appliances, walking boards, etc. In addition, the Carmen, when he's doing that inspection, will also look at the consist to make sure that hazardous cars are not placed next to the locomotive, which you're not supposed to do. And also looking at the loads themselves to make sure they are secured and not shifted or fouled or in danger of falling off the freight car. The Appendix D, or the reduced inspection, is only very minor in scope. It's only 12 criteria, 12 points. And if you ask the train crews, they will tell you they are not trained like the safety inspectors are, where we do what we do. They do not know how to use gauges. They do not know how to assess the overall health of that car beyond the obvious.
How many years does it take to be a qualified carman?
3,856 working hours, 3-year apprenticeship to become a carman.
Mm-hmm. So, do regulations need to change so that they, and I'm using your words, that can't be used in an one can't be used to substitute for the carman inspections?
Yes, the regulations do need to change to allow the qualified mechanical inspector to do the job that they have historically always done, and protect the employees and protect the public.
Okay, thank you. Mr. Hopewell, it's okay. One advantage of our party process as NTSB is that you find out information as we find out information, and you can make safety changes. That's an advantage of our party process. So I wanted to give you an opportunity to talk about some of the changes that Norfolk Southern has made since the derailment.
Thank you. As I mentioned in my opening, safety being our top priority, we take these opportunities to learn, and that's how we get better. That's why we forged plans to move ahead, even though, as I mentioned earlier, we felt like we know that based on performance statistics that our systems with regard to this worked as intended that day, that they are highly effective. We know we're not perfect and there's chances to get better. And that's what continuous improvement in safety is about. We'll never call it perfect. There's always something to do. So Our 6-point plan, as I mentioned mostly in our opening, we're going to employ additional detectors, move along to additional technologies, including acoustic. I agree with the sentiment from others here that a variety of angles of attack at this issue of bearing failures is, you can't count on just one being a catch-all, and we'll continue to look at other technologies that might add to that portfolio, enhancing our processes, our training. It's all on the table.
And you're increasing, providing some redundancy at your ATC desk as well?
Yes, absolutely.
Okay, good. And just to clarify, because I know there was a statement made earlier about what the ATC, the individual who was at the automatic train control desk could see in Atlanta, they got the first two, they got Salem and Sebring temperatures, but did not get any alert for East Palestine, correct?
Correct. Not entirely correct. There was no alert generated at Sebring. The temperature was still rather low there. Salem, there was an alert populated to the system. Then, of course, East Palestine. The way the system is currently architected, the data is sent in after a complete train move as a file with all the readings from that train. And because the train at East Palestine stopped while the part of the train was still occupying the detector, that clearing event didn't happen to send the data into the office. But other means of contact directly from the train crew to the analyst did happen.
That's right. Oh, that reminds me, and this is going to be my last question. Sorry, I promise. Do you know what time, because there was a conversation about this yesterday, the engineer provided the train consist to the Norfolk Southern road foreman's desk?
I'm not aware of specific timestamps. I'm aware generally in the 30 minutes or so that followed the detector alarm and the train going into emergency that the train crew did communicate with multiple entities, the dispatcher, the road foreman's desk, and the wayside desk. But that's the extent of the detail I'm aware of.
9:11 p.m. was the exact time that the engineer provided the train consist to the Norfolk Southern road foreman's desk in Atlanta. Just wanted to be clear on that from yesterday. Was there a follow-up question over here on that one issue regarding billing for repairs? Anything over here? No. People need a break? You're tired of me? Okay. So, time, what? Oh, yes, sir.
Chairman Howendy, I'll be remiss if I don't just make one recommendation, because I know there is a lot of effort that goes into this. We are a Universal Transportation Center that's funded by USDOT, and USDOT has invested a lot in some of these centers to promote safety and create technology. I strongly recommend to this group that before we make decisions on like investing in more wayside, we need to step back and maybe do a comparison and a systematic comparison between wayside versus onboard, and make informed decisions that will help everyone and create better opportunities, because we put sometimes some of the personnel in a position to make decisions that without having a lot of data. And so taking that time to make sure that we have now new technology, and we have tested this now for 3 decades. We might want to work together and see if there is other ways to improve the system so that it can help everyone.
Thank you very much, and I agree with that, and I'm glad you spoke up, so appreciate it. Okay, we are going to take a lunch break. I know it's almost 2 o'clock. We're gonna come back at 3 p.m. Sorry, we're running a little bit late, but I do want to thank all the witnesses for panel 3, your presentations, your statements, your patience with all of the numerous questions and putting up with the heat is really, really appreciated. Thank you so much.
Trish? Right.
All right, welcome back. We are now ready to turn to the final panel, which is on rail tank car safety. Ms. Shaw, will you please begin the introductions and swear in the witnesses?
Sure. Chair Homendy, specific topics to be addressed in panel 4 include the tank car derailment damage, tank car crashworthiness, hazardous materials package information, and appropriate tank car candidates for vent and burn actions. Witnesses for panel 4 are composed of the following individuals: Ken Dorsey, Association of American Railroads; Paul Williams, Norfolk Southern; Randy Keltz, Federal Railroad Administration; William Schoonover, PHMSA; Jeremiah Zimmerman, Minlid Manufacturing; A.D. McKissick, Trinity Rail; and Karen N. Stegman, Oxy Vinyls. The NTSB technical panel is composed of Paul Stansel, the panel chair; Ruben Payan, investigator in charge for the East Palestine investigation; Mark Doherty, and Sean Lynham. I would now ask that the witnesses please stand to be sworn in. Please raise your right hand and answer by saying, "I do." Do you swear or affirm that the testimony you will give in this hearing will be the truth, the whole truth, and nothing but the truth? Thank you. You can be seated. As a reminder, you will remain under oath until the conclusion of the hearing this afternoon. Chair Homendy, these witnesses have been pre-qualified and their respective experience and qualifications appear in the docket as exhibits in Group A. As a reminder to the witnesses, please push the microphone button to talk and then push it again when you're finished, and please talk as closely as you can. It's been hard to hear today, so we would appreciate that. And also, please answer the questions factually and avoid analysis. I'll now turn the questioning over to Mr. Stansel.
Thank you, Ms. Shaw. Good afternoon, witnesses, Chair Homendy, and members of the Board of Inquiry. I'm Paul Stansel, the panel lead for panel 4. And before we get started with questioning, I understand that the following witnesses have a preliminary statement to provide: Mr. McKissick, Ms. Stegman, and Mr. Williams. We'll begin with Mr. McKissick's. Ken Dorsey also, okay.
Chair Homendy, members of the Board of Inquiry, and members of the technical panel, and the East Palestine community, thank you for the opportunity to provide testimony today. My name is A.D. McKissick, and I serve as a Vice President and Chief Engineer at Trinity Rail. I have more than 30 years' experience in the railway supply industry and have been at Trinity Rail for 18 years. In my role as Chief Engineer, I'm responsible for the technical oversight of railcar designs, including testing and analysis, and the technical interface with regulatory and other agencies. Trinity Rail is proud to be one of North America's leading manufacturers of railcars and railcar products, and to be relied upon for the trusted services that we provide in this industry. We at Trinity want to express our support for the East Palestine community, and more broadly for all those impacted by the derailment, and to pledge our continued commitment to work collaboratively with the NTSB and other stakeholders as the board examines the accident. Thank you.
Thank you, Mr. McKissick. Ms. Stegman, would you provide your statement, please?
Yes, thank you. Good afternoon, Madam Chairperson, members of the NTSB board, ladies and gentlemen. As you know from the proceedings, I am Karen Ann Stegman. I am the Vice President of Supply Chain for Oxy Vinyls. I would like to reiterate the remarks my colleague Paul Thomas made yesterday. I want to acknowledge the East Palestine community and thank those who participated in the response effort following the derailment of the North Fork Southern Train 32N in February of this year, including Chief Drabeck and the other first responders. We recognize the impact the derailment has had on your community. We are committed to supporting the agency's investigation of the incident in East Palestine. Like many manufacturers, Oxy Vinyls uses pressurized tank cars to transport some of its products by rail. Oxy Vinyls does not build the tank cars used to transport our products. Instead, we purchase or lease rail cars the way someone might purchase or lease a vehicle. We rely on railroads such as the North Fork Southern to safely transport our products to their destination. All of Oxyvinyl's tank cars are inspected and maintained by facilities that are certified by the Association of American Railroads. These companies have specialized knowledge and skilled workforces specifically trained to ensure that rail cars are compliant with the Department of Transportation's strict specifications. Additionally, we contract with a service company that tracks maintenance activities and repairs for our rail car fleet. These suppliers assist in managing our maintenance program, including preparing and maintaining records in compliance with all relevant regulations. In the February incident in East Palestine, 5 tank cars shipped by Oxyvinyls containing stabilized vinyl chloride monomer were derailed. These tank cars did not initiate the derailment, nor did they breach in the derailment. The tanks on these rail cars remained intact following the derailment. Additionally, the pressure relief devices on all 5 cars operated as intended, preventing damage to the tanks by relieving the elevated pressures caused by the surrounding fires. From our perspective, these tank cars and their associated safety devices exhibited sound mechanical integrity and functioned as designed during the extraordinary circumstances of this incident. All 5 tank cars transporting our product were manufactured by Trinity and were authorized by the Association of American Railroads. 3 of those VCM tank cars were purchased from Trinity and the other 2 were leased. 1 from Trinity Industries Leasing Company, and 1 from GATX Corporation. 5 other companies had a combined total of 6 tank cars involved in the derailment that contained hazardous materials, including ethylene glycol monobutyl ether, ethyl hexyl acrylate, butyl acrylate, isobutylene, and benzene. Many of these rail cars breached upon derailing, which released their contents into the environment. The contents of some of these cars fueled the initial fires at the derailment scene. Today's panel includes a discussion of the DOT 111 tank cars and the damage sustained to those cars in the derailment. I want to emphasize the tank cars carrying the stabilized vinyl chloride monomers were DOT 105 cars, which is a different specification class and did not breach in the derailment. Thank you for inviting Oxyvinyls to participate in the investigative hearing. Along with the other rail shippers, we have an interest in working with the regulatory agencies such as the Federal Railroad Administration, railcar and other equipment manufacturers, railcar lessors, and the railroad industry to ensure the safe and reliable transport of goods by rail. And as Oxyvinyls has made clear from the outset, we share the NTSB's goal of preventing incidents like this from happening in the future and advancing transportation safety. I look forward to answering your questions to the best of my ability. Thank you.
Thank you, Ms. Stegman. Mr. Williams, please give us your statement.
Good afternoon. My name is Paul Williams, and I'm Norfolk Southern's Regional Manager of Hazardous Materials for Virginia and West Virginia. I apologize. I'm vocally challenged today, but I will do my best to read the statement and answer your questions. I've been with Norfolk Southern for since 2003. In those 20 years, I've worked to ensure the safe transport of hazardous materials across our network, both in my role as Norfolk Southern as well as my involvement with the AAR Rail Tank Car Committee. Norfolk Southern has long advocated for more stringent tank car safety standards and a more aggressive phase out for older equipment, like some of the tank cars that were involved in the East Palestine derailment. Norfolk Southern, like a number of other railroad companies, is a common carrier, which means it has a legal obligation to transport goods upon reasonable request, including hazardous materials. This service is in the best interest of both the public and shippers Though running a railroad has inherent risks, rail remains the safest method of transporting hazardous materials above ground. We take our obligations extremely seriously and are continuously focused on emphasizing safety while serving shippers and the public. As an employee of Norfolk Southern for 2 decades, I want to make this clear. Norfolk Southern has always worked to do the right thing when we have an accident or a spill, and we will take care of the people of East Palestine. We'll make sure we are the safety leader in the freight industry. Norfolk Southern has been enhancing our hot bearing detectors network and piloting next generation hot bearing detectors. We have committed to joining the Federal Railroad Administration's confidential close call reporting system alongside the other Class 1 railroads. And we're not finished. We're also analyzing our car routing, leveraging positive train control to minimize risks, and also self-reporting hazardous materials infractions to the FRA within 48 hours. We are committed to learning from this accident and working with the public and officials and industry partners to improve railroad safety. All industry stakeholders, including railroad companies and railcar owners, manufacturers, leasing companies, and equipment makers, must work together to ensure the safety of our crews and the communities in which we operate. I'd be happy to answer questions at any time.
Thank you, Mr. Williams. And Mr. Dorsey, I apologize omitting you in the introduction. Please give us your statement.
Thank you for the opportunity to appear on behalf of the Association of American Railroads. As Mike Thrush stated earlier today, one of the AER's functions is to issue standards governing rolling stock. The earliest industry freight car standards were in fact tank car standards dating back 120 years to an AER predecessor organization. The tank car safety is a shared responsibility between the railroads, rail customers, and federal safety regulators. These specialty cars are used to transport hazardous materials that are used in everything from manufacturing to water purification. While the railroads are responsible for the safe shipment of customers who own more than 99.9% of the 400,000 active tank car fleet also play a vital role in the safe transportation of these goods. Although tank car standards originated with the rail industry, eventually tank car standards were also regulated by the Interstate Commerce Commission and then by the Department of Transportation. However, AER's role in setting tank car standards did not cease with the adoption of federal regulations. AER continues to set voluntary tank car safety standards that go over and above and often precede by many years federal requirement, with many of the AER standards incorporated by reference in the federal regulations. AER helped lead the charge for DOT regulations requiring new, tougher tank car standards for hazardous materials, including flammable liquids like crude oil. Long before the federal phase-out was approved, the industry proactively required thicker shells and improved top fittings, among other enhancements, to improve performance through the industry's interchange standards. As the phase-out nears completion, crude oil and ethanol are no longer moved in DOT 111 cars. Many of the tank car features that have enhanced the safety of flammable liquid transportation have long been in place for flammable gases such as vinyl chloride. AER tank car standards are developed by the AER Tank Car Committee, which includes representatives not only the rail industry, but also the tank car industry. Although government representation is not formally part of the Tank Car Committee, they also actively participate in committee deliberations, including representatives from the Pipeline Hazardous Materials Administration, the Federal Railroad Administration, and the Department of Transportation's Canadian equivalent, Transport Canada, as well as the NTSB and the Canadian counterpart, Transportation Safety Board of Canada. In addition to developing standards for the design of tank cars, AER's audits certifies facilities that manufacture and repair tank cars. AER audit program is separate from any inspections performed by the federal safety and regulators. AER audits and certifies tank car facilities for both compliance with technical standards and to conform compliance with the AER required quality assurance programs for the manufacturing process. I'd be remiss if I didn't mention AER's partnership with the Railway Supply Institute in the RSI AER Rail Tank Car Safety Research and Test Project. RSI represents the tank car industry. Through the project, RSI and AER have engaged in important tank car research for many years, using the project's unparalleled database of 50 years of tank car accident, data. One important area of study has been evaluating the effect of various tank car features on the probability of release should an accident occur. This program has yielded significant safety improvements that are reflected in modifications to existing tank cars. Constructions of new tank cars with improved designs and quantitative decision-making tools such as risk analysis, cost-benefit analysis. Research by the Safety Project has led to now common tank car safety features, including head shields, shelf couplers, and thermal protection on tank cars carrying hazardous materials. I look forward to contributing to the panel's discussion today. Thank you.
Thank you, Mr. Dorsey. Okay, I'd like to begin with Mr. Keltz. And I would like you to first tell us about the Federal Railroad Administration's role in accident investigation and tank car safety.
Thank you, Mr. Stansel. Yes, I'm the manager for the FRA's tank car safety programs. When most people think of the Federal Railroad Administration, they think of the larger disciplines within the organization, such as the Motor Power and Equipment Division, Hazardous Materials Division, Signal, Train Control, Track, and the like. This group's a small, specialized group where it primarily focuses on the oversight and enforcement of the tank cars themselves. The group's comprised of 3 engineers and 3 tank car specialists, and I'm the manager of the program. So we provide oversight over the tank car manufacturers, repair, maintenance facilities, the qualifiers, including the tank car owners themselves. So again, it's a specialized group that's kind of niche just to the tank cars themselves. Regarding the accident, our participation in accident investigations, we don't get involved with the investigation efforts itself. What we get involved with is we look at the tank cars and assess the damage, both for a positive and a negative outcome of tank cars that are involved in train derailments. And what this effort is for is to catalog the information, again, both positive and negative, and compile it. If the department would need to move on future rulemaking, what type of safety enhancements to make to tank cars moving forward. We've worked collaboratively, obviously, with the NTSB, the carriers that are involved, sometimes the equipment owners themselves, and we go out and do this forensic type analysis. It's always after the fact, and that's at a high level what our roles and responsibilities are regarding that.
Thank you, Mr. Keltz, and that'll lead me to our next question here. You participated in the NTSB's investigation and post-derailment damage assessment, in this case in East Palestine. Can you tell us what you found or what you observed with respect to the tank car breaching damages? And let's begin with the hazardous materials tank cars first, and then we'll follow that up with the non-hazardous materials tank cars, please.
Okay, for this effort, being that there was a number of cars involved, I'm going to refer to the exhibit, Group B exhibit, exhibit number 10. And Table 9 that starts on page 46 of that exhibit. So as it was previously mentioned in previous testimony, there was a number of tank cars, both containing hazardous materials and non-hazardous materials. I'm going to review the list of the hazardous material cars themselves. Starting with running order line number 28, tank car TLX 402025 was the first vinyl chloride car in the pileup itself. That car did not sustain any type of mechanical breaching or any damage to the vessel itself in the derailment. It was subject of one of the vent and burn operations to mitigate the product that was left inside that post-derailment. The second car in the hazardous material lineup is line number 29. This car number is OCPX 80235. And again, this is another vinyl chloride car. with the same outcome. No mechanical breaching, another vent and burn car. Third car, hazardous materials, the OCPX 80179. This is another vinyl chloride car, and again, the same outcome, vent and burn, no mechanical damage to the vessel itself. Fourth car number 31 in the lineup. This is GATX 95098. This is the fourth vinyl chloride car in the initials pileup, and again, same outcome. It was a vent and burn with no mechanical damage to the vessel. The next car, hazardous material car, was line number 36, car number SHPX 211226, and this was an ethylene glycol monobutyl ether car. This car lost its entire load due to the bottom outlet valve being dislodged during the derailment. So we had loss of contents through the BOV, and on the B end of the car, the tank head had a crack in the head itself from the initial derailment. The next car in the hazardous material lineup, car running order number 38. This is a DOWX car, 73168. This is the ethyl hexyl acrylate car. What was reported was that there was a partial load loss, and we had both B head. We had the A end had a head puncture, and the B end had cracks on it. So again, we had breaching of this tank car, when it was involved in derailment itself. Next one is line number 50, UTLX 205907. This is a butyl acrylates car, and the A and B end had punctures, and this car was also observed in numerous photos of the drone flights and whatnot, that the manway gaskets were burned out on this car, and you could see some of those fires as the car was laying there post derailment. Next hazmat car, line number 55, OCPX 80370. This was the fifth vinyl chloride car in the consist, and again, no mechanical damage to the car, and this was the fifth car that was vent and burned during that operation. And that concludes the hazardous material tank cars. The next table I'm going to refer to is table number 10 within the same exhibit. And this is page 57 of the document, table 10, and these are the non-hazardous tank cars that were involved in the derailment itself. We'll start with line number 30, running order in line number 34, an RACX car 51435. This is a propylene glycol car, a DOT 111, 100W1. Head impact damage, puncture to the shell on the left center of the car, and it lost its entire load. The next car would be running order number 41, UTLX 100055, a petroleum lube oil car, DOT 111, 100W1. The manway cover was missing, the top fittings sheared off, and the tank shell on this one was also punctured. Car lost its entire load. Next car, running order number 42, XOMX 110664, another petroleum lube oil car. This one was a AAR 211A 100W1. It lost most of its load due to unknown reasons. And this being that this was a non-hazardous material car, we elected not to do a post-damage assessment on this because it was a non-haz car. I know when we initially put a hold on these cars in conjunction with NTSB, we only wanted to look at the cars that were put a hold on, the cars that were carrying the hazardous materials themselves. So this car never got a formal forensic assessment to determine where all this product was lost from. The next car up would be line number 44, UTLX 671310, another petroleum lube oil car, a DOT 111, 100W1, and again, a partial load leak through the pressure relief device, and top fittings leaking and on fire. This is another one that was, we had photographic evidence. You could see some fire burning out of the top of the car, similar to the previous car. Next car, line number 45, CERX 30072. This is a propylene glycol car, another DOT 111, 100W1. This car lost its entire load due to a tank head puncture. And the last car that was compromised, running order 47, was an NATX 231335, diethylene glycol, another DOT 111, 100W1. This car lost its entire load due to a coupler impact puncture on the left side of the center of the car.
Okay, thank you for that, Mr. Keltz. And just to reiterate, all of the tank cars that released product due to mechanical damage were either DOT 111 or AAR 211 tank cars, correct?
That is correct.
Okay. Okay, Mr. Williams, please describe for us what damage sustained by the vinyl chloride tank cars created challenges for you and your contractors in handling those cars and considering options necessary to make the scene safe.
We were unable to see much of the damage due to the configuration of the wreck. Tank damage, as you know, 105s have a steel jacket, so we're looking at damage to the jacket, not what's underneath. Fire damage was evident on all the cars, and all these factors complicated our damage assessment. The valves were damaged in the fire as well, which rendered them inoperable.
I understand that there was body bolster damage as well. How did that affect your ability to handle these cars?
Given the condition of the cars, we weren't going to move them. So the bolster damage wasn't of a concern at that time.
So that didn't limit your ability to remediate any of the vinyl chloride cars?
No, sir.
Okay. And what role did the tank car construction details play in considering how to address the hazards posed by the various tank cars, including the vinyl chloride tank cars? Did you reference UMLR data or any other data for the tank car certificate of construction or anything while you were in the process of doing this remediation work?
Yes. After the initial derailment, we looked up the car specifications in UMLR, which revealed that they were all 105 J300Ws, so we knew what minimum thickness they were. We knew they had thermal jackets. We knew they had 1/8 inch steel jacket. We knew they had protective housing around the valves. So that gave us an idea of what type of container we're dealing with. We also looked at the properties of the vinyl chloride, and it was a suitable container.
Okay, and did you do that for all of the tank cars involved in the derailment?
Yes, sir, we did.
Okay, and so I guess it goes without saying that the UMLR data needs to be accurate. Where does that data come from?
The UMLR data is entered by the car owners, and it is stored in Rail Inc.
Okay, and did you find the data to be accurate and consistent with what you found on scene?
To my knowledge, yes.
Okay. All right, Ms. Stegman, I heard your preliminary statement regarding the performance of the tank car equipment, and just want to give you the opportunity. Is there anything else you would like to say about them, given the outcome in this incident in which there was a need to conduct a vent and burn on your tank cars?
I have nothing to add to the damage assessment. But when we look at the vinyl chloride cars, there's just a few key points we want to continue to emphasize. Mr. Stansel, you opened up panel 2 yesterday with a definition of pressure relief devices and a description of their function. The primary focus, the only focus of a pressure relief device is to relieve the excess pressure building in a vessel or tank to prevent a rupture. That is exactly what the pressure relief devices on all 5 tank cars did. It's the one fact that is very clear throughout the derailment and the incident that occurred. The 5 pressure relief devices were activated. That's according to eyewitness testimony. And the tanks remained intact up until the vent and burn decision. That was over 60 hours that the 5 pressure relief devices protected the 5 DOT 105 tanks. Thank you.
Okay, thank you. So since this derailment, have you identified any issues at all that point to the need for any changes of processes, procedures, or equipment for your tank cars?
No, we have not.
Okay. All right, thank you. Mr. McKissick, Trinity Industries manufactured all 5 DOT 105 tank cars used to transport the vinyl chloride, as well as 1 breached DOT 111 general service tank car, DOWX 73168, and that was carrying combustible liquids. Please describe for us any special features of these pressure and general service tank cars, and tell us about their differences in lading protection.
Thank you for the question, Mr. Stansel. Let me start off with, I think we need to put a DOT 111 in there to give a benchmark so we can compare these two. The biggest difference is between all these can be the thickness of the steel. So we'll just set the level of 111 at 7/16 inch minimum thickness. The 105 is a special car that's it's a pressure car that has, in addition to the normal features of a way to get in the car, a manway, you have a fittings arrangement on it. But a 105 is distinguishable from other cars because it has a thermal protection system, which is designed to survive high temperature fire situations, and it also has an insulation system. It also differs from a 111 car in that there's no bottom outlet there. The 105 is, in this particular case, was 9/16 of an inch thick. The top fittings protection is required to be 3/4 of an inch thick, where that's not required on a 111. And it also has a head shield on it, which is at least 1/2 of an inch thick. The other car, even though it was classified as a 111, had some special features on it, the DOWX car. It was similar to what we commonly refer to as a CPC 1232 car, but it wasn't technically a CPC 1232 car. And one of the reasons is it was built before CPC 1232 existed. The car, why it had the special features, in addition to sometimes a customer will request additional features on it, but this car was built to operate under a special permit and run at 286,000 pounds gross rail load. At the time, 263,000 was allowed, so it operated under a special permit. Part of that requirement then was additional safety features. So this car was actually 1/2 inch thick, TC 128 normalized steel, which is a higher grade of steel. It had half-height head shields, which means they look, we call them trapezoidal sometimes. They look like a trapezoid, but they only go halfway up the tank. So it had the 1/2 inch head shields. And it also had the 3/4 inch housing on there. So it had a lot of the features of a pressure car without some of the other requirements on there. I hope that gave a good overview for you.
Yes, sir. Thank you very much for that. And based on what you've seen in the post-derailment examinations, I know some of your personnel were present out there at the scene, and as well as post-derailment testing that we've done. Do you have any concern about the damage performance of any of these tank cars?
Let me answer your question this way. A derailment like this in excess of 40 miles an hour is a very violent and chaotic event. It's unpredictable in how the cars will end up in a derailment. There are a lot of similarities. We have what we refer to as accordion shape, where you have a pile in the middle of them, and you have some cars on the outside, like the TILX VCM car was at the beginning of it. So it's a very violent and unpredictable behavior. So when you look at something like this, it's hard to actually pin down and make a firm prediction on how cars are going to go. Looking at the derailment, though, as an overall view, and what I saw, I was not there, let me qualify that. I've looked at pictures and so on, but I did not see anything that would be unexpected in a derailment of this magnitude and this speed.
Okay, thank you, Mr. McKissick. Mr. Doherty, please continue with the questions.
So my first question is for Mr. Dorsey. Could you compare the safety features of the DOT 117 tank cars versus the legacy DOT 111 and the CPC 1232 tank cars that were breached in a derailment?
So DOT 117J, which would be a new built DOT 117, you would have, basically you'd have a 9/16 inch shell and full height head shields, top fittings protection, whereas a legacy 111 would not be required to have the jacket or thermal protection. I'm sorry, there's also thermal protection on a 117J. Top fittings protection, depending on the vintage of the 111, might not be there, and it wouldn't be required a head shield. What Mr. McKissick referred to as a CPC 1232 car, or would be considered an enhanced 111 if you were in Canada, it would have, if it was unjacketed, a 1/2 inch thick shell and half height head shield. It would have top fittings protection. 117 car is actually approaching the 105 in construction features and strength. It does have a bottom outlet valve, and it has an additional nozzle on top, allowed, not necessary. And the legacy car is potentially either 7/16 inch, or in your case, if you were asking about the CPC 1232 car, it's a 1/2 inch. And the CPC 1232 car or enhanced car would be TC 128 grade B normalized, so that's it's the higher tensile tank car material, and it is normalized. So I guess that answers your question, I hope.
Yeah, so continuing that conversation, can you briefly describe what a DOT 111S specification tank car is?
So, and Carl's in the audience. So a DOT 111S, certain owners of cars wanted to designate DOT 111 cars that had additional safety features. So an S car would have, the head shield and double shelf coupler. DOT 111A could have those features, but certain owners wanted to designate it to their customers, I assume, that those features were present on the cars, so they marked them S. It just indicates additional safety features on the car.
Thank you. So we noted that out of 3 of the punctured and cracked hazardous material tank cars, which included a DOT 111S, one had a half head shield, which was ripped off as a result of the derailment. CPC 1232, which was compromised, and a DOT 111A, which had no head shield installed. All 3 sustained head damage and punctures. Can you tell us what the benefit of a full height head shield is with regard to tank car crash worthiness, not only for this incident, but for any incident or accident involving an impact to the A or B end of a tank car?
So past research from the safety project did an evaluation, and the head of the tank cars was determined to be vulnerable to high energy events during derailments. The half height head shield was instituted because the research indicated that about 80% of the strikes happen below the center line of the head. So a half height head shield was determined to give you the most benefit for the least additional weight to the car. Full height head shield, of course, protects the head, and all that assumes that obviously the head shield is in place. With that, additional research more recently has indicated that the head shields tend to collapse towards the head, absorbing energy the whole time they collapse, and they become additive to the head essentially giving you equivalent additional thickness, but there is energy absorbed while it's collapsing towards the head. They've proven to be very effective in protecting heads. I'm not sure quantitatively, is there additional information I could give?
No, thank you for that. And then what kind of, or what types of tank cars have full head shields?
So the federal regulations require head protective systems. I'd have to allow DOT to basically talk about what's required to have heads by federal regulation, but commonly, of course, 117Js and pressure cars. But that's a head protective system. A full height head shield is one option for a head protective system. So.
Okay, thank you for that. My next question, Mr. Schoonover. So given that current federal regulations allow the continued use of DOT 111 tank cars, such as those that were involved in the East Palestine derailment, and because the hazardous materials were not transported in a high hazard flammable train, what are your thoughts about the continuing use of DOT 111 tank cars for these types of materials?
Thank you for that question, Mr. Doherty. Shortly after the accident, we issued a safety advisory to notify owners that they have the ability to go beyond federal regulations. And the federal regulations set a minimum standard for packaging for transporting hazardous materials. And we wanted to make sure we notified car owners, shippers, anyone that is selecting a car, that they can always go above and beyond the federal standard. Even though we may not be able to enact regulations that require better cars at this time. So, we would hope that the shippers and the car owners would go above and beyond and replace those cars.
So, in addition to that, are there any efforts, if any, that are actually being pursued to accelerate the May 1st, 2029 FAST Act target date for the phase out of the DOT 111 tank cars and other flammable liquid service?
Absolutely. The Secretary Buttigieg has reached out to Congress and asked them to take legislative action to rescind or change the mandates under the FAST Act that limited our ability to change out DOT 111s in flammable liquid service. And we continue to press the industry to take action as well. We actually went out to the industry as part of the Secretary's action plan as a result of the accident and talked to the major builders, and I think Mr. Keltz can talk to that.
Thank you. And what regulatory gaps should be addressed regarding the current standards for general service tank cars, such as a DOT 111 and DOT 117s?
Regulatory gaps. Not related to this accident in particular, but I think what we see is that, and this accident did demonstrate that 117s behave as we want them to, that they survive accidents. We had some lube oil cars that were DOT 117Js, behaved and survived the accident well. I think in looking at that, in addition to converting the fleet, the remaining gap that we have with the 111 car and even the 117s relates to bolted and hinged manways. And I think what we're seeing is in accidents, the bolted and hinged manways continue to be that area where even if a car survives an accident, in the post-accident fire and aftermath, we're having additional failures and problems. So.
And that's a lead into my next question. What should be done about the use of hinged and bolted manways on flammable liquid general service tank cars?
Well, I've raised this issue to the industry. I think in addition to considering action at the government level, I think the industry needs to work with us very quickly to establish a plan to convert the existing cars over and get rid of bolted and hinged manways, go to a bolted manway that allows us to put in fire-resistant gaskets of better quality that can survive post-accident incidents. So.
Thank you. And same question regarding bottom outlet valves.
I'm sorry, sir, could you repeat?
Same question. Do you have any thoughts on bottom outlet valves and what should be done regarding the bottom outlet valves? Do you have any thoughts on that?
I think there's continued work to research bottom outlet valves. You know, it would be great if we could find a way to get rid of them, but there are a lot of issues with just flat out, removing them from cars. There's a lot of changes that have to be done at shippers' facilities and receiving facilities. But I think having those discussions of how we find alternatives to that and finding a path forward is what we need to do. So.
Great, thank you. So my next set of questions for Mr. Zimmerman. If we could please display Exhibit 52. Sorry, Exhibit D52. Mr. Zimmerman, I know we've touched on this a few times, but from an engineer's standpoint, can you please explain what a tank car pressure relief device is? And could you also give us an overview of how it functions?
Yes. In this case, this is an internal style pressure relief valve. It is a reclosing safety relief device. It opens when the tank car pressure reaches the start to discharge pressure, and then recloses once that pressure is reduced to the vapor tight pressure.
Great, thanks. And so what is the purpose and importance of a reclosable pressure relief device, such like the ones on the VCM cars?
The intention of a reclosing pressure relief valve is to limit the amount of commodity that's released into the environment. You want the pressure to be relieved, but you want to do that by minimizing the exposure.
Thank you. Can we display Exhibit D50, please? So, Mr. Zimmerman, considering the findings of the post-derailment examinations that at least 2 of the pressure relief device valve stems became stuck closed in their guide bushings, and this is in reference to the pressure relief devices affixed to tank cars OCPX 80179 and OCPX 80370. What are your thoughts about valve components compatibility with burning vinyl chloride?
We manufacture a range of tank car surface equipment. We do not specify compatibility with the commodities.
Thank you. And that was my next question. Does Midland provide any guidance to its customers about the compatibility of the equipment with the intended lading?
We do not, no.
Okay. And can you explain why you do not?
We don't have the knowledge of the chemicals being put, the commodity being put in the tank cars to determine chemical compatibility. We can only provide a range of materials, and it's up to our customers and ultimately the shipper to determine that compatibility before the commodity enters the tank.
Thank you. And you participated in our post-derailment pressure relief device examinations. Did you observe any evidence of obstruction or fouling of the equipment or internal components that would affect its function to relieve pressure?
Yes, as you mentioned, several of the valve stems were stuck inside the top guides.
Okay, thank you. And I will turn the questioning over to Mr. Stansel.
Yes, thank you. And continuing with you, Mr. Zimmerman, first, please display Exhibit D51. So the post-derailment pressure relief device examination found stainless steel components significantly corroded, and we heard from Dr. Carroll yesterday that corrosion would be expected when burning vinyl chloride produces hydrogen chloride, especially in the presence of water. How would you expect that to affect the operation of these devices?
first, I just want to clarify that the as-received condition of these valves is not always indicative of their condition prior to the vent and burn. In this case, the residue would have to be sent to a laboratory to determine the exact mechanism by which that stem was stuck to the top guide. I can't comment on that.
Okay. Would you, if the valve was not corroded prior to the derailment and it was in a condition like this after the derailment, does that tell you anything about its exposure to the burning vinyl chloride, the hydrogen chloride, or any other factor?
No, I can't comment on the exposure to the chemicals without more information on the exact nature of the corrosion itself.
Okay. Well, let's ask you then, what would be the result of a closed, stuck valve of a pressure relief device? What safety concern is that?
Depending on the conditions inside the tank car, if a pressure relief valve was inoperable, yes, that would pose a safety concern.
And why would that be?
The intent is to open and function normally if the pressure inside the tank exceeds the start to discharge. If it's unable to do that and the pressure inside the tank car did exceed the start to discharge, that would pose a safety concern.
Okay. Could you please display Exhibit D52, please? And I won't display the proprietary engineering drawing with the actual dimensions, but I would like you to explain the measurement tolerance between the top guide and the valve stem and why these tolerances or the gap between the parts is so small. And I understand criteria suggests that as little as 4/1000ths of an inch. Is that correct?
That's correct.
Yeah. So why is that?
As I mentioned, the function of these valves is to reclose once the pressure inside the tank is relieved. To ensure that that seal is maintained, there's a tight alignment of that stem shown here in blue as that valve opens and then recloses. So to ensure that that seal, the body and the seat, the primary seal of the valve, seats appropriately after expelling fluids, it has to maintain a tight tolerance with at one end at the valve stem with the top guide and at the bottom with the follower inside the guide tube.
Okay, so please go to Exhibit F23, page 19 and 20, please. Okay, on this, this is an excerpt from the Midland Manufacturing Installation, Operation, and Maintenance Manual. And if you note on the drawing up near the top, it cautions against painting or obstructing the guide bushing where the valve stem enters it. Please explain why Midland highlighted this caution.
Any obstruction to the flow path of the valve or to the motion, the movement of the primary components, the stem or spring, could affect the performance of the valve.
And how do you mean affect performance? What does that mean?
Obstruction in the flow path would potentially lower its flow rating. It's how much volume passes through the valve. Or it could affect the start to discharge pressure.
Could it affect it by causing the valve to stick shut?
In an extreme example, yes. On the other end, it could make a very negligible difference.
Understood. Okay, would valve stem corrosion have the same effect as paint or some other obstruction?
It depends on the nature of the corrosion.
Looking at this case, is that reasonable to expect?
I can't comment on the exact nature of the stem being fused to the top guide in this case without more additional information on the metallurgy.
Mm-hmm. Would you agree that this is a critical design feature of a pressure relief device, that there be no obstruction or interference with the operation of that valve stem?
Yes, that's correct.
Yeah, and so if it's sensitive to contamination or paint, what could Midland do to improve the valve's resistance to foreign matter or corrosion?
I can't comment on potential design changes. This design has been approved and in use since the late 1960s. We have not seen any evidence that this is a recurring or a common practice or effect of corrosion for these products.
So is it fair to say that you are presently not anticipating any changes or modification to the valve design?
Not at this time.
Okay.
But we will certainly take any recommendations from the NTSB or the federal changes in federal or industry regulations into account in future designs.
Very good. Thank you. Ms. Stegman, after hearing that, do you have any position on the compatibility of the pressure relief devices with the vinyl chloride lading?
I would like to just first begin by echoing Mr. Zimmerman's comment that we do not believe that the pressure relief devices as tested reflected the condition or status of the relief valves during the incident. The pressure relief devices that we're testing and the analysis and the examination is post-vent and burn. We saw the videos and pictures yesterday of the vent and burn process. Extreme mechanical pressure wave forces and temperature thermal stresses were placed on those relief valves. When I interviewed Mr. Poe as part of the NTSB investigation, the gentleman that installed the explosives, remember we installed explosives in the vent and burn process. I asked him if he could quantify the mechanical forces of the vent and burn process, and he said no. So we're analyzing valves without setting the parameters of what they've been exposed to. We have not quantified the forces, thermal and mechanical, of the vent and burn process. And we are now trying to draw conclusions regarding the pressure relief devices.
Okay, thank you. Mr. Lynham.
Okay, the next set of questions are going to be for Mr. Dorsey. Do reclosing pressure relief devices need to operate beyond the 100 mint benchmark established for thermal protection systems?
So yes, thank you for the question. The 100-minute, as you stated, the 100-minute standard has to do with thermal protective systems, and I believe it's a response requirement. The reclosing pressure relief valve is on the car to protect the tank, and I would expect that it would function long beyond the 100 minutes, depending on the impingement, the amount of energy put in the car, and things like that. I would expect it to operate continuously long beyond the 100 minutes.
And what can you tell us about the service history of the pressure relief devices and angle valves used on the 5 DOT 105 tank cars? And I'll give you some idea of what I'm talking about here. The A34247 and A3700 series PRDs and Midland A720 angle valves.
So the PRDs, as Mr. Zimmerman stated, we have no I mean, they have a long history of being in service, and I have no issues that I'm aware of with those designs. The Midland 720 angle valves that were on the vinyl chloride cars have the AER tank car committee met, and Midland came up with a root cause for a problem that they had noticed in service. All those valves are being modified with a change to the way the packing stem protects the stem threads. And that program, I believe, is due to be completed next year. And all new 720 style valves have the changes to the way the packing stem is protected from deteriorating packing. Does that answer your You okay?
Yes, it does. Thank you. This next few questions are for Mr. Schoonover. Do you agree with Mr. Dorsey? Should the function of the pressure relief device be tied to the 100-minute benchmark for function of thermal protection systems?
Thanks, Mr. Lynham. The design of a pressure relief valve is to safely relieve the pressure until the car is either empty or the situation is resolved. And so if that goes beyond the 100 minutes, we expect it to operate beyond the 100 minutes. So I hope that answers your question.
It does. Just to follow up on that, what would be the consequences if a pressure relief device fails to actuate while there is still product left in a tank car exposed to a pool fire?
You're going to build up pressure in the car and up to and including potential catastrophic failure.
Okay. This next question, Mr. McKissick, do you have any expectations that the pressure relief device should continue to operate beyond the 100-minute benchmark for thermal protection system performance for a tank car?
I think Mr. Schoonover accurately said it. The pressure relief device should continue to operate as long as pressure is building in the car to keep the pressure in the tank below the burst pressure of the tank. I will add one thing that it also depends on how much commodity is left in the tank as far as how long it could go.
Okay, thank you. Next question, Mr. Keltz. We understand that the Federal Railroad Administration conducted a review of equipment approvals for some of the tank cars involved in the East Palestine derailment. Please tell us what the FRA found for the specific tank cars.
Yeah, so as part of the follow-up of the 5 VCM cars, when we captured the valves off of those cars for additional forensic analysis, we acquired the approval information and all of the design parameters for the cars. That's one of our operations to ensure that the cars are compliant with all the federal regulations and are compatible with the products that they're transporting at the time. So what we did is we took a review of all the approvals for the 5 VCM cars, first looking at the service equipment, the valves, and the fittings, because that's what really drove this, because we were capturing the valves and fittings off of the cars for additional forensic analysis. During that review process, we found some anomalies and some nonconformities with those approvals. Starting with the TILX car, and I'm referring to a document that's an exhibit. It's the Group H exhibit number 1, and this is a high-level summary of again some of the findings that we noted with those approvals. If you look at this document for TILX 402025, you can look down through here and see some discrepancies where when the cars have their approvals, these are documented on what's called a certificate of construction. It's an AAR form, industry recognized as AAR form 4-2. When we looked at the drawings that were provided along with the certificates of construction, we noticed there was issues with the different revision levels that were not captured on the certificates of construction. So what happens there is if you have, on the certificate of construction, if it's listing an original drawing and the car is altered subsequently to that approval, and now it's, now the information is being provided with a different revision level of the drawings, there could be potential changes to the cars that may make them unsafe due to design criteria. So that's what we observed with that one particular car. Again, it was the different revisions not captured on the original 4.2 at the time of construction. The next car that we took a look at was the GATX car 95098, and where we noted that this car at one point in time the car was originally built with a James Berry AZFRA 2-inch angle valve, top transfer valves, and at some point in time of its life, the car was changed out to a Midland 720 valve. The equipment owner had this documented on what's another AAR form that's to document the change. It's known as an R1, Exhibit R1. It's essentially a shorthand version of the 4.2, and where you can document precedent changes or alterations to the cars. What this lacked is they made the modification, but they didn't list on the R1 what the precedent approval was that they were referencing to make this alteration. So that alteration was made without having any type of precedent approval that we were able to ascertain from the equipment owner. One of the big things that we noted with this particular car is, I believe this was the car that was initially approved for no, this was not. This is the other car. This car had the angle or the pressure relief device changed out at some point as well. So the car was originally equipped with a 225 PSI start to discharge pressure relief device, and at some point it was modified to a 247.5 start to discharge pressure relief device. And you can see again where there's discrepancies within the approval process. You know, where it just, you know, the paperwork wasn't supporting how the car was discovered in transportation. And one of the significant issues with this, and again, I got in front of myself, I remembered that it was this car. This car on its original approval, it was put into service for propylene oxide, and on the 4-2 form, the statement was for propylene oxide and products authorized in DOT 173 for which there are no special commodity requirements, and so on and so forth. Propylene oxide it's a different type of material than vinyl chloride, so we're dealing with this is a hazard class 3 packing group 1 material, where that is not vinyl chloride. Also, vinyl chloride has special provisions within the hazardous material regulations. They're commonly referred to as bulk transportation codes or B codes. So there's a specific B code associated with vinyl chloride that talks about the formation of acetylites and to ensure chemical compatibility with any types of fittings that are on the car. So we could not find any documented evidence where this car was properly approved for vinyl chloride service or these B codes, these special provision codes, both within the section 173, the hazard material regulations, nor those bulk special provision codes were applied for this. That was kind of alarming when we saw that. And then we move on to the 3 OCPX cars, and again, you can see for OCPX 80235, again, the relief device size and remove the 34247 and apply a 37247. Those valves sound similar, but they have a different flow capacity to them. So again, this wasn't this wasn't properly documented with any type of R1 or 4.2. No precedent approval that was provided during the information to both NTSB and FRA. I know we both made several requests of the equipment owners to ensure that we had all these documents in place before we made these types of assessments, and we just didn't find it. This car also had its angle valves at some point were altered as well. You know, where the cars we found them, they were equipped with 720s at the time, Midland 720 valves at the time of the derailment. And this car had some qualification records that showed that the valves were actually Midland A724s. And I believe a 724 is different from a material of construction where it's stainless steel. Is that correct, Mr. Zimmerman? Versus a 720, which is a carbon steel body. And again, I mentioned there's a special provision code for vinyl chloride, with concerns around the chemical compatibility. And again, for all three of the cars, you know, we just had missing or incorrect information on the AR Form 42, such as dates. The dates weren't signed off. I believe there were some of these cars that didn't have car builder's signature, you know, attesting that the cars were in accordance with their approvals prior to placing them in hazardous material transportation and things like that. And again, this is just a summary. There was a fair amount, a significant amount, both with the approval documentation and the subsequent qualification and maintenance records that we took exception to during this review.
All right, thank you. Just quickly, we're running out of time, I see. Could any of the equipment approval deficiencies you noted lead to tank car performance or safety problems?
That we don't know, because we're not the group that does the approvals. That's, you know, the approvals are done through the AAR and the tank car committee approval process, and where they use a third party, you know, subject matter expert to do an engineering analysis on those. So we, FRA, we don't have no way of knowing if there was anything there that would potentially negatively impact these cars as they were in transportation.
All right, and lastly, could you please comment on whether your findings are isolated incidents, or is this a more widespread problem within the industry?
Yeah, so we've been looking at this for a number of years, and one of the tank car team staff members coined a phrase a few years ago where we look at these and it's essentially a paper match car match paper type exercise for the service that it's in. We've been looking at these for the past few years, and it seems to be fairly commonplace that none of the approvals are 100% compliant 100% of the time. So it's an issue. We have some additional bandwidth now within the group with the addition of another engineer this past year. So we're taking a harder look at these as we're going out and auditing tank car facilities and the equipment owners' qualification and maintenance programs as well, to ensure that these approvals are all in place. These approvals are what, you know, that's the science and the engineering analysis that supports the cars for the transportation of the products that they're in. So this is very key. If these approvals aren't in place and proper, nobody knows if these cars are going to perform the way that they're supposed to. You know, normal incident to transportation or in derailment scenarios such as what we experienced here.
All right, thank you. I'll turn it over to Mr. Doherty.
Thank you. So, Mr. Dorsey, continuing on from Mr. Keltz's comments, can you explain the process required for a tank car owner to change a tank car's service from one commodity to another?
So generally, they would submit a change to the AAR and note the change in commodity. If there are any modifications or alterations needed for that car to change commodities, then a 4-2 would be submitted with the alterations that were being planned for that car, and it would be reviewed. And that review would indicate that it is in compliance with the AER interchange standards or the federal regulations or Transport Canada's TDG. But I guess that's, yeah.
Thank you for that. Could you explain the AAR delegated authority and the process that is used to review tank car builder's application for certificates of construction?
So a builder would submit a 4-2 for a group of cars, a certificate of construction request for a group of cars, and it would have basically an outline of the equipment and configuration of the car, features such as head shields, or if they were going to be included. And then that would go to a third-party engineer who reviews those based on a checklist that we've developed and his longtime experience. But the checklist is then submitted with the 4-2 into our system. It's all an online system now. And once that is complete, then it comes to basically my queue. And then I review the results of the independent third parties evaluation. And I also review the general package. My particular concern is any recent changes made to the regulations. I'm also watching them for trends. And then based on my determination that they comply with the federal regulations or the Canadian federal regulations and interchange standards, I would approve those on behalf of the Tank Car Committee.
All right, thank you. We're almost out of time, but one last question for you. What are the responsibilities of the various parties, tank car builders, owners, shippers, in ensuring the equipment is approved for hazardous materials service?
So the builder would build them to within the specifications for a hazardous material package. That builder would have consultation with the shipper to ensure or to equip those with the components that would be compatible for the service the shipper intends the car for. And then the AAR reviews all that to ensure that it would be within the federal regulations or the interchange standards.
All right, thank you. And we're out of time. I'm going to turn it back over to Mr. Stansel.
Yes, Chair Hamady, we would like some extra time if it's available, but that's all we have for now.
Well, I was going to allow Mr. Doherty to continue on his questioning for another 15 minutes,
Thank you.
unless you don't want it.
All right, thank you. Mr. Dorsey, what are the safety consequences if the tank car owners do not file the appropriate equipment approvals with the AAR?
Thank you for that. I couldn't actually comment on the safety consequences without knowing what was changed. The approvals are required to maintain compliance, and it does serve as a check or a balance to make sure that the package is at least being planned to be within the regulation, but without knowing what change was made without the approval, I couldn't comment on the actual safety implication.
Thank you. I'm going to turn it over to Mr. Keltz. Do you have anything to add regarding the equipment review process and responsibility of tank car builders, owners, and shippers?
No, I would just like to build on where the requirements for that reside. So they actually start within the federal hazardous material regulations under 49 CFR Part 179, specifically 179.3.5.6. As the AAR has mentioned previously, that there are numerous standards incorporated by reference into the hazardous material regulation, into the federal regulations, and that's where it starts. So the approvals, from the original approvals and designs, it starts in Part 179 for the car itself, and throughout Part 179, we use in the regulation the term approval, and we define it as approval by the Tank Car Committee. That term approval appears approximately 100 times within the hazardous material regulation. So it's not only the car itself, the package itself, but there's also valves and fittings and of the like, things of the like that also receive standalone approval along with the car. So the origins are within hazardous material regulations in Part 179 for the specification portion of it. And the other piece is in Part 173.31 where it speaks about the change of service from one initial product to another initial product. And again, it refers to the AAR standards, the tank car manual on how to go about doing that. I just wanted to establish the foundation as to where those approvals come from.
And thank you. And what is the importance of having a robust review process in place to ensure the equipment is properly reviewed and approved?
Can you repeat the question? A lot of echo.
Yes, sir. What is the importance to have a robust review process in place to ensure the equipment is properly reviewed and improved?
Yeah, so Again, as I mentioned, without a proper engineering analysis, looking at all of the design features of the car, chemical compatibility, things of that nature, there could be safety issues that could get overlooked in the design process. Like I mentioned, with the vinyl chloride cars, there's a special provision code that the operator must take into account for to the formation of acetylites with some of the components. You know, if that type of thing occurs, it could render PRDs inoperative. There's a whole litany of issues that could arise from not having appropriate approvals in place, properly vetted and approved as such.
Thank you. I'm going to turn the questioning over to Mr. Stansel.
Yes, thank you, Mr. Doherty. Ms. Stegman, Mr. Keltz's testimony suggested that all 5 of the vinyl chloride tank cars had various degrees of nonconformance with regard to approvals. Please tell us about your policies and procedures for verifying compliance with your tank car equipment approvals.
Yes, thank you for the opportunity. I do want to start off with saying that we received this list through the NTSB investigation process in June. This document was uploaded to the website in preparation for the investigative hearing, so we've only had this information presented to us in just the last 2 weeks. So this is the first time when we saw the information. We did reach out to the FRA to follow up to see. Mr. Keltz and I had several conversations in May to see if there were concerns, but again, we did not have any clarity on what their concerns may be. I made a few notes as there was discussions. As noted from the observations, many of the observations are related to administrative and approval processes related to documents. We began turning documents over to the agencies while the derailment was here in East Palestine in the beginning of February. We continued providing documents as requested, and Mr. Keltz did request all documents related to our rail cars. Just specific to the Oxy cars, the ones that we own, the 3 OCPX cars, we turned over in excess 350 pages of documents. I want to give an example of something that we worked on Memorial Day weekend. As we reviewed the group factual report, it was in there that we were missing material of construction in one situation. We replied back to the NTSB investigation and asked for a correction in that group factual report. That edit was declined. We went back and worked the Thursday before Memorial Day weekend, pulled my team together. We reviewed the original 2 documents submitted to Mr. Keltz in March 13th. We referenced drawing 1, which clearly then referenced drawing 2, and the material of construction of concern that was missing was on drawing 2. We resubmitted those drawings to Mr. Stansel, Mr. Payon, and Mr. Doherty, and you agreed with that review. We turned over with the OCPX documents over 300 pages of drawings, approvals, bench test procedure documents, and each of these documents has many, many, many elements to them. Again, we take this issue seriously, and I think our efforts in May and what we've done since we've gotten this list in the last 2 weeks will demonstrate the seriousness of which Oxy responds to concerns by regulators. In the last 2 weeks, my team has pulled together. We are going back through our document search. As I said in my opening statement, we use a range of suppliers to help us be compliant. We use an outside consultant with over 35 years of experience. We have a firm that tracks and traces rail car and manages our maintenance and repairs and approvals. We've set some new expectations with them. They have pulled a team together. And again, we needed the specific list, and we're going to go back and look at our documents to see if we can close these gaps. Several years ago, in the role I'm in my previous role, we've made an effort, concerted effort as a continuous improvement to take all of our manual documents and scan them electronically for better and more efficient retrieving. So we're going to go back and make sure that our electronic filing did not leave any gaps that have the document but cannot find. I do agree with Mr. Kelps that we do have some administrative issues. We've looked at our own internal reviews, and we do see some opportunities. However, I want to be clear that the list of observations does not represent any safety, performance, or design issues. Our team has looked at the design. Even though we do not own the 2 cars by the lessors, they meet the DOT 105 specifications for vinyl chloride. The special provision looking at the GATX car, and GATX is a party to this hearing, and they will need to answer for their approval processes. However, we looked at the GATX car. It has an excess flow valve on that. That is one of the special provisions. So we believe that we can work through with the federal agencies, understand the perspective, and learn from that dialogue so we can enhance our maintenance tracking and approval processes.
Well,
thank you.
Thank you. I appreciate your perspective and your answer as to the specific tank cars. My question was actually more broad than that, but I'm glad you were able to address the specific cars as well.
Thank you for the opportunity, Mr. Stansel.
You're welcome. Mr. Schoonover, as Mr. Kelts had mentioned, this being a more widespread issue in the industry, and if compliance with the approval requirements continues to be a significant problem, what could FRA and PHMSA, I guess this is both to Mr. Kelts and Mr. Schoonover, what could FRA and PHMSA do to ensure that more thorough reviews are done before tank car equipment is approved for hazardous material service?
So the role of PHMSA in this particular aspect is to serve as the foundation for the regulatory system and to take a cross-modal approach. We rely on our modal partners, in this case FRA, to really oversee the compliance oversight aspect of that. When they ask for our help and we need extra resources, we always do this in collaboration. So we look forward to offering any assistance to them that we can. But from a broader perspective, we've been considering steps that we need to take. We've been considering regulatory actions. Unfortunately, because we have it in an open docket, I'm not permitted to discuss that. But we are considering actions that we can take that address this, the issues that we've been finding. So.
Mr. Kelts, do you have anything to add to that?
No, I don't.
Okay. Mr. Dorsey, what can you tell us about AAR's efforts to ensure effectiveness of equipment review and approval processes?
So the AAR grants approvals as per the standards regulations. We are trying to develop tools to help owners record and track the equipment that's on cars. We've started with pressure relief valves, and we're trying to expand that into the rest of the pressure relief devices as they're critical to the safety of the cars. After that, we'll probably expand into the rest of the service equipment. So it's called a component tracking system, and it would allow both the railroads and the owners to be aware of specifically what valve is on their car and when it was put on and when it was taken off. As for the rest of the approvals, I'd have to look at the specific concerns in this particular case, but we are working on tools to help owners comply with their requirements.
Yes, sir. Thank you. Ms. Stegman, I just wanted to close the gap on a discussion that began yesterday, and this relates to the safety data sheet for vinyl chloride monomer. And I know we heard some testimony yesterday that suggests that this might not be the case regarding its incompatibility with reactive metals such as aluminum. Can you explain why oxyvinyls uses tank cars that have aluminum components such as the aluminum-coated spring on TILX 402025? That's the aluminum-coated pressure relief device spring. and the aluminum protective housing covers on OCPX 80235 and OCPX 80179 and GATX 95098, and the aluminum hand wheels on vapor and liquid angle valves.
Yes, thank you, Mr. Stansel. That was a long question.
Yeah. I can break it up if you need to.
Looking at the protective housings, there was a time period in industry where that was the standard. Today, as we purchase and bring fleets onto, we have, I'm sorry, as we add rail cars to our fleet, we are replacing or adding them with carbon steel protective housings. However, there was a period of time based on ergonomics and the safety of our loaders, which was an industry standard, protective aluminum housing covers were common because they're lighter weight than the carbon steel. As industry has advanced technology, there's now lift assist, which takes the weight off the loader so that they can more easily manipulate and open and close the carbon steel housing. And so our go forward is, as we have brought new fleets, which is why you see the TILX car is fitted with a carbon steel protective housing, because that's one of the newest cars that was involved in the derailment, and it had carbon steel. So I believe I adequately addressed that, hopefully. In regards to the spring, I believe my colleagues yesterday, Mr. Thomas and also Dr. Carroll, made very clear that aluminum is not incompatible with stabilized vinyl chloride monomer. So the SDS is a broad communication document that covers potential hazards in a wide range of situations across many process conditions. In the case of stabilized vinyl chloride monomer, aluminum is not a concern, a compatibility concern. And then regarding the aluminum hand wheels, we have over time migrated, enhancing our tank car fleet. We had a concern with a previous brand of hand wheels, and we moved to the Midland angle valves because of the reliability, operable operations, and maintenance ease. And this was based off of some of the feedback we got from our loading technicians, our process supervisors, as well as our reliability engineers. And so we began a migration over to the Midland valves, which happened to be one of the 4-1s or administrative approvals that we referenced, was moving over to the Midland valves. And the Midland valves are come with an aluminum handle wheel, so I guess it would be best to maybe have one of the equipment manufacturers talk a little bit about the aluminum fittings hand wheels. Thank you.
Thank you, and we hope to get to that question later, but I see we're out of time. We'll take more if we can get it later. Thank you.
Thank you very much. We're now going to move on to the parties. And again, I think everybody's very familiar with the rules. So we'll start at the industry table.
This is Amy Hamilton from Trinity Rail. We have no questions at this time.
Okay. Norfolk Southern.
David Gooden with Norfolk Southern. We have no questions at this time. We'll yield our time back.
Oxy Vinyls.
Paul Thomas, Oxy Vinyls. First question for Mr. Zimmerman. Please expand on your comment that the as-tested condition of the PRDs or pressure safety valves may not be indicative of the relief device's condition before the vent and burn.
Yeah, in general, if we receive a piece of service equipment back from the field, we don't know the conditions in which it was removed, cleaned, transferred, stored before it arrives back. In the case of this incident, obviously the vent and burn was a significant event, a significant thermal event that may have contributed to the damage seen on the service equipment.
Thank you for that. One more follow-up question. The safety relief device or pressure relief device examination and testing occurred almost 6 weeks after the incident. Is it possible that the corrosion occurred after the incident but before the examination of the pressure relief devices?
Without knowing the nature of the root cause of that corrosion, I can't say, but it's certainly possible.
Okay, thank you for that. Next question is for Mr. Keltz. Did the FRA perform a tank approval summary on the ethylene glycol monobutyl ether tank car?
No, we didn't look at any of the other tank cars. We started this initiative once we captured, along with NTSB, once we captured the fittings arrangements for additional analyses. That's when it started.
Okay, thank you. So just make sure I'm clear. It appears that the FRA only did the tank car approval summary on the tank cars that did not breach in the derailment. Is that correct?
Yes, in this derailment, yes. We only looked at the 5 VCM cars, and again, we initiated that approval review based on the collecting of those valves and fittings. Again, our statement, our passages, paper match car, car match paper. We wanted to make sure that the valves we were looking at for that post-accident evaluation were what was approved to be on those cars. So that's why we took those efforts.
Okay, thank you, sir. Appreciate your answers.
Yes, sir.
That's all we have. Thank you.
Thank you very much. We'll move on to the labor table. Railroad signalman.
We don't have any questions, so we'll yield our time.
All right, locomotive engineers.
Randy Fannin, BLET, we have no questions.
Smart.
Jared Cassidy with Smart TD. I'm going to dip my toe in the water here, and I didn't think anyone could be more fun than panel 2 yesterday, but
Jared, can you hold the mic?
oh yeah, sorry. Jared Cassidy with Smart TD. I'm going to dip my toe in the water here. I didn't think anyone could be more fun than panel 2 yesterday, but you all are giving them a pretty good race. Look, as a conductor and engineer, I don't have a lot of knowledge on the construction or how these cars are built, but what I do have is a lot of concern for how my train is made up when I want to move freight. And I'm curious, since I have access to this panel, has anyone looked at the makeup of the train in this incident and the cars that were adjacent? Are there certain types of cars that could provide more risk to puncture of these tank cars than others? Or is it kind of fair game across the system that a car is a car and the risk of puncture is the same? And ultimately what I'm getting at is for the conductors and engineers in the industry, when we look at the train makeup, are there things that we should be looking for that could pose more of a risk in an incident like this? Does that make sense? I guess we'll start with FRA and PHMSA maybe.
So that's a great question. We are doing research on train makeup in relation to some previous accidents and trying to understand it. And one of the questions that we keep asking is, because there's a lot of concern over buffer cars and where should hazmat be placed in the train, but we're going further and also asking ourselves what other materials should be placed next to it, and are there materials that shouldn't be. But generally, when you look at the punctures, a lot of these punctures, and Mr. Keltz can correct me, but I think a lot of those were couplers, and those punctures are the behavior of the shelf couplers with other couplers, so, and normal train behavior in an accident.
Okay, thank you. Mr. Keltz, I honestly don't know what you were referencing earlier. I'm curious what you meant by the oxyvinyl cars, or the vinyl chloride cars, excuse me, did not have any mechanical damage. What did you mean when you say no mechanical damage?
Yeah, what I meant by that, there obviously there was mechanical damage to the cars, right? The jackets were mangled up pretty hard. The running gear and the brake systems were pretty much destroyed. But from our perspective, the tank itself had no type of mechanical damage to it other than some dents and deformations that we found post-accident. And then there was no evidence of any breaching on those cars.
Okay, thank you. And then my last question, just out of curiosity, on the approval process, if someone does not seek the proper approvals and I'm still not 100% sure what the cycle is here or who's responsible for it. Are there consequences for not receiving the proper approvals, and what are those consequences?
So the only way a tank car, DOT specification tank car is approved for hazardous materials service is if it has its approval. That is the only way that it is authorized to transport hazmat by rail. So if the approvals processes aren't in place, it's essentially an illegal car in transportation. And if FRA or the Hazardous Material Division, those inspectors find those types of scenarios, they can actually notify the railroad and essentially stop the train and have that car, pulled from the train as such. We have found, well, not necessarily regarding the approvals, but we have found materials in unauthorized specification cars where they have done that. So that's the consequence for not having the approvals in place. They're essentially an illegal hazardous material package at that point.
Okay. All right. Thank you.
Yes, Jason Cox with Transportation Communications Union. Is it possible to get Exhibit H42 pulled up?
Sorry, one more time.
Is it possible to get Exhibit H42 pulled up? I couldn't ask the question myself because I was sitting on the panel previously, but with H42, and I'm directing this to Paul Williams, the Norfolk and Southern representative currently up there. It was asked to your counterpart if there was a written policy on freight car inspection times, and according to this, it says walk one side of cars, coupling hoses between cars, inspect same side, looking for obvious switch damage, make in-train repairs and document as required. Note, cycle time is for a 50-car cut at 0.5 minutes per car with one car inspector. That's 30 seconds aside in writing. Can you address that policy, or is that outside your wheelhouse?
No, I can't. I cannot, because that's outside of my area of expertise. I'm not aware of any time limits.
Okay, even though it's in writing right here from NS's own database.
Yes, sir, I can read that, but I was not aware of it until just now.
Okay, thank you. I have no further questions.
Okay. Firefighters.
Thank you. Paul Carey, IFF. First of all, thank you to the witnesses. Very informative, very good testimony. I'm not sure if Mr. Keltz or Mr. Shinova could answer this, but as we all know, when the first responders arrived at this chaotic event, they were not able to get good information off of placards, and I know from having been to the scene that the placards melted off. Has there been any thought given to regulating the use of maybe like steel placards, some better resilient material other than paper and plastic that is destroyed during a fire?
So I'll start with that one because that's a more general hazmat question that would fall in my my field. And we're always looking for better technology. I'm not sure how we would address or what material we would use to prevent that, because we see steel placards and other placards in the highway mode that get consumed in fires. In addition, during an accident, the placard holders get folded under. They get obscured. They're covered in mud and other debris. So we're really looking at other technology that can provide information to responders very quickly to get there, and trying to build redundancy into the system. One of the things we train responders to look at now is reporting marks and numbers. And so you can tell what the car is by the different reporting marks and numbers on the car as well. So, using that redundancy to try to help them, but also looking at ways we can build technology into the system. So.
Great, thank you for that answer. And I do understand, I know on the highway we've had many incidents where they get distorted and things like that. I also understand that the placards and labeling and things like that are one piece of the puzzle. And I know what you're saying about redundancy. However, in this day and age, with the technology we have, I mean, we put people on the moon. I mean, there's got to be a material that can, be fire resistant and withstand a lot of fire exposure that will kind of remain in place enough for us to get some information. I think it's vital for you to look at. Thank you.
All right, thank you. We're going to move on to the government panel, state and local and feds. Figure out who goes first.
Okay, thank you, Carl Alexi, FRA. First, a quick question to Mr. Williams. Was there, before the 100-minute mark, was there any venting of VCM?
I was not there at the time it first started to vent, but from what I understand, there was no visible venting prior to 100 minutes.
Okay, so there was also no loss from other valves and fittings prior to the 100-minute mark.
Are you referring to the VCM cars?
VCM cars.
Yes, sir.
Same thing. Okay, thanks.
Carl,
Please.
would you mind holding your mic?
Sure.
Okay, thanks.
Sure. Let's see. This is a question for Mr. Keltz. After East Palestine, the Secretary had a call to action to industry, to Congress, and internally to the department. One of those things that the Secretary wanted us to do was take a look at the tank car fleet, specifically looking at the phase out of the DOT 111s. And one of the things that I know that your team did was to reach out to tank car owners and find out because we know from just recent history how well the DOT 117s perform relative to behave in a derailment compared to the DOT 111s. So the faster we phase those out, the better. But you contacted some of the tank car owners that cover a good portion of the fleet. What did you learn were some of the issues that they were facing with expediting that phase out?
Yeah, so that initiative, we looked at the top 9 owners of tank cars in North America, which encompassed approximately 83% of the North American tank car fleet. So, we got the mass majority of the tank cars captured in this survey. Both pressure cars, general purpose cars, but we specifically focused the survey questions along the lines of the utilization of DOT 111s in lieu of 117Js and Rs. And again, like you'd mentioned, some of the challenges that they were faced with. Some of the feedback that we heard is, when these owners are purchasing or either building these cars for their fleet. Now, these top 9 owners, these were all leasing companies, right? These were not owners of cars that were actually utilizing them for any type of their service. So these were all either the builder/owners, and some of the financial institutes own these cars as a revenue generating stream, as a leasing asset. So these were the folks that we were dealing with. So what we heard right off of the bat was, these are a 50-year asset, right? These DOT 111s. So what they were, being that they're a 50-year asset, they want to leave them in transportation as long as they can to obviously get their return on that investment back, right? They did this based on the phase out that was enacted by the FAST Act. So that was the target they're shooting at, right? So that's some of the challenges they were looking at, right? Have all that initial, that cost that was outlaid for these assets. Some of the other issues or leasing agreements that we heard can complicate things. You know, if you have a shipper that comes in and wants a block of cars, some of those lease agreements can be lengthy in terms, and it sounds like some of those contracts are difficult to break. So that's why some of those cars are actually captive. You know, they have 111s in those flammable liquid service. They're captive there until the lease expires on them, or unfortunately something would happen to the asset. Something else that we noted was, you know, several 117s in this derailment along out in transportation. We've noted some 117s transporting non-hazardous materials, such as this incident. We had lube oil, and what they were doing. You know, the answers we received there is when they're bringing new cars on, adding cars to their portfolio, they may not have an assigned service for them when they're bringing them into the fleet, right? So they're just changing out fleet assets. So if they can utilize that type of newer car for a lesser hazardous material, that's why they're moving those some of those cars, those better cars, into those less hazardous material service. So it's kind of a complex dynamic with how these companies purchase, own, operate, lease the cars.
Okay, all right, thank you. My time's up.
It's on. Okay, good. Not good at this. Ms. Stegman, you mentioned earlier, or maybe I misheard you, but you said, I know all five of the vinyl chloride cars performed. I'm sorry. Is this better?
Yeah.
Chair Hamidi.
I know they didn't have mechanical damage.
We need to clarify his role as the.
I'm sorry.
Great, go ahead.
Can you remind me your?
I'm sitting in for Mr. Schoonover while he's.
Okay, but I thought Olivia was the spokesperson when he's up on the. Okay.
Ma'am, you said that all five performed, but did all of the valves get stuck?
Hang on. Is there a problem with Mr. Davis serving as a spokesperson?
I just wanted to clarify that we did have the right spokesperson as the alternate.
Okay, but Mr. Davis can serve as a spokesperson while Mr. Schoonover's up here. Go for it, Mr. Davis.
Thank you very much. I apologize. So, Ms. Stegman, we all accept that there was no mechanical damage to the 5 vinyl chloride cars. I was wondering, it sounded to me when you testified earlier that all of the pressure relief devices functioned as they should. Is that accurate?
Correct. That was my statement.
Okay. And then we saw 2 that appeared to be stuck. Did that happen in testing? Maybe I'm just confused on that. Or did I not see it properly?
The testing was in March. What I'm saying is the function of a pressure relief device is to relieve the excess pressure of a tank so that it does not rupture. The pressure relief devices functioned as designed during the incident at East Palestine. The tanks, we saw, according to witness testimony, all 5 relief valves activated during the scene, and we saw the videos and pictures that they were relieving and, as we talked about, reclosing. The tanks remained intact through the duration of the incident for 60+ hours. We had a vent and burn operation, which is very unique to this incident. As we have said many times over the last 2 days, it's a last resort incident and not something that's done frequently. We are now looking at relief valves that were exposed to those thermal and mechanical stresses of the vent and burn. All I'm stating is that the conditions of those relief valves reflect relief valves that have performed and went through a vent and burn process.
Thank you very much. I appreciate that.
Thank you.
Mr. Zimmerman, have valves of this similar type been tested under field conditions or actually had to endure similar heat stress, pressure relief situations in the past?
If I heard you correctly, you asked if we test these at...
No, I guess what I'm saying is,
LDD?
have they been involved in incidents and performed as specified in the past under heat-related conditions? In other words, have they had to actually vent pressure because of excessive heat, as happened here before?
I'm sorry, I can't quite hear.
I apologize. So in the past, had valves of this make or this specification, had they been involved in incidents before where they've actually had to release pressure from a tank car?
I don't know that answer off the top of my head.
Okay, thank you very much. That's all I have.
Village of East Palestine.
Thank you, Madam Chairman. This is for Mr. Keltz with FRA. Earlier, you were talking about the compliance of the 5 vinyl chloride cars in reference to meeting standards and requirements. Did they, in fact, all 5 meet all federal regulations and standards based on your investigation of those?
So it wouldn't completely nullify it. As some of the observations were somewhat benign. From a technical standpoint, again, I expressed that FRA does not know if, without having those proper approvals in place for those cars, we don't know if they're if they meet that design criteria for that particular product. So yeah, they're not completely nullified, but they're not 100% compliant.
Thank you, sir. That's all, ma'am.
Okay, thanks. We are done with the, do you all mind if we just continue on? Great. So we're going to start with the Board of Inquiry, and I'm going to start. First, for the community members, the reason why we're talking about rail tank cars, first, you want to prevent a tragedy, but second, you want to minimize the damage. And that's why we're talking about stronger tank cars. Mr. Schoonover, how many 111s were on this train? Or Mr. Keltz, either one. Total, hazmat, non-hazmat, how many 111s?
In the entire train?
Correct. Or pick the ones that derailed. Actually, I don't just want the derailed, all the 111s.
The cars that were impacted by the derailment, there were 15 DOT 111s, 2 AAR 211s, and 3 DOT 117s.
Okay. Out of all of those, how many were in flammable liquid service? Class 3 flammable liquid service.
3.
3. How many of the 3 were breached or damaged?
One of them. UTLX 205 907 butyl acrylate stabilized flammable
At car
liquid.
number 50? I have car number 50, is that right?
Yeah.
Okay. The reason and I'm going to come back to this in a minute. So your proposal on the 111s is just to speed up the time frame right now, correct? Not to. Do you have a proposal, Mr. Schoonover, to expand it beyond just Class 3 flammable liquids?
We don't have that proposal at this time, but we are considering it. We're looking at all options. One thing we did point out is that in the interim, the railroads can also take actions to.
Oh, I totally understand that. Totally understand that. The reason why I'm asking these questions is because The community is under the impression that, oh, all these tank cars are going to be replaced with stronger tank cars. One tank car under the proposal, one. I'm not belittling how many gallons that would be, but we can't mislead communities after derailments in making proposals that don't directly go to the cause. Yes, that's part of the problem, but we're talking one tank car. Now, and again, how many gallons in a tank car, you think? 20,000?
25,000.
25,000 gallons. So that is significant. But one tank car out of 149 cars and numerous hazmat cars. I am going to come back to this in a minute, but now I'll turn it over to Vice Chairman Landsberg.
Thank you, Chair. I think we've seen that DOT 111 tank cars might best be used for hauling corn syrup as opposed to anything flammable. We've had a recommendation out on that since 2015, and I believe it's currently open unacceptable because you haven't met the deadlines that we agreed to. We've talked about retrofits, jackets, thermal protection, and equipping them with proper PRDs. Mr. Kels or Mr. Schoonover, could you tell me how many DOT 111s have breached in the last 3 years and have caught fire?
I don't know that number off the top of my head, but
could we get that?
Yes, I can provide that information.
I think it would be helpful to inform the investigation to show the magnitude of the threat of, well, the shippers or the tank car leaseholders are, I understand they want to get their return on investment. So now we get into the whole question of economics versus safety, and I think everybody understands where that one's going.
So let me get the ask right. DOT 111s
that have breached in the last 3 years.
Last 3 years?
Last 3 years, because theoretically this should have all been taken care of by 2020. So I'll give you the benefit of the doubt, last 3 years, and have caught fire. So I don't care if it's been corn syrup or Slurpees or whatever. I want to know that what's caught fire, because that's really what we're talking about. They can continue to use 111s for non-flammable materials. That's perfectly fine. And I would hope that the leaseholders would make that shift quickly, and I would hope that AAR would encourage them to do so. Mr. Kels, does changing the tank car contents affect the requirements for the PRBs? So if a tank car has been certified for benzene, for example, and then it is changed over to oxyvinyl, does the PRD have to be changed or recertified?
Potentially, it needs to be changed out based on the venting capacity. And again, it depends on the service that it's in. So if it's in a flammable liquid service,
right,
and it needs the requirement for a thermal protection system, the PRV, the pressure relief device, is part of that thermal protection system. So that's one of the items that needs to be looked at when they're moving it from one product to another product to ensure that they have.
Requirement. There is a law that says that you must do this. Am I understanding that correctly?
Correct, yes.
Okay, so in terms of this documentation, who's responsible for doing that? The owner, the shipper, the manufacturer, FRA, AAR? It seems like everybody is kind of pointing their fingers, and we don't seem to have a system to be able to ascertain when a car is in compliance or not. Is that correct or not?
I can answer that. Ultimately, the shipper is responsible for making sure the car that they use is appropriate for their commodity. They're the entity that knows the material they're going to ship. So they have primary responsibility. The car owner has a responsibility to make sure the car is compliant with what the shipper needs. And so there's a synthesis that has to occur, but ultimately we hold the shipper and the car owners accountable for their functions that they do.
So who enforces this?
We do. That's part of what the function of the FRA's tank car safety team does.
Are you doing that?
Yes, we are.
100%?
Not 100%.
What percentage at this point? And I realize within the vagaries of personnel and government hiring and all of that, but how long will it take you to get to the high 90s?
That would take a while. Like I mentioned previously, we just added some bandwidth in our engineering group. Our engineering group is primarily who performs this function through owner audits. We have 3 engineers on staff, and we have over 400 different tank car owners.
How many cars is that might be involved in flammable service?
I don't have the total number for flammable service, but I do know we're right at just under 500,000 tank cars in North America.
So is it safe to say you're significantly outgunned?
That would be a safe assessment, yes, sir.
Okay. So we have a regulation, but at present it's unenforceable, essentially.
Utilizing the
resources that you have at this point, it's unenforceable. Is that correct?
Yeah, it's an extremely heavy lift for us, yes, sir.
Is there any kind of penalty after the fact if you find something where somebody has been shipping improperly? What kind of penalty is levied?
Yeah, we can write civil penalty violations.
How much?
I believe our cap is somewhere in approximately $250,000, I think, is under the hazmat.
How many penalties have been assessed in the last year?
Nothing for this. This is something we haven't heavily enforced on until we have recently obtained the additional staffing, so where we could take a harder run on it.
I understand. I'll stop here for the moment, Chair. Thank you.
Thank you. Member Graham.
Thank you, Chair. Mr. Keltz, there were 2 benzene cars that derailed, DPRX 259013 and 258671. Can you tell us whether those cars breached or not in the derailment?
No, neither one of those cars breached. They were further back in the derailment. I believe the one car remained upright on its wheels, and the leading car, it was derailed, but it was upright. I believe the one end, the truck wheel set was derailed, and that was it. They did suffer flame impingement damage from the fire that occurred in the ditch, but neither one of those cars were compromised. Literally no mechanical damage to them at all, other than the flame impingement.
Great, thank you. Mr. Zimmerman, the PRDs that were on the 105 vinyl chloride cars, in the development of that pressure release device, was it ever tested for corrosion or what could corrode it?
The development of these products far predates me. They were developed in the early 60s. But all of our products they use materials that are approved for use in tank car surface equipment by the AAR Appendix M.
Okay. Is there an inspection cycle or a calibration interval for your PRD device on those 105s?
That's determined by the shipper and the tank car. The tank car will have a service interval. The PRD is part of a qualification and repair activity that would happen at the end of the service of that tank car.
Okay, so that's the shipper that sets that interval if needed, or a calibration?
My understanding is it's the shipper.
Oxy, is that correct?
Can you repeat? I know it's back and forth. Can you kind of phrase that as a question?
Yes, I was asking if there is a set interval for testing the PRDs on the 105 car, or is there an interval for calibration of the pressure release device? And I guess I would go for Trinity Rail also because you're releasing some. So either one of you.
I'll answer that question.
Okay, thank you.
For the pressure relief devices on the VCM cars, we do a very thorough and sophisticated analysis, and we work with the FRA on our techniques. We have a 10-year qualification intervals on those PRVs.
Okay, 10-year. What pressure release were set on those 105 PRDs?
They're qualified for 247.5 PSI.
And who set that and why?
It's a design by the supplier Midland. The actual why that one was specified, it's set at that value, the design value, I can't answer that question.
Okay. Is that adjustable, Mr. Zimmerman? Can they set it for different pressure?
No, that's not the intention of the device. It is intended to be set at the marked pressure.
Okay. And then for Ms. Stegman, did Oxy evaluate that pressure for your product?
Yes, and I believe, and this is not the level of detail that I typically operate at, but I believe it's in the regulations that it's relative to 1/3 the burst pressure of the vessel. So 247 is 1/3 of 750 PSI minimum burst pressure.
Okay, thank you.
Member Chapman.
Thank you, Chair. Mr. Keltz and Mr. Schoonover, I want to alert you. I have a question for Mr. Williams, but I'm going to circle back to you all on this, so you might want to just follow the thread so I don't catch you by surprise. Mr. Williams, I am told, and actually, Julie, can you put up Exhibit D65, please? I'm told that Norfolk Southern was one of the authors of a 2007 report titled Tank Car Vent and Burn Process Study. And as a part of that report, Transportation Technology Center and the FRA conducted a study of vent and burn as a method of hazardous materials incident mitigation. The report states that its purpose is to develop guidelines and tools to aid emergency response personnel in determining when to use the vent and burn method and to help guide them through the procedure. Were any, to your knowledge, were any of the tools developed from this study employed in the decision-making process for the procedure used in East Palestine?
I have to clarify one thing. That was me in a previous life. At that time, I worked for the Association of American Railroads, not Norfolk Southern. In answer to the second part of your question, you would have to check with Mr. McCarty and Mr. Day, because they are the ones that have the checklists for processes go through for vent and burn.
Okay, so you're not aware that any of the tools from this were employed here in East Palestine?
I am not aware, no.
Okay. I understand that the report had several recommendations for emergency responders and incident commanders, including a vent and burn checklist, which seems like it could be beneficial. Again, don't know whether that was done here in East Palestine. Incident commanders could and should use a vent and burn flow chart or process map. Likewise, that seems to have some benefits for a difficult decision, particularly a difficult decision being made by folks that probably aren't terribly familiar with this sort of a process. And I understand also that the report recommended that a vent and burn database be established, which I don't think has occurred. I'm not suggesting that you would know either way, but it's my understanding that that database probably has not been implemented. And I'm told as well that the report identifies vinyl chloride as one of the potential candidates for vent and burn action. And that there may also be special considerations for vinyl chloride noted in the report. Coming back to you, Mr. Schoonover and Mr. Keltz, do you know whether any of the recommendations from this report have been implemented?
I don't know that any have been implemented.
I want to suggest that this is something that, I mean, it may need some updating, but this is the sort of thing that folks should probably give a close look to, because it seems like the sort of resource that would be very helpful to someone like the chief here in East Palestine, who was facing such difficult circumstances. This is the sort of thing that might be very, very useful to others in the future that might be facing that sort of crisis. Thank you. Thanks very much.
Thank you. I'm going to return to car number 50. So car 50 had flammable liquid in it. What was it carrying?
Butyl acrylate stabilized.
Okay, and it lost the entire load, so maybe 25,000 gallons.
Correct, yes.
And again, I'm not minimizing that. I'm just trying to get across that the proposal to increase phasing out of DOT 111s would just have affected one of the cars on this train, not any of the ones that were involved in the vent and burn. I want to see if Ms. Canan can pull up Exhibit F34. So, Mr. Schoonover, the rule that DOT implemented on hazardous materials, enhanced tank car standards, and operational controls for high hazard flammable trains. And I'm going to ask you questions on just the rule, and you're welcome to give me any changes that Congress made as well. In this, okay, thank you. In the proposed rule, you stated that the rulemaking was designed to reduce the frequency and consequences of accidents involving certain trains transporting large volumes of flammable liquids. And it would have addressed some of our accident investigations like Castleton, North Dakota, Aliceville, Alabama, Cherry Valley, Illinois, certainly in Lac-Mégantic in Quebec. Your rule used what hazardous materials that would be subject to the definition of high hazard flammable train?
The rule used flammable liquids.
Class 3 flammable liquids.
Class 3 flammable liquids, yes, ma'am.
But there's lots of other
there are
hazmat out there, not just flammable liquids. At the time, why just flammable liquids?
Because at the time, that was the greatest risk we were seeing, particularly with unit trains of hazardous materials. So when you have a 100-car train, and that was the size of unit trains at the time, 100 cars, you have, 2.5 million gallons of material rolling down the track. And when you have an accident, if you have a lot of failures in those, if you have 40 cars in an accident and you have 20 failures, that's a lot of material that you're subjecting a community to. And the risk was so great that we felt the urge to address those trains. At the same time, we did address getting rid of DOT 111s for all flammable liquids. We went beyond that for getting rid of the DOT 111s.
Right.
But
for the flammable liquids, yes, at the time there was accident after accident involving unit trains transporting crude oil, ethanol. Our comments to PHMSA, I think this was to PHMSA, yes, to PHMSA, wanted PHMSA to consider expanding it to a broad array of hazardous materials, including combustibles and flammable gases. You've just stated why you focused on flammable liquids. Are you considering now any sort of proposal to broaden the definition of high hazard flammable trains, or even asking Congress to broaden the definition of high hazard flammable trains to include other materials like flammable gases and combustibles?
yes, ma'am, we are. We are considering.
Could you talk a little closer?
I'm sorry. Yes, ma'am, we are. We are considering. Considering a rulemaking to adjust or address what is considered a high hazard train, not necessarily a high hazard flammable train, because I think there are other materials that are not flammable that need to be included and given the same protections. We are also we've asked and worked with Congress on the rail safety bill to help adjust that and give them some technical assistance on how they can expand the requirements, because we think there's a need. And this is part of Secretary Buttigieg's 5x5x5 action plan that he addressed. So we're working on that. Right now, we're doing the analysis and trying to figure out where we can go. So.
Great. And there were a couple of hazmat cars on here that were DOT 111 cars transporting combustible liquid.
Yes, ma'am. And
So
hopefully we can.
I mean, because what we don't want to get is into a situation where we're just addressing the most immediate concern, where when we see a number of incidents with ethanol or crude oil, all of a sudden we're just addressing that, and now it's combustible, and now it's the next one. It's always after the fact. The NTSB is on record of phasing out all DOT 111s in hazmat service. So I'm glad to hear that that's something you're working on.
I will say, Madam Chair, I can't disagree with you. I think that's really a laudable goal that we would like to have. But we're trying to do it in a manner that, because we have to consider costs and benefits, that does it in a way that we can actually get that regulation through. So we're trying to do it in the best way we can. I would love for the industry to really step up and get rid of them all on their own. So.
Oh boy, you went there. So what is the cost of the, what does the DOT consider as the cost of a life today? In your cost benefit analysis?
I'd have to look at this.
$9.6 million.
You're right.
It's priceless. They're priceless to us. Yeah. So the other question I have, and this will be my last question in this round, the 20 or more loaded cars or the 35 or more in a mixed freight train. How did you come up with those numbers?
It was based on an analysis we did of how many cars were in accidents, what the industry was doing, and just trying to come up with a number that we felt that we had analyzed the number of cars that were involved in accidents and unit trains, and then our scientific folks figured out how many cars that would be distributed throughout the train. And so that at any point in the train, using an equal distribution, what was the likelihood of having cars? So I hope that answers your,
yes.
There's an algorithm to it.
And how many gallons of hazardous liquid would be 35 or more rail cars? About?
That's a lot. I'm not a good math person, I can tell you, but it's a considerable amount. You're talking about, million gallons.
Million gallons. That's pretty significant. Are you thinking about maybe dropping some of that too? I know there's a law.
We're looking at all of it.
Okay, great.
Yes.
Vice Chairman Landsberg.
Yes, ma'am.
Thank you, Chair. I'm going to show my ignorance on chemistry once again. Ms. Stegman, how long has oxyvinyl been produced? Has it been around for a while? Or vinyl chloride, excuse me. Is it a new product?
No. I've been in the career 34 years, and it way predates me. I don't know the date of origin, but.
So how many years, roughly?
I really don't know. I think we missed the opportunity to ask Dr. Carroll.
Okay, but it's not a new chemical.
Absolutely not.
Okay, and so you were working with Midland Manufacturing to help come up with specifications for your PRDs for your cars, or is that not how it works?
Yes, we work and we spec out cars. I haven't personally spec'd out a car, but that's how the process works.
Okay. Mr. Zimmerman, when you test the PRDs, do you just test them for pressure, or do you also test them for flame and heat? Because when we saw the venting process, it wasn't just pressure of, air coming out. It was corrosive or potentially corrosive liquid and fire and heat and all of that. Does your testing encompass that?
No, they're only tested with air.
It would seem like it would make an awful lot of sense to perhaps figure out how to test them in what is the real world environment and see how stainless steel and some of the items that you put in to the valves would perform under the real world circumstance. In talking with Mr. Stansel and so on, I mean, I think they have a question about exactly when corrosion occurred and so forth. And if we know the PRDs all functioned at least once. The question is, did they then get gummed up as a result of some of the things that weren't tested for? And it would just seem like it would make a lot of sense to start doing that for some of these more liquids. And then my last question, and Mr. Schoonover, I think you've kind of addressed this, but do HHFTs get any special handling?
Yes, sir. There are speed restrictions. There is notification, pre-notification of shipment quantities to state emergency response commissions, tribal emergency response commissions.
Okay.
And some braking enhancements.
Yeah, for Mr. Williams, is there any incentive to avoid that by only putting 19 cars together or only 34 cars in a consist? I realize that might be considered a little duplicitous, but it seems like you might avoid a whole lot of headaches and still be within the regulation.
Not that I'm aware of, no.
Okay. Well, I think there's some opportunities here. As we said, we had 5 cars create a huge problem, and I think there's a great opportunity to really take a look at what the real hazard is. Thank you very much, and thank you to the panel for all of your efforts.
Member Graham.
Thank you, Chair. Mr. Zimmerman, so your PRD device is set up to release pressure from the tank car at 247.5 psi, correct?
Yes, within plus or minus 3%.
Plus or minus. So you would expect pressure as it built up to that point, it would release, and then what would it do? When would it shut off?
It would vent until the pressure drops to the vapor tight pressure.
Okay. So we had vinyl chloride cars that were sitting in pool fires, assuming that the internal product was heating up, building up pressure. It might release for about 30 seconds and then stop for maybe a couple minutes and do it again. Would that sound like a normal function of the PRD?
Yes, if the pressure drops inside the tank during that expelling of the fluid and it drops to the vapor tight, it would reseal and then open again once that pressure increases.
Okay. So we had a tank car, OCPX 80179, that February 4th, Saturday night, I think it was 1731, if I remember right, that hadn't done anything for about 90 minutes to 2 hours, and then emitted violently for 70 minutes, and then did not reopen after that. Based on what you said in your experience, and granted, this was an extreme situation, I would agree with that. What could cause that kind of unusual performance from the pressure release device?
Well, the fact that it opened means that the pressure inside the tank reached its start to discharge, expelled a large quantity of fluid from the tank, decreasing the volume inside the tank, decreasing the pressure. It may have receded and not, again, returned to that start to discharge pressure.
Okay. So that would be an unusual situation, possibly, for the extreme situation.
I mean, that's within its normal function.
Okay. Ms. Stegman, that 70-minute release of the product, is that consistent with your statement earlier that it was functioning as designed and up until the point the vent and burn happened?
Yes, sir.
Okay. Thank you. Thank the panel for everything. I'm willing to defer my time over to the panel afterwards.
I have one last.
Member Chapman.
Chair, I am down to my very last question of the two-day hearing. No one's happier about that than me. Before I get to that, I want to thank all of you certainly for being here today. Very helpful. All of you who have participated, all of our team, and really most of all, the people from the community who have taken time to observe our sometimes dry and not all that interesting process under conditions of extreme heat. My last question, a relative softball, I think, for Mr. Schoonover and Mr. Keltz. We checked on this, as of September 2022, this is last September, the Bureau of Transportation Statistics estimated that 8,322 new DOT 117 or DOT 117R tank cars would be introduced during the year 2022. I don't know how close that number is to the actual number, but there's rounding off. We're looking at roughly 8,000 new or retrofitted tank cars coming online during that last year. How much impact do you think that has had or will have on helping us get the DOT 111s out of the fleet?
I think every car that we can replace is a start, but I think that more can be done. I think that the industry can take additional steps to speed up the process, and we've said as much in our safety advisory that we feel very comfortable that the industry can move well beyond that. And once they change out all the cars in flammable liquid service, move to other services and keep going. But we felt comfortable enough to ask Congress to go back to the 2025 date.
So it's, I guess the short answer might be it's progress, but there's still a long way to go.
Absolutely, sir.
Mr. Keltz, care to comment?
Yeah, I just want to echo what Mr. Schoonover stated, that every one car added to the fleet helps. It could have been the one car out here, right, that was in flammable liquid service that could have potentially prevented this disaster from occurring. So, and again, to echo what Mr. Schoonover said, yeah, tomorrow can't come fast enough for the phase out.
Thank you. Thanks to the panel. Chair, thank you very much.
Thank you, Member Chapman. Okay, Mr. Keltz, do you think it's just a administrative oversight, not really substantive, or have any sort of impact to have all the things you identified on the 5 vinyl chloride tank cars? Do you think it's just administrative, or Ms. Stegman suggested there wasn't really a negative impact to what you had stated was missing in the paperwork?
Well, again, the standards and regulations were created for a reason, to ensure that the DOT specification cars meet critical design characteristics. Those approvals, the requirement for those approvals have been in industry is almost as long as this industry has existed. They were essentially there before the formation of DOT. I've seen language going back to the 1964 rulemaking where that information came about in what's now the hazardous material regulation. So there's a reason for those approvals to be in place. And again, as I previously stated, if there's not a scientific engineering analysis of the 100 points of light that these cars, from a design characteristic standpoint, meet, who is to guarantee that they are going to perform and function as they're intended to design without having all that information captured within the appropriate approvals?
And for GATX 95098, I mean, that one was approved for propylene oxide and products authorized in DOT 173, for which there are no special commodity requirements and non-regulated commodities compatible with this class of car. Yet they're transporting vinyl chloride, and it seems to be a significant issue.
And again, you can do that. You can swap cars from product to product, providing that you go through the appropriate approval process to ensure that that car is compliant and capable of performing in that service.
Okay, great. Thank you. For the, Ms. Stegman, how does Oxyvinyls classify the chemicals on its SDSs?
I am not the SDS technical expert. We had a panel yesterday with two of my colleagues, and I believe they extensively discussed the SDS.
And the reason why I'm asking is I'm asking in response to some questioning on the aluminum components. 1910.1200G of 29 CFR states that chemical manufacturers preparing the SDS shall ensure that the information provided accurately reflects the scientific evidence used in making the hazard classification. The reason why I'm asking these questions is when questioned by the staff about aluminum components on the pressure relief devices and the aluminum covers, the aluminum hand wheels, the spring, you stated that aluminum does not react with vinyl chloride. However, your SDS says that vinyl chloride reacts with incompatible materials and creates strong exothermic reaction with aluminum.
ESDS covers a broad range of applications and a wide range, and identifies potential hazards and concerns, covering a wide range of process conditions within our facilities as well as our customers. As we have communicated and stated, we were transporting stabilized vinyl chloride monomer, and I believe my colleagues, Mr. Thomas and Dr. Carroll, explained that there is not a compatibility concern related to stabilized VCM.
No, I totally understand, and I know what they testified on, but every written document states, let me finish, that there is a reaction, that it is incompatible. Tox Planet, NIOSH Pocket Guide, Chlorine Institute's pamphlet, CITIG's Handbook of Toxic and Hazardous Chemicals and Carcinogens. The only document that you all pointed to was an Encyclopedia of Chemical Processing and Design. That's the end of my question. So I am going to yield 5 minutes to the chief, who has one more question, and then we're going to go to the staff for their additional questions.
Thank you, Madam Chair, and you just kind of took a little bit of my thunder there with your last question, but
sorry.
That's okay. This is for Ms. Stegman. The chair just referenced your SDS sheet, which is Group D, Exhibit 26. I was up there yesterday, so I wasn't able to ask the question. But during the testimony yesterday, it was stated that it references stabilized VC in this document and talks about it not being able to polymerize. I could only find 2 or 3 mentions of stabilizer in this entire document. None of them stating that stabilized vinyl chloride will not go through that process. This is a very important document to first responders. This is something that we rely on to give us information on how to react to the situations at hand. And much like the chairman said, things in here are stating that they react with certain things, including aluminum and air. How are we supposed to do our job effectively if all the information that you have isn't in the documents that you provide us to do our job?
I will respond, but I want to qualify my response. I am not the primary or technical contact on our SDS. Mr. Paul Thomas, my colleague, testified extensively yesterday, and we also, and we will gladly share this in our analysis and future interactions with the NTSB investigation. We can walk you through the SDS. There is a process that you walk where it's stabilized, but as I passionately discussed with Mr. Stansel, Mr. Payon, and Mr. Doherty during the group factual report, they were only referencing sections, I think, 2, 10, and 7 in the group factual report. And during that review meeting, I made a very strong case after several conversations to reference section 14, the transport information section of our SDS. And if you look at that SDS, that section, it says stabilized vinyl chloride monomer. And what I think is also important in that section is the word polymerization is not mentioned. That is because it is stabilized vinyl chloride monomer, and in the absence of oxygen and an initiator primarily, you will not have a chemical reaction. And Dr. Carroll explicitly walked us through that yesterday. So section 14, transport information, does not mention polymerization. It clearly outlines we're transporting stabilized vinyl chloride monomer, and it references the hazmat table, and it has special provisions, number 21. Number 21 references stabilized vinyl chloride and how you stabilize vinyl chloride. B44 talks about not having a reaction with formation of acetylides, which is looking at metals, and if there is a chemical reaction, the hazmat requirement is not to form acetylides. We had technical folks walk Mr. Stansel, I think it was Mr. Doherty, and I don't remember who the third NTSB investigator was, but we had our director of technology, we had our PVC tech steward, and we also had Mr. Smith, who was on the panel yesterday, walk the NTSB investigators through that. I feel like we have thoroughly addressed this, but we take this very seriously. We take your feedback, Mr. Drabeck. I just want to let you know that we have spent months discussing this with the investigation committee, and we look forward to engaging more and answering any future questions, and we are open to suggestions. Thank you.
My suggestion, if I may, would be to put that verbiage somewhere in this document other than referencing 4 numbers in section 14 under a special provision.
So on page 10,
Thank you.
I would like to say on page 10, stability and reactivity, chemical stability, generally stable at normal temperatures and pressures, however, may violently polymerize or generate other hazardous conditions when not stabilized and/or stored correctly.
Thank you. Chief, are you going to read all 10 pages when you're out there fighting a fire?
Absolutely not.
Yeah, exactly.
Thank
All right,
you.
back to the staff.
Thank you, Chair Helmany. Wanted to clarify something with regard to high hazard flammable trains with Mr. Schoonover. This train was carrying 20 hazardous material cars, and at least 3, maybe 4 of them were corrosive liquids, sulfuric acid, so clearly not a high hazard flammable train, correct, Mr. Schoonover?
You are correct.
Okay. Even if the FAST Act requirements for flammable liquids are accelerated, would that apply to a train like this one?
No, sir. That's why we're considering regulatory action to revise the definition.
So without revising the definition of a high hazard flammable train, even if you were to accelerate the phase out, there would be 0 cars affected by the current rules as they're written, correct?
I'm sorry, could you repeat that again?
Even if the phase out were accelerated under the current regulations, that would have affected no cars that were on this train, correct?
It would have affected, and the chair was correct, it would have affected 1 car.
But it's not in a high hazard flammable train.
It would not have made the train a high hazard flammable train, but you have to remember that the HHFT rule also started to get rid of DOT 111s. So while it wouldn't have changed the designation of the train to a high hazard flammable train, it still would have corrected the one car that was there if we accelerated it. So,
okay, thank you for the clarification.
Yeah, absolutely.
Thank you. Mr. Doherty, please continue.
Can I just, it wouldn't have had the operational changes like speed limits and routing and
That's right,
things
you're
like
correct.
that.
It would not have changed the operation.
That's what it would have
Right, it
have
wouldn't
done.
have changed the HHFT designation or provided the extra safety advantages that an HHFT designation provide, but it would have gotten rid of the one car. So I just wanted to be clear that it didn't do not, wouldn't, even if we accelerated it, because the acceleration is really the date of getting rid of 111s. So there's more work that we have to do to change the definition of an HHFT.
Correct.
So,
thank you, sir.
Absolutely.
I want to shift gears back because I have a few more questions about the tank car build process compatibility. A couple of questions for Mr. McKissick. When a rail car manufacturer receives an order to build a new tank car and then submits an application for certificate of construction, what role do rail car manufacturers have in ensuring the service equipment and appurtenances are compatible with the lading?
Thank you for that question, Mr. Daugherty. It's a process that often takes several months. It'll start off with a request for a car from a shipper usually, and then it will go through, and there'll be over several, like I say, several months. There'll be a lot of interaction between the builder and the shipper to make sure that, one, we meet the specifications that they want as far as size of the car. A lot of times they have loading racks they need to fit in, but also things like commodity. So after that process is finished and we agree between the builder and the shipper on the compatibility of both their needs and the regulation, we will submit for a 4-2. And then it goes to a review process where an independent third party will review it. And if in their opinion, it will meet the requirements of all the regulations, they sign their certificate of construction. The car is built. Another signature from the builder is put on there to certify the car was actually built on there, and then is placed in service. And then ultimately, as we talked about many times here, the responsibility is ultimately that the shipper has responsibility to properly contain the commodity.
Thank you. Can you tell me what information do you rely on when selecting the pressure relief devices, angle valves, and other equipment on the tank car?
There's a number of pieces of information we rely upon. We have 45 years of experience building rail cars, so we have quite a database of history of successful applications of these. A lot of times, and I would say the majority of the time, one or two things happen, and there's a lot of overlap in them. We go based on a car that was previously built, and then that's traceable back, so we have a very good history of performance on those cars. And then sometimes there are subtle changes that for whatever reason, sometimes we don't know why, but the shipper will actually request. And then it's a process to go through with our engineers and their experts to give what they need and make sure it's compatible. Then it goes again through the AAR review process.
Thank you. We've obviously had a lot of discussion about PRDs and compatibility. Can you tell me how the decision is made as to what valve or PRD is placed on a tank car?
Well, there are a number of things. Obviously, we're talking about the compatibility here with, I think we've talked about that, where the expertise of the shipper is. Where the builder really goes in and to confirm is the size of the valve. So you have to make sure, we talked about this, I wasn't sure where the question was on how the 247.5 came up, because it could have been a lower pressure relief valve, but this was a request to the customer. You can't go over 33% of the burst pressure, so that gives a maximum. But then we also have to size it based upon two different things. One, for normal operations, we have in the AAR MSRP, we have Appendix A, which is a sizing program, a sizing calculation. And then we also have to, for a 2.1 compressed gas, we have to do a fire analysis of it in 179, and we use a program called AFTEC, which is jointly developed through the, developed and maintained through the RSIA, our safety car, tank car project, which Mr. Dorsey mentioned in his opening statements.
Thank you. Just a few more questions. So in addition to building all the derailed tank cars that transported vinyl chloride, Trinity Industries leased one of them to the shipper Oxyvinyls. As a lessor, what steps do you have to take to ensure the tank car is compatible with the intended lading the lessee uses the tank car for?
Very similar process. Sometimes if they're the owner, they would have to go through the 4-2. Ultimately, it's their responsibility to do it, but we'll go through the same process if they're wanting a new car to lease with, to make sure the compatibility, same as a new build.
And I think you just touched on it, but who is ultimately responsible to ensure the equipment is compatible with the lading?
The shipper.
Thank you. My next few questions for Mr. Dorsey. Can you explain how the AAR's approval process or approval review process ensures, if at all, that the service equipment is compatible with the type of lading service?
So you're asking about the material of the service equipment. So the approval of the service equipment is the approval of service equipment to operate in the rail environment. We rely heavily on the shipper to select materials compatible with their particular lading, as you just heard, with vinyl chloride being a single product that the rail ships, that is shipped by rail. And that even something shipped with the same name can have very different properties depending on its particular condition. We rely on the shipper to select materials that are compatible, and then they use an approved design. So we do approve the design, but the materials of construction, we have to rely on the shipper.
So that actually leads into my next question. Would the approval process be better if the equipment selection is not left up to the customer to determine what service equipment is appropriate for the lading?
I would, so I can't imagine that it would, because the shipper is the only one that knows the specific commodity interactions and the loading conditions, because sometimes the loading conditions will change the materials that you should be using for service equipment. And I would have no idea to know how their particular loading process is going to work.
All right, thank you. And that is all for my questions. Turn it over to Mr. Stansel.
Yes, I just circle back to the discussion on aluminum protective housing covers that I had discussed a little bit earlier with Ms. Stegman. Mr. Schoonover, would you tell us about PHMSA's safety advisory regarding the use of aluminum protective housing covers?
Yes, sir. Thanks, Mr. Stansel. We issued the safety advisory when we became aware that there were aluminum protective housing covers involved in this incident, and that and seeing the behavior in the fire environment caused considerable concern for us, that they may have in some way impacted the either the operation of the equipment that it was meant to protect, or also change the available options that people would have had. So, you know, if you think there's a couple of issues we had with it. One was, you know, that as soon as the because of the low melt point in a pool fire environment, the aluminum melted. It may or may not have gotten in the valves. We didn't know at that time. It may have impeded the operation of the valves, but certainly, and we didn't cover it in the rulemaking and the safety advisory. But you know, in the back of our minds, looking at the pictures we had, the hand wheels and the other aluminum components with that low melt point, it can have an effect of causing the responders to make decisions because of the perceived difficulties in doing things like transloading and others. So we wanted to raise that awareness for the community.
So, Mr. Dorsey and Mr. Schoonover, so the RSI estimated there to be more than 8,200 pressure cars in service with these aluminum housing, protective housing covers. What do you think should be done with that existing fleet? I'll go to Mr. Dorsey first.
So the way that would work is, of course, we'll take that information into the Tank Car Committee and we'll open up a discussion. As I mentioned before, the Tank Car Committee has builders, leaseholders, and we also have shipping organizations that have access to chemical experts. But we'll get together and we will discuss a path forward to ensure that the cars are as safe as they can be in transportation.
Mr. Schoonover, would you like to add to that?
Yeah, I'd like to add that we're watching what the industry does, and if we need to take action, we're going to take action because we feel compelled that it's an issue that needs to be addressed.
Okay, thank you. And Mr. McKissick, are there any cars currently being built in service, pressure tank cars for flammable material service that use aluminum protective housing covers?
Thank you for that question. I am not aware of any, but I thank you for clarifying that question, that aluminum covers for flammable liquid service. A large number of these aluminum covers that we've looked at are not in flammable service. There's a lot of them in acid service, and there are quite a few of them in carbon dioxide cars as well. So I just wanted to make sure that that's understood. They're not all flammable liquid or compressed gases.
Thank you very much. And that's all the questions the technical panel has for this panel.
Filling in momentarily for the chair, I will ask Mr. Allen to read his follow-up items that we'd like to have for the record.
Thank you, Mr. Vice Chairman. We have one new exhibit from today.
Ben, yeah.
Thank you.
Thanks.
It sounds really loud to me. I believe earlier or yesterday, someone asked for the response from Norfolk Southern to the FRA administrator. That has been provided. That is now Exhibit M, as in Mike, 11. It's the reply from Norfolk Southern dated November 11th, 2022. As far as information requests from today, there are 3 for Norfolk Southern. The first is to provide information on the actions taken by the Norfolk Southern Dispatch Center following the train conductor's request at approximately 9:27 for permission to move the locomotive 1 mile from the derailment site. Specifically, we're looking for whether anyone at Norfolk Southern informed first responders or the town of East Palestine that Norfolk Southern employees were moving 1 mile from the derailment and fire, and if they did, what time was that communication made? Second, we've asked for a copy of the Norfolk Southern Mechanical Department's quality standards. And third, we've asked for Norfolk Southern's plan for reducing defects. For the AAR, there are 2 requests. The first is all research conducted by the Wheel and Bearing Committee. And the second is the total cost to purchase a complete set of the AAR regulations. And that concludes it. Thank you, yes. And for PHMSA, the number of DOT 111 tank cars that have breached and caught fire in the last 3 years. That concludes the info request.
Thank you, Mr. Allen. And that concludes panel 4. On behalf of my fellow board members and the NTSB staff, we extend our appreciation to the participants in this hearing. I want to thank each of the witnesses for their testimony and the parties for their cooperation, not only at this hearing, but through the investigation. In the past 2 days, we've shed important light on the facts and circumstances of the February 3rd derailment, all of which we'll consider in our final report. We look forward to completing our investigation and sharing our findings in the coming months. The record will remain open for additional materials that were requested during the hearing. The transcript will be made available to the parties and witnesses electronically within 7 days, Any corrections to the transcript must be sent to the hearing officer, Stephanie Shaw, by Monday, July 24th, 2023. The archive of the hearing webcast will be made available on the NTSB YouTube channel. The transcript of the hearing and all materials entered into the record will become part of the public docket, along with additional exhibits enumerated a moment ago by Mr. Allen. In closing, I'd like to extend the board's gratitude to our colleagues across the agency, starting with Ms. Stephanie Shaw, our hearing officer. You did an excellent job. Great job, seriously. And I also want to thank our investigator in charge, Ruben Payan. Great job, Ruben. The board also extends its appreciation to our colleagues in the following offices, starting with the Office of Railroad, Pipelines, and Hazardous Materials Investigations. Great job, everyone. Really great job. Office of the Chief Financial Officer, Office of the Chief Information Officer, Office of the General Counsel, Office of the Managing Director, Office of Research and Engineering, Office of Safety Recommendations and Communications, the Office of Equal Employment Opportunity, Diversity and Inclusion, the Office of Administrative Law Judges, the Office of Aviation Safety, and the offices of Vice Chair Landsberg and members Graham and Chapman, as well as my team. I also want to thank the Federal Protective Service, the East Palestine Fire Department, the East Palestine Police Department, the East Palestine School District, Columbiana County Sheriff's Office, the Ohio State Highway Patrol, the American Red Cross, the Salvation Army, Principal Sarah Dutton, and Janice Cartwright, who serves as secretary here, and Mark, Angie, and the full custodial staff. Finally, but most importantly, I want to thank the entire community. Could those in the community who are still here stand up? Yeah, even if you're a law enforcement officer, please. And two 12-year-old twins who stuck it out through the last 2 days. And so I just want to thank you. This hearing was for your community, and I can tell you that you all have been so kind to us while we have been here. You have our gratitude, and we will consider East Palestine a home for us, as I hope you will come visit our labs in DC one day. So it's our hope that this hearing and our subsequent investigation report will yield recommendations which, once acted upon, will prevent future derailments and hazmat releases from harming communities like East Palestine and its neighbors. We stand adjourned.